Good morning. Thank you. On behalf of the USD Center for Music, Brain, and Society, the Brain and Creativity Institute, and our collaborators, Renée Fleming and LA Opera Connects, it is my great pleasure to welcome you all to the Science of Music and Learning, Health, Education, and Policy. Thank you all for joining us today, for braving the LA traffic and all the closures around campus. We are delighted that you are here. We are especially grateful to our speakers, panelists, community partners, artists, educators, policymakers, healthcare leaders, funders, and researchers who have traveled from across the country and Canada to be here with us today. This symposium was created around a simple but important idea that music is not merely a cultural activity or artistic pursuit, but a powerful human experience that intersects with learning, health, development, communication, well-being across the lifespan. Over the past 2 decades, research in neuroscience, psychology, education, medicine, and public health has generated an extraordinary body of evidence demonstrating the ways in which music can shape our brains, our behaviors, our community, and our quality of life. At the same time, many questions remain. How do we translate this knowledge into educational practices? How do we bring it into healthcare systems and communities? How do we communicate findings responsibly with the public? And how do we ensure that scientific discoveries ultimately improve people's lives? Today is designed not as a traditional academic conference, but as a working conversation among individuals who approach these questions from different perspectives. Our goal is to learn from one another, identify opportunities for collaboration, and think collectively about where the field goes next. Before we begin, I would like to acknowledge and thank someone whose vision, leadership, and commitment to this work have helped make today possible. Renée Fleming is, of course, one of the world's most celebrated artists. Over the course of her extraordinary career, she has inspired audiences around the globe through her art and her contributions to music. What is perhaps equally remarkable is her commitment to advancing the science of music and health. Through her leadership, advocacy, and ability to bring together researchers, clinicians, educators, artists, and policymakers, Renée has played a transformative role in elevating public awareness of the growing evidence connecting the arts to health and well-being. Many of us in this room have benefited from her curiosity, generosity, and unwavering belief that science and the arts are stronger when they work together. It's been a privilege for me to collaborate with her and her extraordinary staff for this symposium, and I'm deeply grateful for her partnership and friendship. Please join me in welcoming Renée Fleming.
Thank you, Assal. That is an incredibly warm introduction. My goodness. I'm excited to be here in our 3rd annual gathering at USC for the Science of Music and Learning, Health, Education, and Policy Symposium. In years past, this has been a productive space for conversations on how to move the field forward. This work becomes more important every day because of cuts to vital social services, education, healthcare, and the increasingly challenging economic landscape nationwide. We've also seen many changes over the past year in institutional support with research funding cuts at the NIH and NEA. And on a positive note, we've continued to build momentum and even launch new initiatives. We're in the 3rd year of the Renée Fleming NeuroArts Investigator Awards, created in partnership with Johns Hopkins and the Aspen Institute, funding research by pairs of early career scientists and artists working together. To date, we've given $600,000 to 26 teams of researchers over 3 years. And very exciting. And we just announced the latest cohort and are thrilled by their diverse projects and unique perspectives. So one of the researchers from the second year is from USC, Akila Kadambi. She's going to be featured alongside Ann Previn, her co-researcher, at the LA Arts and Health Summit tomorrow. Please be sure to see them there. And another project I'm developing is a new PBS series in collaboration with Susan Meg Salmon and Ivy Ross, authors of the book Your Brain on Art. You all know them. In addition to the research benefits for healthcare, we'll make the case that creative expression should be viewed as a pillar of flourishing in the same way that nutrition, sleep, and exercise are understood as crucial to our well-being and health. And in more good news, the Foundation for the National Institutes of Health have announced major fellowships to fund established scientists studying music's impact on health, probably the brain mostly. Initially, the brainchild of Dr. Francis Collins at the NIH, these fellowships will come to fruition via this private funding approach. So we're building the pipeline of research at an incredibly important time, from the early career NeuroArts Investigator Awards to the established FNIH fellowships. USC's own Assal Habibi is going to chair the Scientific Selection Committee. We're so thrilled to have her on board. And later today, you'll be hearing from a member of the FNIH, Kevin Klock. Where are you, Kevin? Yay. We can tell you more about the policy. And Emmeline actually runs all of the investigator awards, and we're delighted to have her. Oh my gosh. Emmeline Edwards. So this is an intense time, obviously, full of change and uncertainty. The discoveries being made every day give me so much hope. All of us in this room understand the power and potential of the creative arts. We've seen the benefits for people with dementia or Parkinson's disease, for children's healthy development, and for everyone's trauma, anxiety, and depression. And we know we're on the right path. Thank you all for your dedication, and I look forward to learning from you all today. And with that, I will turn it back over to Assal.
Thank you, Renee. I am also reminded to remind everyone about the Wi-Fi. USC has guest Wi-Fi, so you can all get connected to that. We should have signal in this room, or also EDU room would work as well. We will now begin our first session. What do we know now? Where are we headed? This session will explore current findings and emerging directions in the science of music, learning, and development. I would like to thank our session chair, Vani Dewan, and all of our speakers for helping us begin the day by examining where the evidence currently stands and where the next generation of research may take us. Vani, floor is yours.
Hi, everyone. I'm so excited to kick off our first panel of the day. My name is Vani Dewan, and I'm just finishing up the first year of my PhD at the Brain and Music Lab. I was introduced to the field of music cognition through a summer internship in 2019 at the UCSF Sound and Music Perception Lab, where I worked with Dr. Charles Lim and Dr. Karen Chan Barrett, who you'll hear from later today, to study musical improvisation. I got to craft and publish an fMRI case study on Zakir Hussain, one of the foremost Indian classical musicians of our time. This was also around the time that they started the Sound Health Network in collaboration with the National Endowment for the Arts. So I started to get a sense of the ecosystem of researchers doing this amazing work. I kept finding myself drawn back to music cognition. So I'm so excited to be doing my PhD with Assal and working on this exciting work for the next few years. Our first panel is called What Do We Know Now? Where are we headed? An exploration of current findings and emerging directions in the science of music, learning, and development, featuring some incredible researchers. First, we'll hear from Dr. Haley Kragness from Bucknell University, who studies the cognitive origins and social impact of music engagement across early life. Second, Dr. Chen Rabinowitch from University of Haifa, who studies how musical interaction and interpersonal synchrony shape children's social and emotional development and capacities. Third, Dr. Stephen Holochwost from the City University of New York, who examines socio-emotional development in early childhood with an emphasis on self-regulation, and also conducts applied work to examine the potential for early interventions. And finally, from Dr. Miriam Lense from Vanderbilt University, who investigates the intersection of human musicality with health and development, with a focus on children with and without developmental differences, as well as their caregivers. Each of their talks are 15 minutes long and will hold all questions for a 10 to 15-minute panel discussion after all 4 of the talks are done. Or you can find them and ask them at lunch. I think many of us likely experienced formative experiences with music growing up, whether that was taking the plunge to audition for a solo for the first time, or the frustration and gratification of practicing every day for an upcoming concert. And to this day, not all kids have access to music education in this way. So these researchers will present on how these experiences can fundamentally change a variety of outcomes during development. I'll call Dr. Haley Kragness to come present first.
Thank you, Vani, and everyone. I'm really delighted to be here with so many familiar faces and also some folks that I have recently met or am yet to meet. And so I'm excited to share today with you. So we know that music is woven into our early lives. Right from the beginning, right? So from early days of life, caregivers are regularly singing, talking in a sing-songy way. We get musical input from so many toys around us, right? So really early on, we're getting a lot of musical exposure. And we know that by 6 months or even earlier, many of the foundational building blocks that are required for music perception are starting to come into place. So we know that even the infants at this age can discriminate between pitches and between rhythmic variations. They have sensitivity to beat and tempo, right? And so these foundational music perception abilities lay the groundwork for a subsequent sort of smorgasbord of musical activities that we can participate throughout our lifespan, which ranges from, formally engaging in music, such as a life of a professional orchestra musician, to singing Sweet Caroline at your cousin's wedding, right? Okay, so I think today we'll hear all about the great potential for positive cognitive, social, and emotional impacts that these activities have for people throughout the lifespan. So given that potential for positive impact, for me, a question that I've been trying to understand in my research is what factors shape the extent to which someone participates in music or engages in music at different points in their life. Right? So what is driving someone to participate or not participate? I'm a developmental scientist, and we can think about development in this sort of lens up here. We can think about an individual as being situated in sort of proximate contexts like their parents or their school, and in sort of more distal contexts like their social environment or their cultural context. And we can think about how throughout development, the individual and the context shape each other, right? It's a bi-directional relationship. Your context brings to bear on you and you bring to bear on your context. One way we can see this kind of interaction between the individual and the environment is through an example I have here for you. So a few years ago, Swati Swaminathan and I ran a study where we measured children's perceptual abilities as related to music, so their abilities to detect differences in melodies and rhythms. And then we followed them over the next 5 years and looked at what musical experiences they subsequently had. And children who had relatively good melody and rhythm perception abilities were those who ended up going on to take the most subsequent music lessons, right? And so I think this illustrates the idea that they're shaping the sort of environmental context that they're then subsequently exposed to. I'm not the only one looking at these kinds of things. Of course, many researchers have found, there are genetic components to this. If you are relatively old for your cohort, that relates to how much musical exposure you have, your personality, cultural context, we can go on. Right? Okay, So one factor that I've been really interested in recently, and that I think might be an interesting target for understanding this, is musical reward. This essentially refers to how pleasant or enjoyable you find music. And we know from now a very large literature that adults vary a lot in how much they report deriving pleasure from music. We currently, the gold standard is the Barcelona Musical Reward Questionnaire, which asks people things like, when I share music with someone, I feel a special connection with that person. How much do you agree with that? And then we can break down their general reward response into these different categories: social reward, sensory-motor reward, mood regulation ability, all of these different factors. And we can see that this is data from Nick Kathius and Psyche Louis. On the y-axis, that's their total musical reward score of a large sample of adults, and people vary a lot. So some people say that they don't derive much pleasure from music, while others derive, hyperhedonia, a lot of pleasure from music. And I'll draw your attention also to this blue quadrant. So these are folks who say that they don't derive much pleasure from music, but they do derive pleasure from other things like food and sex, right? So their lack of pleasure in response to music is selective. We call those folks musical anhedonics. And now musical anhedonics have been well studied in adults at this point. I think sort of fascinating. Hard for some of us in the room to understand that experience, I think. Okay, so what we wanted to understand was, what is the shape of musical reward across the developmental trajectory? So my collaborator, Amy Belfi, and I wanted to know if we could adapt that BMRQ to measure individual differences in musical reward in young children. And if so, could we identify children who had a profile that resembled that specific musical anhedonia? Okay, so what we did was we asked parents to report on their children. We adapted the BMRQ, and we asked them we sort of adapted each of the items to apply to your child instead of yourself. So instead of asking, when I share music with someone, I feel a special connection, we asked, when my child makes music with someone, they appear to have a special connection with them. So they're evaluating their children's response. And then I mentioned for musical anhedonia, we want to make sure that their lack of pleasure is in response to music and not generalized. So the way that we looked at that is by using a temperament scale, the CBQ, Child Behavior Questionnaire, and we specifically looked at the negative affectivity scale. So that measures just sort of generally how much their kids respond to things with pleasurable or more fussy responses. Okay, so what did we see? So this is a distribution of typical BMRQ scores in a sample of adults. So this is from the original Macerero study. So what did we see with kids? Okay, so, there it is. You'll notice that the x-axis is a little different. Some of the items didn't perform as well, right? So those are omitted, so that's why that's happening. But we can see that the general shape is pretty similar. We have this long sort of left-hand tail, right? Identifying potentially folks who are not getting as much reward from musical experiences. You might be saying, okay, well, 3 to 7 years old, that's, really different developmentally. Were there changes with age? And there were no changes with age. So no correlation whatsoever there. Okay, our next question: could we identify children who fell into this sort of profile of musical anhedonia? So again, this is the Nick Kathius data. They identified about 6% of their sample as being musically anhedonic. For us, we identified about 8% of kids in our sample whose parents reported they did not receive much pleasure from music, but do respond pleasurably to other stimuli, seem to have normal pleasure responses other than that. Okay. So what about those different contributing factors that I talked about before? The BMRQ traditionally has these 5 sub-factors. So we did a factor analysis. And what we found with the CBMRQ was that the mood regulation and emotion evocation subscales were relatively preserved. And the other subscales tended to hang together and load onto a more generalized, what we might call a musical engagement subscale. And I'll also note, we saw this interesting phenomenon where the dancing items and the singing or humming items, the vocalization items, diverged from each other in the sensory motor reward, which other people validating the BMRQ and other populations have also seen something similar to this. Okay. So far, we've learned that we can observe substantial individual differences in musical reward early on, at least in parent-reported responses to music. And some children seem to have a profile that looks like it reflects something like musical anhedonia. The factors that contribute to musical reward are somewhat consistent between children and adults. But we also see this more less differentiated response, right? And that leads to all sorts of questions about what might be happening across development. So one way we might think about this result is that certain factors become more or less prominent in their contribution to musical reward over the lifespan. So for example, I think a really reasonable prediction might be that social reward becomes really important in adolescence. Right. So we're trying to understand now in our ongoing work how stable or how unstable musical reward might be across childhood. So we're doing this in 3 ways: with longitudinal work, retrospective work, and also with hopefully with baby work as well. So I have this is new data for you from just a couple of weeks ago. Our original participants reported on their children in 2023. So now in 2026, we reached back out to them and we got about half of them to respond again. So our plot over there is plotting their musical reward total scores of 2023 versus today, a couple of weeks ago. And this is what we see is relative stability, right? So the kids who are sort of on the most extreme ends tend to be pretty stable across time. This is the only data from that data set that I've looked at so far, so more to come on that. With Psyche Louis, we're working on a retrospective musical reward questionnaire. So asking the same person to think about themselves right now, themselves as a teenager and themselves as a child, and we can examine stability over time in the same individual in this way. These are our pilot data, so more to come there. And then circling back to where we sort of started, we talked about how even early in life, babies are exposed to a lot of music and responding to music. I do a lot of baby work in my lab. And so I observed that parents have all kinds of things to say about their children's responses to music. And so, for example, some people say things like this: he bounces to music, he calms when I sing to him. They have a sort of strong idea that their kid is already showing reward responses to music. Other people say things like, I have no idea if my child likes certain songs. He moves his body at times, but it's not often, right? So these are sort of implying that there might be these really early emerging differences in reward responses. Another line of research that I'm not talking about today is about baby dancing. I'm really interested in baby dancing. And we see again and again when we do dancing studies that the more babies dance, the more they tend to also smile in response to music. So those two behaviors tend to go together. So stay tuned for more on that. Okay. So I hope that we've sort of started to add more pieces to this puzzle. In addition to all of these previously researched factors, I think musical reward is a really important target that we're trying to understand. I'll just briefly, since I have, I think, another minute, I'll talk very briefly about another line of research that I think could be really important and that we're trying to understand in my lab, which is children's and adults' beliefs about music, what they think is involved in being involved in music. So one line of research that I'm doing asks parents or adults and children about where they believe different types of musical abilities come from. So we have interviewed 5-year-olds and asked them all kinds of questions like, what makes someone have good rhythm? What makes someone a good singer? Here's some examples of their spontaneous responses. One kid said, they have good rhythm because they practice a lot. Another kid said, God gave them a voice to sing, but some people don't have that. And you might imagine if you have these two different beliefs, that might lead to different willingness or different optimism and different willingness to engage in those behaviors. So I hope that by trying to understand these factors, we can start to better understand how we can implement music to support children cognitively and socially, emotionally as they develop in their early childhood. Okay, thank you very much, and look forward to chatting with you.
All right. Thank you very much. And thank you for being Assal for the invitation. I'm really happy to be here and to talk and meet everybody here. Today I'm going to talk about music, synchrony, and social connection. And the question that I've been asking myself since, I guess, forever is, as a musician myself, as a flautist, how can music enhance social connections? And I started exploring this by looking at musical interaction. And my lens of looking at musical interaction is not formal musical training or professional playing, but really some kids taking pots and pans and just jamming together. And you can take it to extreme kind of large scale levels. I've had two experiences in the past couple of years, going with my daughter to a Taylor Swift show. Okay. And I started exploring this question by doing my PhD study on kids in the UK, and I created this program, a musical intervention program, where they played games that were supposed to enhance emotional empathy. For example, imitation games where they would imitate each other's movements and musical phrases. Games that had to do with attention to the other, really focusing on the other and not on themselves. And games that were very synchronous, rhythmic, making rhythms together at the same time. And I'll show you a very quick example of a game where I asked them to have a question type of game. This is what we were doing in 9. So it was a lot of fun, and except for the music group, I had a control group of kids who only who got storytelling and drama instead of music. And as you can see, empathy was higher following music in this study specifically. And then because I was firsthand witnessing what was going on in the groups musically, what I noticed most was that interpersonal synchrony, just being in time together, was really important. And I kind of focused on that for a long time now. So as I said, interpersonal synchrony is also when you sing together, 2 or more people who are in time together. It can happen when you sing, when you walk, when you talk to your baby, when you dance, and when you do sports. So interpersonal synchrony is prevalent everywhere, right? Not just in music. So I started exploring this phenomenon specifically, and I started off with this study at the University of Washington where I had 4-year-old children who did not know each other come into the room to swing together, an everyday activity we do all the time with kids. And so we had 2 conditions here. One was swinging together at the same time, and the other was swinging not together. That was the only difference between those 2 conditions, the timing. And I was interested in looking at their cooperation. Would it be different after synchrony than after asynchrony? So we took these steps where they had to pass envelopes from one bucket to the other, and here we measured encouraged them to do that. And as you can see, the kids who were swinging in synchrony were faster in this task when you compare it to kids who were asynchronous or kids in the baseline group, which were kids who just came into the room and they didn't swing at all, they just did the task. So already you know that synchrony enhances cooperation in 4-year-olds. And we took it a step further because we wanted to know what's the mechanism behind it, or what does it take for synchrony to enhance cooperation? Do we need to have all of the information? Do we need to see facial expressions, smiles, or is it enough for us to know that there's something out there that's doing the same movement like us? Maybe that's even enough. So we put this barrier between the children, and it's a translucent screen. You can see a silhouette of the person beside you swinging, but you don't know anything about what's going on socially with them. Are they happy? Are they sad? Are they looking at you? You have no idea what's going on. And what was interesting was that we were able to replicate the effect. So the synchrony translucent condition was substantially more cooperative or enhanced cooperation more than the asynchronous translucent condition. So we know that it's a strong effect. It's persistent. Synchrony can enhance cooperation just by knowing that you're in synchrony with someone. That's it. My PhD student also did a study with young adults on the autistic spectrum, where she created this physical training, which was non-sync or sync. And also here we measure cooperation by asking the adults to pick up tokens and measure their step rate. And again, following synchrony, they were faster. They did more steps towards picking up those tokens, that they had more motivation to cooperate following synchrony. So we know that interpersonal synchrony enhances cooperation. And now I'm venturing into this kind of interaction quality aspect of it. My PhD student is where she can with another child who is on the autistic spectrum in synchrony or in asynchrony. So they get this feedback when it's not synchronous, the music is different. So they get this feedback from the music as well as the movements of what's going on, whether they're in synchrony or not in synchrony with her. This is especially good because it was really challenging to have children on the autistic spectrum actually doing discrete movements and tapping in synchrony. So this has really been successful in terms of actually operating interpersonal synchrony. And we were looking at shared attention. Kids who were in synchrony had more shared attention following synchrony. And also we were looking at other types at their perceived interaction. How did they perceive the interaction? Did they like it? Was it enjoyable? What do they think about the experiment? And their perceived empathy towards the experimenter. So all of these were enhanced following synchrony when compared to asynchrony. So summing up this section, there's another study also looking at discrete, non-discrete synchrony here, where we had the joint painting procedure, which was either in synchrony or in asynchrony, where kids watched both excerpts and we asked them questions about how they perceive these two instances of interaction. And overall, they associated more empathy and closeness and similarity and a better quality of interaction overall between the dyad in the synchrony condition. So I hope, another study. This is a study of my postdoc Noemi, who was taking students. And it's a longitudinal study, but this is part of it where we had them dance together. We computed the coherence level of the dancing, how synchronized is the dyad. And then we kind of look at the correlations between that and the CIB, which is the coding interactive behavior between the mother and the child, and found many, many different correlations. For example, the more synchronous the moms, the dyad are, the more the child joint attention level goes up. And the more synchronous the dyad is in the dance, the more dyadic
reciprocity we see between the dyads. So I think I can sum up now that the quality of interaction is also enhanced or is associated with interpersonal synchrony. There are more studies that I did that looked at closeness and similarity. Closeness and similarity are enhanced following synchrony, as well as positive valence, just feeling good. So I'm not going to go into details of these now. So I have some ongoing experiments, ongoing work in my lab. I like this one especially. This is about moms at risk or family at risk with their babies. And we're doing music therapy work and longitudinal music therapy work with them, looking at their brains before and after. And this is just an example of my student Shai. We're looking at skin, we're looking at speech to them, and trying to kind of strengthen their Okay. So I think I hope I managed to show you that there's a lots going on that shows connections, positive effects of interpersonal synchrony. There's in-group effects, out-group effects, there's even self-effects. So there's a lot going on. But, and there's a but here. Do you remember that stadium singing in the Premier League in Manchester? I don't know if you've been in these games, but this often happens after the game. There's two groups and they're very emotionally, sometimes these things happen. And there's not many things that look at the negative effects of interpersonal synchrony or what's going on when things are really, when people feel very connected to each other, maybe because of the singing. And I've been starting to think about the dark side of synchrony for quite some time now. And there are very few studies that talk about how synchrony might cause aggression towards outgroup members, as in the picture that we saw, enhance blind obedience, and reduce creativity and reduce group dissent. And this is really interesting for me to look at the other side of the coin too. And it's exactly this highly cohesive intensity that might just take a wrong turn when it comes to synchrony. It's very cohesive, it's intense, and I think we need to really try to understand interpersonal synchrony so well to be able to know what the best and optimal ways to use it. And this is what I've been trying to do in my lab. This is ongoing work of groups of adults who are doing synchrony and asynchrony interactions in the lab. And I'm looking at cooperation, but I'm also looking at their blind obedience here, trying to kill bugs and their group dissent levels. I'm also doing this experiment with children, playing either in synchrony or in asynchrony. This is ongoing work in my lab at the moment, looking at the positive effects that could be coming from this and their blind obedience, as well as their group dissent. So all of that together to see what the picture is and what possible balances could be done here. But the interesting thing is that coming back to music, after I actually kind of left it for many years, because I think, I don't know how much time to get into it, but I think music is the different song. It's not introduced to synchrony, and the looseness that it allows, especially in improvisation and creation, where everybody can be still an individual, but part of the group. I think that especially the improvised music recognition might give us what I'm looking for, which is higher social cohesion, higher cooperation, higher sense of individuality. That's why higher group dissent, low blind obedience, because individuality is high, right? And cohesiveness is high, but not as high as in interpersonal synchrony, and therefore less outgroup aggression. So that's my hope. And with that, I'm going to finish. I think we should continue to do what we do, which is to fine-tune the effects of music and synchrony for both typically developing children as well as for clinical populations.
continue to do what is being done here and in other places, which are real world implementations of all of this basic science in the lab. And of course, continue to understand what's going to be sustainable and how do we sustain these effects after we implement it for it to continue to have effects. And of course, strengthen collaborations between researchers, practitioners, and policymakers, exactly as in these types of events. Thank you very much.
Okay. All right. Thank you so much for having me here today. So just to get right into it, for personal reasons, I'm particularly sympathetic to arguments for the benefits of music education for children's learning and development. I earned a PhD in music theory and composition under the tutelage of the late, great Charles Warren prior to pursuing my PhD in developmental psychology. And for reasons that I can assure you have nothing to do with money, I continue to compose. But my personal sympathies aside, many people have argued that certain types of music education might foster children's capacity to engage in volitional processes of self-regulation, the skills we use to set and pursue goals, both small and large, as we navigate our lives. One set of those processes are referred to as executive functions. They include working memory, the ability to hold information in mind and manipulate it, inhibitory control, the ability to inhibit dominant behavioral response, and cognitive flexibility, the ability to shift attention to meet changing situation demands. So if we think about music and just take one example, and consider how a child's experience in an ensemble rehearsal may exercise their cognitive flexibility. You think about what's going on a moment-to-moment basis. A child shifting their attention from their music to their conductor, back to their music, hopefully to their stand partner, maybe not, back to their music, and so on. And that's happening moment to moment, right, day after day. And I think you could make equally plausible arguments for how working memory and inhibitory control would be advanced in such a setting. Now, what's interesting is despite that compelling rationale, there have historically been two big limitations in the research literature examining the benefits of music education for children's learning and development. First, there have been issues of internal validity, much of it rooted in drawing causal inference from correlational study design. But the other is that the relatively small number of studies that have used randomized control designs to examine the benefits of music education tend to suffer from limitations of external validity. And the reason for that is because, like many educational opportunities, the opportunity to study music is distributed inequitably as a function of income. Less affluent students are less likely to have access to music education in school. Ken Elvis has done a tremendous amount of work on that topic. It's very compelling. They also have less access to music education outside of school. And so into that breach have stepped a lot of different community-based music education programs. And for the last 15 years, I've had the privilege of working with one of them called Play on Philly. And they actually allowed me, when I was still a grad student, to do a randomized control design in which we looked at the benefits of intense orchestral education, 90 minutes a day, every day that school is in session over the course of a school year. And we were able to demonstrate that being in that program caused not only positive changes that were fairly substantial in children's executive functions, but also in their academic achievement. As is so often the question, the case, the question is why, right? Why would that be the case that music education would have that effect? One reason that suggests itself when you view self-regulation from a biobehavioral perspective is children's neurophysiological function. So one of the clearest definitions of self-regulation from a biobehavioral, what did I do? Sorry about that. There we go. From a biobehavioral perspective was offered by Clancy Blair and Sibel Raybeard, who argued, quote, that self-regulation is a biobehavioral system that enables the primarily volitional control of attention and emotional arousal for purposes of reflective goal direction action. And they went on to define self-regulation as having top-down volitional component, like executive functions, but also being rooted in the bottom-up activity of involuntary neurophysiological systems. And in humans, there are 3 neurophysiological systems that are essential for self-regulation, because these systems together modulate metabolic output under conditions of homeostasis stress. They're the hypothalamic pituitary adrenal axis and the 2 branches of the autonomic nervous system, the parasympathetic and sympathetic nervous system. Now, the HPA axis is particularly interesting to think about when you're thinking about children inhabiting environments of higher risk. So the HPA axis, when activated, initiates a complex signaling cascade that causes the adrenals ultimately to release cortisol, which is a steroid hormone that acts as a catabolic agent. That has a number of different metabolism effects, one of which, or most notably, which is the breaking down of glycogen into glucose, so it can be released into the liver, into the bloodstream by the liver, providing energy. The activity of the HPA axis is particularly interesting to examine with respect to risk and adversity, because unlike the parasympathetic and sympathetic nervous systems, which respond very rapidly to stress, the HPA axis takes many minutes to reach full levels of activation. Now, for a species like ours, a species that can anticipate stressors, having a system that primes us for action in the face of stress is highly adaptive under most circumstances, but there's a catch. And that catch is, what if you inhabit an environment which you're always anticipating or experiencing high levels of stress? That is to say, an environment of high risk. In that case, our ability to anticipate stressors can lead to chronically elevated levels of HPA axis activity, and that can cause problems for children's development. As I said, cortisol is a catabolic agent. It can cross the blood-brain barrier. So it has the potential to get access to brain tissue and basically counteract the fundamentally anabolic process of early brain development. And that may explain, in part, the associations between elevated levels of cortisol and poor developmental outcomes. So prior research has found, for example, that the effects of poverty on executive functions are mediated by higher levels of cortisol. By the same token, if music education reduces or downregulates HPA axis activity among children in poverty, may help to explain the results we observed in the study that we conducted with Play on Philly. So that was all in my mind when I was interpreting the results of that study. And in fact, in that interpretation, I argued that part of the reason music program may impact executive functions is through its effects on levels of HPA axis activity. And just as I was writing that, this study came out. It was written by a colleague, Ellie Brown, in which she reported that attending an arts-enriched preschool program can lead to lower levels of cortisol among young children facing high levels of poverty. So when I saw that, I reached out to Ellie, and she and I started talking about the ideas that eventually became the Reach Lab, research on expanding equity through the arts for children. Unfortunately, that grant or that lab was defunded. But before that happened, I should have taken equity out. Before that happened, we were able to do some work. And so one of the studies that we did was to look at children's HPA axis activity in a music and movement education classroom. And we found 2 things. One was that children's HPA axis activity was lower when educators, particularly when the children were older, kind of got out of the way. So these are all preschool children, but slightly older preschool children. When the educators kind of let them do their thing, you saw a reduction in kids' HPA axis activity relative to when the teachers were more involved. And then also when teachers were more positive in their interactions with the kids, we saw for all kids, regardless of age, an effect of that on levels of cortisol. And the latter 2 of those findings was really interesting to me because it aligned with some work I was doing on another project where we were looking at the activity of another bottom-up system, the parasympathetic nervous system, and how that might be implicated in transmitting the benefits of early education to children's development. That project's called the Learning Emotions in Play in School Project, or LEAPS, which began as a small pilot and now is kind of ballooned into an R01. And beginning about 8 years ago, the team for that project and I started making the argument that if we could track children's phasic moment-to-moment parasympathetic nervous system in an early education classroom, that would provide us a lot of insight into how they're experiencing that classroom and ultimately how we might want to design early childhood education programs. And our recent findings from that study, LEAPS, indicate that just as was the case for the HPA axis, children's experiences in the classroom can indeed influence their parasympathetic function. So we found that when children engaged in more positive patterns of interaction, it's like the 5-minute thing. Am I there? Okay. All right, I'm doing okay. More positive, yeah, all right. More positive patterns of interaction with their teachers. Their parasympathetic nervous system activity increased. So then when we step back, we look across these two studies, the study in a music ed classroom, an early music ed classroom, and then a study in an early education classroom, we see parallel influences of positive teacher interaction on two different neurophysiological systems, such that in both cases, more positive patterns of interaction shift the activity of those systems away from configurations that support vigilance and defensive behavior and towards configurations that are ultimately more conducive to learning. With tremendous help, no, I wasn't going to mention it, but now I have to. With tremendous, I don't have a picture of it. Hold on, I do, but not with me. With tremendous help from Sunil, we created the Iyengar, what did I call it? The Iyengar 3000, 8000. It was a wearable, heart rate monitor. The problem with the cortisol, you just take saliva, you take saliva from the kids. The parasympathetic nervous system requires continuous. So that's a heart rate monitor, kid. They're very small, they're very expensive. So the kind that I could get with NEA funding was the larger non-internal storage kind, but that meant we had to put them on the kids. So we're trying to get data on parasympathetic nervous system activity in an early music ed classroom, and that's hard because NIH doesn't want to fund that. So we have been able to get money from NIH to fund just regular early education classrooms. But what we've observed is going back to the framing questions of what do we know, where are we headed? We appear to know that children, what they experience in the early education and early music education classrooms can impact individual neurophysiological systems that are essential to self-regulation. But we also know that those systems don't operate individually or in isolation. In fact, the parasympathetic nervous system, sympathetic nervous system, and HPA axis function in concert to mobilize metabolic resources to meet situational demands. The problem is that's hard to study. In some ways, it's hard to kind of conceptualize. So my colleagues and I proposed the concept of neurophysiological space as a heuristic to aid us in understanding young children's neurophysiological function in education environments from a multisystemic perspective. And the essential idea behind it is that any configuration of parasympathetic, sympathetic, and HPA axis activity can be represented in a kind of three-dimensional state space defined by relative levels of activity across those systems. But that certain patterns of activity are more or less likely to be observed in a child, depending on their immediate environmental experience, and such as their classroom environmental experience, and then their cumulative life experience. And so the next big step for us is to use that heuristic, figure out a way to get the Iyengar 8000 to work, also sample cortisol, and then look at how patterns of multisystemic neurophysiological function among children from backgrounds of higher risk may shift as a result of education, and specifically music education, and then to understand how those shifts may account, at least in part, for the broader benefits of music education for children's development. So that's where we are currently. And I'll just close by again thanking us all for the invitation, and then
All right. Well, thank you all so much for being here. Thank you, Assal, for the invitation. Thank you to my co-panelists. What an incredible symposium session to be a part of. My name is Miriam Lense. I'm from Vanderbilt, and I'm going to be talking about music and rhythm in social engagement in early childhood. I'm going to start by thanking the participants and their families, because we absolutely could not do this work without them, my colleagues and collaborators, and we've been fortunate to have funding from both NIH and the National Endowment for the Arts Research Labs program. So we're really grateful to be able to pursue this research with their support. So when I think about social development and the social environment, we know that social environment is really essential for supporting child development and learning, particularly really early in life. And when we consider that foundational social environment, it's really that relationship between a child and their caregiver. And we know that musical engagement is a really natural and ubiquitous part of the way people interact in these social experiences. So I'm going to give some examples of the ways we harness music and music cognition to understand and support social behavior, some mechanistic work with music cognition as kind of a window into understanding social communication early in life, and then share some examples of sort of applications of this work and applied in community settings. All right, so we've been hearing a lot in Tall, rhyming names, that's a whole other study. We're talking about interpersonal synchrony. So, critical to the social environment is really how we coordinate our interactions with other people. And early success in these coordinated interactions predicts more positive later outcomes in many areas like language, cognition, attachment. Well, how do we do this? Well, rhythm is a really good candidate for this. And we know that rhythmic behavior is really, really prominent in early infant-directed communication. So one of my favorite forms of infant-directed communication is infant-directed singing, which is universal. It's a multimodal form of rhythmic social interaction. I'm going to really stress the fact that infant-directed singing is not just sound, okay? There's effective facial expressions, there's gestures, there's physical touch, there's movements, and all of these are synchronized to the rhythmic structure of the singing. And we know from prior work that infant-directed singing serves to capture and maintain infants' attention. It also modulates their arousal levels and that of their caregivers. So it's like what's good for the gosling is good for the goose. Okay, I just worked that out, but something like that. Okay, so singing can provide a window into the development of social behavior. Yeah, you should always work out your metaphors ahead of time, I guess. Okay, so one approach we've taken is really focusing on this concept of synchrony, as Tall has discussed with us, or entrainment, because we know that promotes bonding, pro-social behavior, empathy. We had so many examples of that from Tall's work. So in a lot of our work, we ask if entrainment to the predictable rhythm of infant-directed singing supports infants' attention to really salient and meaningful social information, that of looking to a caregiver's eyes. We focus on eye looking because it's very early emerging. It's very highly conserved. Looking at someone's eyes lets us know what they're thinking, what they're feeling, what they're paying attention to. Can also increase neural coupling between partners. And I'm going to give you a number of examples from our research using eye tracking, which lets us look at the moment-by-moment attention patterns of infants as someone sings to them. So we can assess, is children's gaze to a singer's eyes modulated by the rhythmic structure of singing? So that is, the infants attend more to a singer's eyes, time-locked to the predictable rhythmic structure of singing, like the beats of singing. So we know we're having a little bit of audio tech delay, but I'm going to play you an example of the stimuli they see, and I'd like to ask you to try to groove along to this if you can. Let's see if it works.
Mary had a little lamb, little lamb, little lamb. Mary had a little lamb, its fleece was white as snow.
Okay, I'd like to thank Karen, who was clearly tapping along and grooving as instructions. So thank you, I appreciate that. So hopefully maybe some of you were doing that. But anyway, the infants really like it. Okay, I recognize you're not the target audience. Ecological validity of your stimuli, all right? Okay. So we started this at 2 months. 2 months, I think this is fascinating. At 2 months of age, infants are first showing clear signs of actively engaging with others in sort of socially meaningful and interactive ways. And that middle line there is the beats of the singing, what Karen was so nicely tapping along to. So thank you, Karen. And around time locked around the beats of the singing, 2-month infants are increasing their eye looking, right? They're more likely to look at the eyes, time locked to the beats of the singing as early as 2 months of age. I get it, it's not super precise. What were you doing at 2 months of age? Okay, so give it. You were doing this actually, it turns out. Okay, so then we looked at this again at 6 month infants, because by 6 months infants
are really highly experienced in face-to-face play. They're doing their own rhythmic behaviors like babbling. And by 6 months of age, we can see this effect is really substantially increased. There's a 4-fold increase in
eye-looking time lock to the rhythmic beats of singing by 6 months of age.
So this is really exciting to us. It sort of lays a foundation demonstrating a key way that rhythm and sensitivity to rhythm is modulating infant social behavior of eye looking. Now, of course, infants don't look for no reason. You know, you got to razzle dazzle them. So we asked, what are singers doing on the beats? And so we see that time locked to the beats of singing, the singers, the caregivers are also doing these really important social behaviors. So singers increase their wide-eyed positive affect, they decrease their neutral affect. Super hard to do those two things at the same time. You know, you could try. They also reduce their motion, so they still, and they actually inhibit their blinking, which means that their eyes are open for their infants to see. In follow-up work, we've shown that really early in life, infants are particularly reliant on the rhythmic structure, like those 2-month-olds really need that rhythm. And then with age, infants become more sensitive to these different sort of social communicative cues that are layered on top of the rhythmic structure. So if you combine these findings, if you see that there's rhythmically modulated eye gaze, you also see that the caregivers are providing these really important social cues, this suggests that through entrained rhythmic interactions, such as provided by infant-directed singing, that infants are optimizing their meaningful engagement, and they're also provided with really key opportunities for social learning. So it's a really powerful way you can use singing to support social development. With support from the NIH Sound Health Initiative, we've been fortunate to now expand this work into autism. So autism is characterized by differences in the timing and coordination of social behaviors. But despite these challenges in social timing, many autistic individuals still maintain preferences for musical and rhythmic stimuli. So we've repeated this experiment, that same eye tracking experiment I showed you with infants, but now with toddlers with and without autism, where they watch these videos of natural infant-directed singing. And what we can see is that entrainment effects extend into toddlerhood, both in non-autistic toddlers on the bottom and in autistic toddlers on the top. The effect is admittedly somewhat reduced in autistic toddlers, but we're still seeing that they are timing their eye looking based on the predictable rhythmic beats of the singing, which is really exciting. So then we've expanded this, and we also showed toddlers videos that were experimentally manipulated to reduce their predictability. So Karen and company, I'd like to encourage you to try to jam along to this stimulus. Okay.
Mary had a little lamb, little lamb, little lamb. Mary had a little lamb, its fleece was white as snow.
What's so disturbing is we watch so many of these videos in my lab that I was like, wait, is this unpredictable? Because I totally get this. Let me double check the stimuli. So we've totally ablated our sense of rhythm. Okay, so we show them videos where the rhythm is, Karen, you were doing a great job, but it's harder, right? Yeah, okay, thank you, yeah. All right. Won't make you listen to that again. So this is the graph I showed you before with autistic toddlers on the top row, non-autistic toddlers on the bottom row. In original singing, right, we see these really strong effects, particularly in non-autistic toddlers. But when we show them the jittered singing, you can see that, oh, I can see, but there we go. This is fun. I did async. We did studies of asynchrony too, but I'm not talking about those here. But the effect is reduced in both groups, okay? So that when you've removed that rhythmic predictability, you really impaired people's ability to time and coordinate their social gaze behavior. In new work that we've done, we've mapped this onto sort of predictive coding models in autism that shows that they're using some different mechanisms to underlie some of how they're dealing with the unpredictability. We've also expanded from eye gaze to look at looking at the eyes of others to just kind of how they're moment by moment attending overall to the interaction. And we see that as you increase the unpredictability, so as the singing gets more and more jittered, the autistic toddlers have a harder and harder time compared to the non-autistic toddlers in controlling their attention. Sorry, this is great. We're getting like surround sound cues. I felt like I was like on a pageant or something. I was like, oh, the judges put up their scores. Okay, so This overall suggests that song and rhythmic predictability support social engagement early in life, including in autism. And so this means that rhythm and song can provide a mechanism to support social and communication skills. So as one example, this is a large survey study we did in autism. Parents reported on their autistic children's musical engagement, social interaction skills, and expressive communication skills. And we see that children's sort of propensity to actively rhythmically engage in music, bounce to the beat, maybe the reward they're getting from it. This is all in autistic toddlers, is this little drum icon I got there, is correlated both with their musical interactions with their parents, but also their broader social interaction skills, using a sort of broadband measure of interpersonal relationships. And those actually provide independent conduits to children's expressive communication skills. So this suggests some possible paths by which rhythm and music can support language development in autism. Okay. A lot of work that we do in my lab also thinks about these broad principles through which music activities align with best practices for social interaction and social communication. I'm also a clinician. And so there are some of the principles we think about are predictability. We do a lot of examples for that, but also reinforcement or reward. We're talking a little bit about that. Emotion regulation. Oh, this is fantastic. We talked a little bit about that. Shared attention. We actually talked a little bit about that. Okay. And and also just these natural social play contexts. And what's really exciting is that these principles, these are what we often think about supporting social interaction in clinical populations. But I don't know, anyone who's a parent, raise your hand. Anyone who had a parent, raise your hand. Okay. Yeah. So these are just the best principles for positive responsive parenting overall. Like this is what you do to support that relationship. And then these principles are going to be in play not only for the child, but also for the parent. And so I think that promotes that music is really a natural platform to promote these types of positive parenting and positive interaction behaviors. So in one of our studies by the NEA Research Lab, we had parents and their preschoolers share either wordless picture books or songbooks. And we saw not only did children increase their engagement in the activity for songbooks, but parents look more at their children during songbooks than picture books. And in autism, their gaze behaviors, sorry, there's a little bit of delay, is aligned for the songbooks, but not the picture books, right? So songbooks are naturally creating a platform that are coordinating parent and child behavior and also just making parents available for social moments that may occur. We also do a lot of work combining sort of early evidence-based interventions and musical principles. So how can we kind of incorporate song and rhythm into play-based therapies and everyday interactions? We have a large study going on as part of our Sound Health Initiative project now in autism with a clinician in this intervention. But we also did a parent coaching program thanks to COVID, and we couldn't go, see the people. So what a wonderful opportunity to pivot. And so this program takes an evidence-based autism intervention called reciprocal imitation training, and we enhanced it with music. So therefore you get MERIT, which is a wonderful acronym, isn't it? So in the first stage principles that you teach parents to do in this interaction is to continually imitate their child and to describe their play. This way you can build children's social attention. It helps them know that what they're doing is meaningful, that you care about it, also gives them really good language input. So we taught parents to do this using music, and I'll play a little example here.
Oh, sleeping on the ground, getting up, and sleeping on the ground, and getting up, and sleeping on the ground, getting up and down.
You also get a really good when you imitate toddlers. Okay, so I don't have a lot of time, but this is to say parents were able to learn evidence-based intervention and increase their vocal musicality, which increases their sort of animacy and makes them really interesting to kids. Not to other parents, actually. You guys seemed pretty interested. Okay. We also do a lot of work with community-based interventions. We've developed Serenade, which is a psychoeducational parent-child music class program. Parents get they learn positive parenting strategies through music. They also get to discuss and connect with others. And I just like to share this sort of music class. Let me see, there's nothing we can't do from the family of an autistic child. And also it's truly been the best activity. We've tried family, which is where I say, give me all your money, right? Let us do this for families all over the place. So I'll just play end with a little clip of that music class. Isn't that such feel good, right? So what's amazing about this too is we have not, this is one of the autistic children here, we've not made the children stand up in this class. Like that's way too much pressure. But what's happened is that little pure child in the blue shirt, he loves attention, lots of social reward from music. And so he has sort of taken it upon himself when you say hello to him to kind of do the like, look at me thing and stand up. So the child's learning to wave and he's learning to do that. And you could hear like all that cheering. So like if you're a parent, oh my God, is that rewarding to hear everyone recognize that for your child? Okay, so final points. Music and rhythm are natural components of social interaction. Rhythmic opportunities provide foundational opportunities for social development and connection. And music experiences support children and caregivers. They potentiate ingredients of successful communication interventions. And I just want to thank you all so much for your time.
Thank you to all four of our speakers for those really excellent talks. We are now going to transition into a panel discussion. So we're getting our incredible chair bringers to bring the chairs out, and we'll call all of our speakers back to come take a seat. And we are also going to open it up to audience questions. So we have a mic that Jed will be floating around the room. So you can either choose to ask your question into the mic or you can project. There are wonderful acoustics in this room, whatever you prefer. So I am very lucky and I get to ask the first question. So really, really fascinating talks. And I thought it was such an interesting range of topics, all kind of under the lens of development. So my personal question was, I was wondering to what degree each of you take into account individual differences when you think about your research questions and how to interpret the results.
Sure. I'm thinking about that a lot. Yeah, I think this musical reward line of research that I've done is in my line of work among the first that I've really tried to understand individual differences, and it is showing to me how important that is because we see such a broad distribution of responses. Yeah.
When you look at a child's performance on a task of executive functions, for example, there's obviously a lot of variability among children and even within a child over time in their performance. But what you can see also is that two children who essentially have the same performance on that kind of cognitive behavioral task will recruit their neurophysiological resources in very different ways to get there. And so that's, I think, probably the perspective the individual perspective is most relevant to the work I'm doing now.
I think it's important. I not always I actually measure it or really kind of insert it into my design, but I did have a few studies where it's actually crucial. So the result changes. For example, I've had people come into the lab, they play this mirror game, and their level of self-esteem where they came into the lab, that really changed the way that the intervention was, what it was doing to them. So I think it's really important. Sometimes maybe we don't have enough time to insert it as part of the design, but it's important. Yeah.
Yeah, I think those individual differences are incredibly important. Certainly in our work with autism, I'm sure everyone has heard that, if you've met one person with autism, you've met one person with autism, right? So there's a ton of individual differences that we need to consider. And so it's always this balance of am I looking at something that I can see group differences on? And then within that, how can I understand the individual heterogeneity that's happening within that condition? I think it's going to be incredibly important for moving music health forward in regards to, personalized interventions, in regards to knowing who's the best fit for those sort of moderating factors. I would also a lot of the work we do in like our parent-child interactions, it's really important we measure individual differences, not just in the children, but also in the parents, right? So if they're going to be a facilitator of this, we can think, what's going to be happening with them. And we've seen individual differences in not just children's engagement with music, but also how much parents, what makes them likely to kind of engage in these types of musical behaviors. So you have to kind of look at both aspects.
Thank you. Alrighty, we'll open it up for audience questions and judges will bring the mic. And if folks could maybe just try to keep the question pretty brief so we can hear from all of our panelists. Thank you.
So thank you. So we heard about the individual cognitive effects of music training, and we heard about the pro-social effects of making music together or making rhythm together. I wonder if anybody can comment on the relationship between the two. To what degree being more pro-social can affect your cognitive, your cognition, and the other way around.
Well, I'll give you one way that I think about that in some of the work that I do, and which is that we learn through our social interactions and those experiences with other people. So one thing, for example, that we see in autism is that you get these sort of moment by moment differences in how if what you're interested in is something different than what other people are interested in experience, in a context and environment, then we're going to learn something different from that environment because you're attending to something different. And so one of the things I think that's exciting to us about this sort of rhythmic predictability and singing is that we can get people to look at the same thing at the same time, so we can sort of get some of that same information intake. We're really interested in, does that, what are you then learning from that? What's the reward experience you're getting from that? What's the information you're getting? And so, we don't have all that information yet, but we have seen that the amount with one diverges from, say, certain normative patterns of social behavior and social interaction is associated with other types of cognitive and language skill development, because you are getting different information from that environment. So that's one way in which they interact a lot, is particularly in an autism context.
Yeah, so I can project.
I'll just say also, like, we learn best when we are emotionally regulated. And so that's, I think, a big thing in some of the things and probably some of the schoolwork as well, right? So that, if you're too stressed, you can't learn anything. And if you're sleeping, you can't learn anything. So emotion regulation plays a big facet in our abilities to regulate, to learn.
Great talks, all of you. Thank you very much. Haley made an interesting point regarding the nature versus nurture. That some kids just seem to be more biased towards music and with music anhedonia and things of that nature. And so my question really is, the brain remains plastic throughout the life. And my question is, if I have an adult child, is it too late to sing Mary Had a Little Lamb? Or in reality, how can adults benefit from such? Yeah, exactly.
I mean, I think the earlier the better, right? But certainly lots of folks are doing really interesting work, even at sort of the last stages of life, right? In retirement and in seniors, showing that there still could be benefits of especially social musical experiences. So I would say, just to be brief about, is it too late? I think no, right?
Take it to the other end of the extreme. I was wondering, have you seen findings from the studies of in neonatal settings and in pregnant mothers or NICU settings that you think are relevant to, I don't know if there's been any longitudinal work that suggests how they respond in infancy or toddlerhood to music. And I don't know if that's been hooked up, that research has been hooked up. Any thoughts on that?
Sounds like an initiative for funding for a super long longitudinal study. Just gonna plant that out there. There are some very exciting studies. I don't know that they have shown us how long they've followed things out. And, you know, I think you run into some sample size issues, you run into some individual difference issues in regards to that. So I think we need some really, really large samples. There's certainly some really great studies in the NICU of, you know, music providing this sort of regulating environment that helps with feeding and growing and, God, that's the job of a newborn, right? So yeah, you grow. But we see that, and so that could, you know, when we think about those mechanisms by which like music could have those longer term effects too, right? Is that if it's promoting your sort of putting you in a state for that improved optimal development. I know there's been some recent studies that have tried to look at some really early like NICU interventions and then later outcomes, and I think they've been a bit more varied, like when they've tried to look at like toddler cognitive
and the reason I ask the question is simply because I mean, all this is the context of learning, of course, but I think there's tremendous implications, as you've talked about, for dosing and for understanding responsiveness to these therapeutic options too. So this is great.
Well, I think there's also some of those individual differences, like the things, you know, you, I feel like yesterday at dinner, we were talking about some of us of parents of adolescents were bonding and, you know, the number of degrees of freedom that exist in a child's life and the number of controls that you have as a parent in creating that environment and how they change. So I think some of those individual differences and sort of personalized trajectory approaches will be really important to kind of parse some of those things out.
Yeah, I just want to add, I think if you take, for example, Ruth Feldman's studies, she's not looking at NICUs, but she is looking at for very, very early caregiver-child interaction. It's music, you know, you sing or you talk, the prosody and how it maintains throughout the childhood and sometimes even into adolescence, looking at physiology, looking at psychopathology. So this is kind of what I can think of as more longitudinal in nature, this line of study.
Can I ask a question? Thank you all for wonderful presentations. The synchrony, and I guess maybe Tal, primarily you, and maybe Miriam and Haley, you, the synchrony through the pro-social behavior related to synchrony, how lasting it is. Because I can see people at a concert moving together, all like feeling the same, but then you go out and nobody's holding the door for someone else, or like it's not worse. And worse than that, right? Fighting. Your empathic traits don't seem to change. Is it something state, or is it some way to extend it?
It's a really good question. So I in my work, I've been trying to do both. So very short doses, right? 2 minutes, and it changes something right after. I don't know if it persists. I've been doing longitudinal musical interventions for children and now for babies and their moms and children. And I mean, it persists for the period and afterwards, but I don't know what more than that. I mean, it's really important to do sustainability studies and to see how it's sustained and how we can sustain it. And it's good. I mean, I think it's a capacity. I look at it as a capacity that we develop. It's like learning how to ride a bike. So we don't forget it right away. So I tend to think about it as a capacity rather than as something that we just do and then we forget about it. But of course, more research is urgently needed for that.
Miriam, I just have a quick question. I was surprised by the pitch, the voice of the young woman who sang Mary Had a Little Lamb. And because it seemed to go against motherese and all the things that we kind of understand about how children respond to voice with pitchiness and a higher pitch, generally speaking. Did you choose her on purpose and why?
I did not choose her on purpose. So that is one clip from a variety of videos that we have, and they certainly vary. We wanted to kind of get the array of experiences that children might have. And so if we only had like really good professional singers or, then that's not every child's experience in terms of their musical interaction. So I think we haven't looked at pitch. We have looked actually at in some new work at like spectral flux, which does include some, pitch related elements and how that changes over time. And we do see that also children visually, their gaze aligns and tracks with some of the changes in that spectral flux information. So I think it's a great question. We probably you're making me think like, oh, I should show a clip, but maybe the parent's voice is higher. But I think, I didn't choose it in that reason. We just kind of wanted to get a whole variety. I will also say our stimuli are not recorded with an actual infant present. And so caregivers so the person is portraying child-directed speech in that versus if there's an actual infant present, people will go to that higher pitched experience, which is like in the that parent and child interacting one. I mean, my gosh, her voice is so high when she's like singing about sleeping on the ground, right? Yeah. So just having the child there will help people. It will promote those things. Yeah.
Did anybody else wonder about that?
No one has ever asked about the pitch of her voice. And I'm gonna, that person is probably like 50 now. I don't know. So I'm gonna track her down. I'm gonna say Renée Fleming had some vocal.
Different if you then paired that with somebody who did have more of a higher pitch or more, Montrese type singing and see if the children respond differently.
Yeah, I mean, we do know that children attend more, like infants will look more at higher pitched sounds. I think in this specific example type of approach for studies where we're really looking at those moment to moment changes, the pitch is also completely, we can be thinking about those relative pitch changes, but they're going to be constrained by the melodic structure of the song. So then I think there's also probably some really interesting music theoretical questions about how we align high-pitched information with those rhythmically salient moments. Haley's nodding, so I feel like maybe Haley has some thoughts on this, but I think there's things we do in child-directed communication to package all of that really important information together to get the most bang for the buck, so that it's not just sort of overall how much a child is looking, but on that moment-by-moment basis, how they're sort of dynamically adjusting what they're attending to.
It have to be a higher key.
Yes, you could just do that. Yes, but I think then you would see the same thing because maybe you would see overall increases in attention, but we'd probably see the same patterns of modulations because, that's the structure of the song. Yeah, thank you. That's great feedback and we'll gonna make some new stimuli.
All righty. Can everybody please, who's raising their hand, please write down your question because we really want to hear your feedback, but we do have to transition on to the next talk. So can we give a round of applause to all of our speakers? Thank you so much.
So our next speaker hardly needs any introduction. Dr. Virginia Penhune is a professor of psychology at Concordia University and director of the Laboratory for Motor Control and Neuroplasticity. She's internationally recognized for her pioneering work on music, brain plasticity, motor learning, and auditory motor integration, and has helped shape our understanding of how musical experiences influence the developing and aging brain. Founding member of the Montreal Laboratory for Brain, Music, and Sound, Bronx, Dr. Penhune's research combines neuroimaging and neurostimulation approaches to explore how humans learn complex skills, how we perceive and produce rhythm, and how music training affects behavior and brain structure across the lifespan. Her work has been supported by major Canadian funding agencies and has had a profound influence on the fields of music neuroscience, motor learning, and human development. I also would like to again note how grateful we are all that Dr. Penhune was willing to join us here in Los Angeles from Canada at a time when international travel and academic exchange can feel increasingly complicated. It's especially meaningful to welcome you here today and really to emphasize the value of cross-border collaboration. Everyone, please join me in welcoming Dr. Penhune.
Thank you very much, Assal. It's a real pleasure to be here. And I just have to, as full disclosure, let you know that I am a Reformed American, right? I'm originally from Boston, but I've lived in Montreal for longer than I've lived in the States. So it's really a pleasure to be here. I will and I'll thank Assal, everybody who's done all the organization. And I'll tell you before I start that my work is really more in sort of in the basic science end of the spectrum. So it's actually a real treat for me to get to hear a lot more about what's happening from people who are doing more translational intervention kinds of studies, because this is not always my area. So I'm excited about that. So without further ado, I'm going to move on. I'm going to try to use the clicker appropriately. Yay. And I'm the sort of person who walks around while I talk. So if for some reason it turns out that you can't hear me, tell me and I'll hold still. So what I'm going to talk to you about today is the concept that there are interactions between our experience. So in this particular case, when we get musical training, development, and that these can have broad effects on behavior and the brain. So we know, this is very general, that adult skill results from a great number of interactive factors, including individual differences, probably genetic differences in auditory, motor, personality, etc. There's the specific experience we get, so the training, the environment that we're in, and development, so maturation of the body and the brain. So there's two particular concepts that I want people to kind of think about as we're talking today. And the first one is obviously the focus of the talk, which is the idea of sensitive periods, which are developmental windows where we think that specific experience has long-term effects on behavior in the brain. And this is certainly not a concept that I originated. There's decades of work on this, and I'll refer particularly to the ideas of Janet Worker and to Cal Hench. And the other idea that I want people to think about is a concept called interactive specialization. So this is a concept that was brought forward in terms of cognitive development, so how different aspects of intellectual development might work together. And I'm going to try to think about it in terms of the brain. So we know that brain systems work together. And the idea that I want to emphasize here is that structurally and functionally connected networks, brain networks, so let's say auditory networks, motor networks, executive function networks interact. And so that experiences like musical training that impact maybe a specific system, let's say your auditory motor system, can have knock-on effects on other systems. And I think one of the ones that a lot of people are really interested in is knock-on effects to language systems and to executive control, so broader cognitive skill. And this is something, it's probably a good thing that you wouldn't let me tweet my slides down to the left. But clearly the one aspect is social function, right? That a lot of people are really bringing us to think about today. So I'm going to just give you a tiny preview for what I'd like to talk about at the end, which is the idea, and again, not something that I've originated, but something I've really tried to think through, which is that we want to think about development and the impact of musical training in terms of what I'm calling a gene maturation environment framework. So the idea that genes code for predispositions or individual differences, and that they control maturation. This is something that's really important to remember, right? So this includes opening and closing of sensitive periods, and the idea that genes push development, but environment pushes back on genes, right? So then genes are activated, they're changed by environment, they're changed by experience. I want to have us think about the idea that sensitive periods, I'm going to focus on sensitive period that I've been able to study in kind of middle childhood, but there's a cascade, right? So some of the people who are the real developmental people in the room here are talking about early plasticity in infancy, middle childhood, other kinds of influences, and into adolescence, which may be which is, I think, a very important period that we've looked at less. I'm going to remind you again here of my interactive specialization idea. So regions interact, one changes in one affect others. And then the final thing I'll just make this point before I even start, which is that I don't think early training is the be all and end all, but it's a scaffold. So early training can provide a scaffold on which later experience can build. All right, so now on to the actual work. So I'm going to give you some examples of this concept of sensitive period. So the first one is from second language learning. This is always a disappointing slide for somebody like me who lives in a bilingual environment, but I'm a late bilingual learner. So I've been in Montreal, where we also have French as a second language. And what this is showing us is how well people perform. This is an extremely large studies, over 500,000 individuals, and lots of different languages. So this is not specific to any particular language. And it's showing us the language abilities of monolinguals, and then people who are immersed in their second language and their ability as a function of their age of first exposure. And what it's showing us is that people who are exposed after the age of 11, 12 have less than full fluency as adults. And I think this is particularly true for things like accent. So somebody like me, there are words in French that I will never be able to say properly, no matter how hard I try. So this is one example of sensitive period. And I think another part that I'll remind you of is that sensitive period is not critical period. Critical period is if you don't get the experience, you cannot develop the skill. What this is saying to us is that over a period of relatively protracted period in childhood, you have better or worse access to the skill. Now, an ability that may be actually a tiny bit more like a critical period is absolute pitch. So I think probably many people in the audience know that absolute pitch is the ability to hear a tone in the environment. So oops. Oh, sorry, that's the wrong one.
That's okay. I've got you.
Which I illustrated there, and a person with absolute pitch can say F sharp, right? They know what that pitch is. And you can go back one. Thank you. Yes. And what this is showing us is that among musicians who have absolute pitch, so this is most musicians, no absolute pitch, and in white musicians with absolute pitch, the vast majority of people who have this absolute pitch skill began their music training before the age of 6, and it drops off quite rapidly. And this is something that's also extremely, I would argue, impossible to learn as an adult. So don't believe any of those promotional materials. You're going to learn to have absolute pitch. It just doesn't seem to work that way. So these are some examples for possible sensitive period effects. The delay is really, and I think we have a lot of anecdotal information, right? So there's a lot of evidence from famous musicians, and probably your child's music teacher will tell you that, you know, the earlier you start, the better. And we can think of a lot of famous people. So Yo-Yo Ma began at 4, Oscar Peterson, famous Canadian jazz pianist, began at 5, Dave Brubeck at 4. So lots of examples, but I want to remind people of the counter examples as well. So somebody like Jimi Hendrix didn't really begin to play until he was 11 or 12. Aaron Copland similarly didn't have a lot of formal musical training until later. Leonard Cohen famously picking up the guitar as a teenager because he thought it was a good way to, you know, make friends and win girlfriends. So we have this anecdotal evidence, and what spurred our initial interest in actually examining this more closely was a study that was done by Gottfried Schlau, where he was looking at the possible brain structural differences between musicians and non-musicians. And what they found in that study was that overall, musicians had larger surface area of the corpus callosum. Really what's important about this is that the corpus callosum is a set of connections between the two hemispheres of the brain, and that these connections were stronger in musicians, particularly in the anterior part of the corpus callosum, which connects the two motor planning regions of the brain. And that this effect was driven by musicians who began their training before the age of 7. This area was particularly larger for them. There are also other findings. This came from Sarah Bankston and Frederick Leanne's lab, showing that the motor pathways of the brain had greater myelination, so stronger connectivity that was related to the number of hours of practice they had in childhood. Now, this is interesting, compelling evidence, but probably some of you are thinking, already, I'm betting the students are already thinking about this. Well, wait, there's no behavioral mechanism. We don't know what is this corpus callosum difference good for. Maybe it's just, random. In particular, we have no control for how much training these people had, right? So if I start playing when I'm 5 and I'm 25, I've got 20 years of training. If somebody else starts when they're 10 and they're 25, they only have 15 years of training. Maybe that difference in the corpus callosum is really only about how much training you have. And we know, obviously, from many other domains that training experience changes brain structure. And the other part that is, I think, important is that age cutoff, that age 7, is kind of arbitrary. It was what they saw in their data, but there was there's no particularly strong reason, at least at this point, to motivate that age 7. So what we did in our lab is one of the first studies was driven by my student, Anne Bailey, who is now a clinician working in Toronto. She works with people with ADHD. And she did both behavioral, which I'll describe in a sec, and brain imaging in adult musicians who began their training either before the age of 7 or after the age of 7. And the big thing that we did here is that we wanted to match these people for the years of training that they had, so that differences that we might see in either behavior or brain structure would be related to the age of start and not to how many years of training they had. And we also thought about other factors that we thought might be relevant, like formal training. So, we had people say to us, oh, well, those late trained musicians, the reason why their brain structure, might be different is, because they don't really have as many lessons or practice. Those late trained musicians, they're just noodling around in their garages, right? They don't really practice the way the smarty pants early trained. So we matched for these factors, and the task that we did with them was a task that was created by another student of mine, Joyce Chen, who now works in Toronto as well, but in kinesiology department, where she's interested in using music to promote rehabilitation. So Joyce developed this task, quite simple, where people hear a little woodblock rhythm, which you'll hear in a moment, and they listen to it, and then they get a second trial where they listen to the woodblock rhythm again, and they have to tap along in synchrony. So I'm going to see if I can do this. We had different levels of difficulty. We wanted to be sure that this task could also be done by non-musicians. So we have simple rhythms. We have more complex ones. And finally, what we call non-metric rhythms, which is that if you were to listen to it, if it didn't ever cycle, you would never be able to find a beat. And yeah, I'll stop there. So the idea was to have a range of difficulty. So what we had, as I said, what we had people do, they tap along and we look at how accurate they are in tapping in time with the sound. So in this case, good performance, low scores, right? They have less difference between when they tapped and when the sound occurred. And we can see that early trained musicians perform better than late trained musicians who perform better than non-musicians. This is good because this is a nice index of an actual behavioral difference between these earlies and these lates. So Anne also looked at brain structure in terms of the gray matter of the brain. And what she showed is that these early trained musicians also had differences in gray matter in the premotor cortex. So this is a region of the brain that we think is important, among other things, for integrating sounds and actions, or vision and action. But it's a sensory motor integration area. So greater volume in this region for the early trained musicians. That was related to the age of start. So earlier you start, larger the volume. And also across both groups related to your performance on that rhythm synchronization task. So this is really nice. This is showing us that that early musical training has a specific effect on brain structure that can be linked to behaviors that we think are something that would be emphasized in musical training. So why might it be that this particular region of the brain would be changed by early musical experience? One piece of information that we have that's not directly related to early musical training, but we did an fMRI study, so brain imaging while people were performing this task, this rhythm synchronization task with Joyce. And that same region of premotor cortex was active while you're doing the task. A second reason that we think that this particular premotor region might change in people who get this early training is that this is a region of the brain that shows its peak maturational change around the ages of 6 to 8. So we know that brain structure changes progressively across development, and that there are peak points at which that change is the greatest. For this region, it's around that 16. And another piece of evidence comes from a study showing that music training in childhood actually accelerated typical maturational change in premotor cortex in children who got at least a couple of years of musical experience between the ages of, I think it's around 6 or 7 and 17. So this looks like a region of the brain where it makes sense to think that early training would have. Now, in the same sample, we also looked at the white matter. But then what happened to it? Here we go. I can do this. I know I can. Hold on, let's see. Did I do something? I don't think I did. Oh, it just needs reviving. Maybe it went to sleep.
Not a moment.
It's right. Okay. So this is work that was done by my student Chris Steele. So taking these same people, we looked at the connections between different regions of the brain in terms of the white matter structure. And what we found is that a region of the corpus callosum, somewhat similar to where Schlag found these differences in adult musicians, differed between earlies and lates and non-musicians. And importantly, if we looked at where this region of the corpus callosum connects to the rest of the brain, that region connects motor and premotor regions of the brain. So regions that I talked about before that are really important for sensory motor integration. We also saw a really nifty finding that I had kind of forgotten about because we used also an unusual task that I had developed as part of my PhD, something that that no real musician would ever think was a musical or even a quasi-musical task, which was the temporal motor sequence task. And what it is kind of a visual rhythm. So what people see is they see one of those kind of simple rhythms that goes short, long, long, short, long, and they have to tap on a mouse button and try to time their taps to reproduce these durations that they're getting from a visual stimulus, which is kind of weird. I had used it in my PhD to compare with people's ability to do auditory rhythms. But this turned out to be really interesting because what Chris saw was that early trained musicians, and I'm sorry, I have now flipped this around where better performance is higher. So early trained musicians are more synchronous than late trained musicians and non-musicians. But what's really impressive about this is this is 6 blocks of performance of the exact same thing over and over again, over 2 days. So early trained musicians are better from the get-go. Everybody improves, right? So you're doing this over and over. But the late trained musicians never catch up. So this is telling us that this is something that is really there for our early trained musicians right from the start. And we had actually seen this in a previous study, one of the very first studies that we did looking at early versus late training. And another sort of piece that's interesting about this is that we looked at the correlation between these changes in the corpus callosum and performance on this task. You can see that there's a strong correlation for the general population, so the non-musicians, but not for the earlies and the lates. So what this suggests is that perhaps this corpus callosum difference may be some sort of a predisposition, an early marker, and that the ongoing training doesn't necessarily affect it as much, and it's not as related. So this is an intriguing piece of information that sort of fits in with this idea that adult attainment is probably a combination of intrinsic individual differences and the kind of training that you get. Now, the last thing, oh, and I'm sorry, I'm going to do my little thing and say, okay, why this region of the corpus callosum? One of the things that's interesting is that this region of the corpus callosum has a stronger contribution of environment, if you're looking in twin studies, to its adult size compared to other regions that might be more under genetic control. It's also a region that changes between 6 and 8 years. The size of this region in adults is related to bimanual coordination, something that we think most musicians need. And also we can look at work from Krista Hyde and from Assal, showing that this is a region of the corpus callosum that also changes with music training in children. So this is, I think, really quite convincing evidence that this early training can have a long-lasting impact. Now, the last piece that we did, again, with these same sample is to look at a region of the brain that we don't always think about in terms of being directly related to music, which is the cerebellum, a region of the brain that's very important for learning new motor skills, that's important for timing, and that's important for what we might think about as optimization of movement. And what we found here, this is work from my student Larry Baer, is actually one of my favorite findings because it did not fit with the general pattern that we had seen with everything else. What we found here is that when we looked at the volume of all of these different lobules in the cerebellum, that early trained musicians actually had smaller volumes of the cerebellum compared to later trained musicians and non-musicians. And that overall, smaller volumes of this lobule 6 were related to better performance in terms of your ability to tap consistently. So this really got us thinking, okay, why is the cerebellum different? So one of the things that's interesting about the cerebellum is that its peak of maturation is much later, really into adolescence and early adulthood. There's a lot of thinking that part of the reason this might be the case is because the cerebellum is actually reciprocally connected to really all regions of the cortex, and that its role in this optimization of function may not just be for motor performance, making your movements more accurate, but may also contribute to optimization of other kinds of cognitive functions, including things like executive control. So perhaps the reason why cerebellum is showing these smaller volumes is we have some sort of an efficiency effect related to this later peak of structural maturation that is built on its connections here, and I'm illustrating, I just don't want to push the wrong button, the connections between this area 5 and 6, which we showed to be different, and these motor and premotor regions of the brain. So the next step that we took was to try to think about this idea, okay, if we think that cerebellar volume is linked to cortical volume, and that's the reason why these, we see these decreases in cerebellum and increases in these motor regions, we should be able to look at the covariation. In other words, how is the volume of the cerebellum correlated to the volume of the cortex? And this is work that was done by my student, Jake Schenker. We took all of the people that we had scanned in this study and in a large number of other studies at the Montreal Neuro with musicians and pooled them together so that we had groups of around 75 early, 75 lates, and around 100 non-musicians. And what Jake was able to do is he was able to label these regions of the cerebellum that we had seen to differ before, and also to label these motor regions of the brain, and to look first, did we replicate this kind of unusual finding that the early trained musicians had smaller cerebellar volumes? And yes, we were able to replicate that. And then what he looked at was how the volumes of the cerebellum were linked to the volumes in the cortex. And what he was able to show here, and this is a bit of a messy slide, is that for early trained musicians, we did indeed see this negative covariation where larger volumes of premotor cortex were linked to smaller volumes of the cerebellum. And the last step we took is related to this idea of this age cutoff. Like, we haven't really given you any evidence here. I've given you evidence that this age 7 cutoff seems to kind of work, but how could we validate that? So what Jake did is he took the volumes of all the regions of the cerebellum and the surface area of all of these motor regions and put them together and use what we call machine learning. So this is a way of saying, take all of this data and see if you can tell me, based on the cerebellum and the motor regions, who's an early trained musician and who's a late trained musician. And what what Jake was able to show is that for this age 7 cutoff, we had the best classification. So the area under this pale blue triangle is largest for the age 7 cutoff compared to age, now I have to squint, age 6 and age 8. So not only is it telling us that we can use these brain structural differences as a way to see, we can link it in a data-driven way to being an early or late trained musicians, but we also have more validation for this age 7 cutoff, even though clearly, and I'll make this point again later, we don't see it, it's not like an abrupt cutoff, right? So we can still classify based on age 6 or age 8. It's just not as good. So the question that probably many of you who are more developmentalists are asking is, well, oh, sorry, my last little, so why out there in the world for this interaction between cerebellum and motor regions? And this comes from the work of Jan Schultz. And what he did was he had the best postdoc project ever. He got to build this incredible apparatus for mice to give them a really enriched environment. And then he was able to scan them after their experience. And what he shows is that the mice who received this enriched environment showed positive increases in this is sensory cortex. It's not illustrated here, but in another part of the figure in motor cortex, and decreasing volumes in the cerebellum. So this is, again, supporting this idea that there may be these reciprocal effects on these regions that are connected to each other. So wait and see the next slide. And thank you. The other piece of evidence coming from humans is that what we know about the connectivity between cerebellum and cortical regions in terms of function. So this is called functional connectivity, resting state. You can put people in the scanner, they just relax. And we look at how these regions intrinsically, their function or their activity is coupled. And this was work from, I think it's Judy Kipping, and she's showing the changes in this functional connectivity across childhood and into adulthood. And we can see that connectivity for these regions of the cerebellum that we saw to differ in the early trained musicians, the changes in functional connectivity with motor regions of the brain are greatest in this middle childhood period. So now's the part, this is the part that I feel like all the developmental people are working for. It's like, okay, good. You showed all of this stuff in adults, but what about kids? So we really tried to think to ourselves, okay, how could we look at whether or not this early training has immediate impacts for children? So this was the heroic PhD thesis of my student, Kira Ireland, along with an amazing group of undergraduates who they named themselves the Penhune Kids Power Team. And they tested 213, I'm sure more, probably more like 250 children in science summer camps, so non-musician kids, and in Suzuki musical summer camps to get these kids with musical training. So we had 130 kids with musical training, on average about greater than 2.5 years. Oh, that's right, sorry. This is wanted kids with more than 2.5 years of training. And we did the child version of that rhythm synchronization task. We did also a melody discrimination task, which we had also done in adults and also seen that early trained musicians performed better. And we did a kind of control syllable sequence discrimination task. So here you obviously have a little melody, and you have the mother elephant who sings the song or the teacher elephant, and then you have either the obedient baby elephant who sings the thing back exactly as they should, or the mischievous monkey who sings it back with one pitch change. And similarly, for this syllable sequence discrimination task, the teacher elephant gives you a sequence like ko, ru, ra, na, fu. It sort of sounded like robot, oh, no, ra, ra, do. And then it was either changed by one syllable or not. And what we saw was that musically trained children outperformed untrained children on both the rhythm and the melody task. But they were also better at this syllable sequence discrimination task. So this is something that I actually hadn't thought about in a while, but since I was coming here, I was like, oh, I have to talk about this. So this was really kind of interesting. And performance on this task correlated with both the rhythm and the melody discrimination task. So this is giving us a little piece of a hint that maybe training on these skills, right, can have knock-on effects for this kind of skill. And then the big thing that we did with this is that we use this to create age norm scores. So everybody who's a developmentalist knows this is the bane of your existence. If I want to look at a kid who's 8 and who has 3 years of music lessons and started when they were 5, well, I need them to be able to compare them to another kid that's 8, and I need to know what kids normally can do at the age of 8, right? So we use these to create age norm scores. And then what Carla was able to do is to look at performance on both the rhythm synchronization and the melody discrimination. And what she found was that we did not see differences in the rhythm discrimination task. And I'll just mention, actually, I'm sorry, I should have said this before. One of the things we really tried to do here was to extend our matching with the kids. So all of the kids had an average of 5 years of training, whether they started earlier or started later. And we matched them for hours they practiced, for a metric of socioeconomic status, so mom's education level, working memory skills, and nonverbal reasoning, so the matrix reasoning subtest of the width. So what we found is no differences on rhythm, differences on melody discrimination. And in particular, where these differences came from were the simple melody discrimination. This task included both melodies that were just had one note change and others that were more difficult where the melody was transposed and they had to discriminate. And all kids in our age range struggled more, not unsurprisingly, with the transposed task. So this is interesting to us and somewhat difficult for my adult findings, right? Because I want to believe, of course, all of my results, but if I believe this and the kids don't differ in the rhythm, but my adults do, my kids differ in the melody discrimination and my adults do. I think what I have to hypothesize is that rhythm synchronization, this ability to do this task, is something that takes longer to develop. And that's something that we could see already in the scores across childhood, which is really, they're still not performing that well up until like 11, 12 years of age in here. So if I want to believe both my results, I have to think that there's some kind of a priming effect. They get this experience in early childhood, but that ability to synchronize, that ability to come up with a representation of the meter so that they can tap along is not fully developed. And then it's their ongoing training into later childhood that's going to then give us the differences that we see in terms of adult performance. Now, this is an open question. It's not something that I know the answer to, but this is what I would have to hypothesize if I have faith in both my results. So, opening for new work. We need to look at adolescence.
Okay, so I'm going to give you some basic conclusions. I don't think these are going to be surprises given what I've been saying. So early music training has long-term effects on behavior in the brain. How that plasticity is manifested depends on the region of the brain that is trained by the experience, the developmental trajectory, the local circuitry, and the connectivity. As I said before, structurally and functionally connected regions develop together, and I'll really emphasize this idea that I think it's a scaffold. So I wanted to put this in here because I was thinking about, okay, a lot of interest here is about potential transfer, right? What is music, what kind of knock-on effects does it have? So I was thinking about this in terms of another area that I'm interested in, which is rhythm processing, and also in terms of a lot of work that's out there that's been done looking at relationships between rhythm abilities, timing abilities in kids, and language and reading readiness kinds of skills. So the way I might try to think about it is that transfer to other domains depends on overlap in function and in maturational window. So perhaps transfer from rhythm to language skills may result from overlap in auditory temporal processing demands, right? That makes sense. We need to do that timing and extract that information from the auditory signal in music. We can apply that to language. Also, the maturational time window of auditory motor integration abilities like synchronization, which we're thinking some of the basic abilities develop in kind of middle childhood, but may be ongoing. So now I'll come to just the last part and talk about how I try to put this all together. And I don't think this is really news to any of the people here, but it's really me trying to grapple with this sort of whole set of results. So we can obviously think about genes as contributing all kinds of predispositions. So I talked about maybe that corpus callosum marker. There's other evidence from a group in Germany showing that there may be differences in auditory cortex that are present in children who later go on to pursue music training. So there could be differences in manual skill, in auditory abilities. We think about anybody who plays the piano, I think everybody knows having big hands is super advantageous, right? This is not something that you think of as being an actual musical skill, but it's a predisposition that's probably very helpful. We also know that there are contributions of personality factors like openness to experience. So somebody asked about, which I thought was a great question, about the interaction between social development and social effects of music and cognitive effects. Well, one of the biggest, globally speaking, contributors to general cognitive ability that's out there in literature is openness to experience, a personality variable highly related to IQ and to things like academic outcome. So you might imagine, or this would be my thinking, is G, promoting openness to experience could help promote cognitive skill. So we know that these factors differ. We know that things like cognitive factors, the kid who can actually sit on that piano bench and focus for a half an hour, right? Probably going to benefit more from early training than a kid who just doesn't have those abilities yet, right? So then we can think about the fact that genes, as I talked about, these are all these predisposing factors, linking them to brain structure, but genes also drive development, right? And then there's this idea that I tried to think about a lot, which is that sensitive periods are multiple, right? So we can think about early infancy where you develop sensitivity to pitch. So infants from, I hope I'm not misquoting, but around like 3 months to 6 months start to develop sensitivity to the pitch and the scale structures of their own culture, whereas before they'd be a little more agnostic. They begin to develop sensitivity to temporal structure. Then in childhood, as we can see, they're maybe more able to deal with things like musical intervals, with melodic contour, rhythm synchronization skills develop, and obviously also social factors. And finally, perhaps linked to some of these like executive control factors and everything, we have further development in frontal lobe regions, in cognitive control, social emotional control, et cetera, that will contribute. And then finally, we have the feedback between these regions and between experience and gene expression. So this really just to encourage all of us to marvel at the complexity of how any kind of a really enriched cognitive, social, emotional experience like musical training can impact the brain. And in many ways that gives us many vectors for intervention. And then the last thing
I'll say is completely selfish, which is to tell you about a new study that my student
Maria Somas is doing to try to make a few more of these links with some of the language-related skills that other people are interested in. So we're collecting a new cohort right now of early and late trained adult musicians. And what we're looking is auditory, cortical and subcortical frequency following response. So this is the ability of the brain to encode pitch and timing information from pitch in the environment. We're looking at auditory motor synchronization. This is a task that was developed by Florencia Aseneo, which is asking people to synchronize to syllables or to pitches, and it's been linked to statistical word learning. So this is the ability to extract possible words from an ongoing stream of auditory information that we know is related to language skill and potentially also to like pre-reading skills like phonemic awareness. And we're also interested in looking at it in terms of speech and music and noise perception. So the idea will be to link these functional differences in frequency following response to synchronization, to these word learning abilities, and to hearing and noise. So this is hopefully coming to a music neurosciences conference near you. So I will stop here and just say thank you very much to Oh yes, here they are. There's
a few questions for Dr. Penhune. If somebody, Bonnie and Jen, have the mics. I think Rick is up here and one.
I'm going to let you moderate. Since I.
Go ahead, Rick.
Sure. Amazing talk. Thank you so much. And that body of work is so strong and consistent, and the message is clear. I had a question about the sensitive period or critical period, and I was thinking about things that music is involved in. And for example, in psychedelics, we know that psychedelics have this ability to open up, critical periods or critical windows in adults' cortical plasticity. And I'm wondering if you could see if maybe, do you think that if you paired maybe a psychedelic with a certain musical experience, you might be able to reverse the late training folks back to more early training type of functionality, or if that's even, if you could think about that, I don't know.
So, I mean, there's a lot of things in there. And I'm not knowledgeable about psychedelics, or only. So I think the concept of the effective psychedelics on is really more on relatively specific memory consolidation. So the idea is that you want to disrupt the already laid down memory trace of, let's say, a traumatic experience, a difficult memory, et cetera. You're going to disrupt that, allowing for kind of relearning or unlearning of a maladaptive association. I think here we're not really talking about a specific memory or set of memories, right? We're talking about a whole kind of body of capacity and skill. I think the other thing is we don't want to think of these late trained musicians as some poor disadvantaged population who we need to repair, right? So I gave you the examples of Aaron Copeland, of Leonard Cope, of other people. There are plenty of highly professional, later trained musicians. I think what this tells us is something about brain development, impact of experience. It tells us about how the brain, how these interactions work. But there are so many factors that might contribute to adult musical performance that I think we just really don't want to think about that way. I'm not saying that that's what you're thinking, but I don't think that I would think of a transient intervention like psychedelics impacting skills like this that have been laid down over many years. So most of our adult musicians have over 15 years of training.
Yeah, thank you, Dr. Penhune. That's just incredible presentation about the neural correlates associated with the music and music training, early childhood. I was particularly curious about the one study you mentioned about the 213 children that were put into the summer camp with music training. Could you elaborate a little bit more about that study design? Was it really was it delivered as an intervention, meaning, or it was just you're observing them and trying to associate their effects?
Thank you for clarifying. We did not do any of the work. These were kids who were attending a Suzuki summer camp. So I think you're probably all familiar with Suzuki training, and a big component of it is that they have big summer jamborees where all the kids get together. So this was a place for us to test kids who had musical training. So we worked with kids in those camps, and with the camp, we gave them music in the brain sessions to inform them a little bit more. And then we used science, and it was like a science and I can't remember like some of the other components they had, summer camp that was not specifically focused on music, where we tested kids without musical training. So it was really just our way of getting the kids with the kind of background, where we did not do any interventions.
Got it. So,
and people do sometimes ask me about the specificity of Suzuki training, and Suzuki training, as many people know, involves a lot of imitation and a lot of early pre-music boosting skills, so the kids can actually participate in training before they can read. Right? You don't need to be able to read music. So it's possible that Suzuki method has a particularly strong effect. It's hard for us to disentangle because these were the kids that we had.
There's some back there who wanted to talk, and I already asked a question, but if I could just two quick questions. One is, first, really amazing talk, really great, as everyone said. The most recent study, or the one that's coming up, rather, do you anticipate that you'll have a large enough sample to control for socioeconomic status? Because I think with word skills, particularly even in those nascent, for among adults, I would imagine things like occupation factors have a lot to do with those as well.
We'll do best we do. We hadn't before with the adults help with yes. And here in that study we will, and we will either hope to match so SES between the all the musician and the control groups, or we can use it as a covariate in the studies. So we'll definitely keep
Thank you. That's great. And my only other question is a little bit off the wall, but the cerebellar volume, cerebellar, how do you pronounce that? I know cerebellar volume. Is there any negative aspect of the relative diminishment of, the smaller, is there any, since we're plotting all the great stuff the premotor cortex is capable of doing, is there something we're losing? Is there an opportunity cost with the apparent resulting diminishment of that?
open question, right? We can't, our brains aren't infinite, and we all can't be good at everything. So clearly, I don't think that the relative change in cerebellar volume that we're talking about is something that's going to create, I don't know what, chronic clumsiness in musicians. But clearly, there have to be upsides and downsides. And this is something that has not been looked at all that much. So yeah, I don't think this would have like an obvious negative effect.
Take one from Ramesh.
Pick Ramesh, because I can see.
Virginia, thank you. Right. I was actually, it's very timely because my question is very related to what Sunil was just asking. It's about the cerebellum and its sort of reciprocal relationship with the premotor areas that you're talking about. One of the functions of the cerebellum is to sort of be a predictor of what is likely to happen. And it has very strong anatomical connections with the premotor cortex, and that's kind of how it gets that information. Now, if the cerebellum is not doing it, it could mean one of two things, right? If the cerebellum's volume is going down, it could mean one of two things. One is the brain is now less interested in sort of making a sensory prediction error, and it's relying more on like its natural way of solving the problem motorically. So I'm just wondering, what is the sort of flip side of this? Like, how long can you not have a cerebellum that's like not getting as much input from the motor cortex and still develop these internal models of how we need to perform? Right?
So I think, again, I'll answer in two parts, is that what we would have to hypothesize if we don't think that somehow this training is creating deficits for musicians, is that it's more of like an efficiency effect, right? Is that you don't need to sort of grow the cerebellum because you've had this experience through a protected period in childhood that's interacting with development, and meaning that your interactions with the cortex are more efficient. One thing I'll say in the background is that we have another study, a very large scale study with I'm not going to remember, the human brain mapping cohort. So it's a very large sample of adults where they have both cortical structure and cerebellar structure. And we looked at this cerebellar cortical covariation across the population. And we see that actually these negative relationships are relatively common in motor, premotor, and prefrontal regions. So it also seems like this is just the way these regions are wired, and that, again, I'm drinking my own Kool-Aid, but I would have to say, based on my own data, that what I think is happening is that the early training is promoting this reciprocal relationship.
Wonderful. Let's thank. Okay, wonderful. Welcome back. I hope you enjoyed lunch. Before we continue with the afternoon session, we wanted to create a brief opportunity to experience the very thing that has brought us all together today. Throughout the morning, we have discussed music as a subject of scientific inquiry, its effects on the brain, learning, development, and health. Yet music is also, first and foremost, a lived human experience. It is something we create, share, and feel. We are delighted to have two extraordinary musicians with us today, Giovanni Piacentini and Meagan Martin, who will remind us of all the artistry and human connection that inspire so much of the research that we have been discussing. Let's welcome the musicians.
Thank you and good afternoon. I'm Meagan Martin. This is Giovanni Piacentini, and we're very happy to be here this afternoon to share this 15-minute musical interlude. We prepared 2 sets of songs in Spanish. The first is 3 selections from Manuel de Falla's Siete Canciones Populares Españolas, 7 popular Spanish songs. And then we'll conclude with 2 songs from Rosa Divina, a beautiful song cycle by guitarist and Latin Grammy nominated composer, Giovanni Piacentini. And I will read the translation before each song. And the first from the set of the Falla songs is El Paño Moruno, the Moorish cloth. On the delicate fabric in the shop, there fell a stain. It sells for less, for it has lost its value.
Asturiana, Asturian song. To see if it might console me, I drew near a green pine. To see me weep, it wept. And the pine, since it was green, wept to see me weeping. Canción, song. Since your eyes are treacherous, I'm going to bury them. You know not what it costs, Delaire, dearest, to gaze into them. Mother, a la orilla. They say you do not love me, but you loved me once. Make the best of it, Delaire, and cut your losses. Mother, a la orilla. Thank you. And for this second and final set, we'll be doing two selections from Giovanni's sound cycle Rosa Divina, which sets the poetry of Sor Juana Inés de la Cruz, a brilliant and trailblazing 16th century scholar, poet, and nun. Giovanni wrote these songs for me, and actually an alumnus of USC, Bucknell, who, since he completed his master's, doctorate, and artist diploma here at USC, has been nominated for 4 Grammys as a guitarist. So, he's doing pretty well. So we'll be doing the first 2 songs from this 3-song cycle. The first, Esta tarde mi bien, cuando te hablaba. This afternoon, my love, when I spoke with you, since I saw in your face and in your actions that I couldn't persuade you with words, I only wished you could see my heart. And love, who helped my intents, achieved what seemed impossible, because among the tears that my pain was spilling, my broken heart started to shed. Enough of this harshness, my love. Stop it. Don't be haunted anymore by tyrant jealousy, nor let your wicked doubts corrupt your peace. With stubborn shadows, with futile signs, because you already saw and touched the blood of my shattered heart between your hands. For our final song, Detente, sombra de mi bien esquivo, stop, shadow of my elusive goodness, image of the dream that I love the most, for whom I joyfully die, fair illusion, for whom I heavy exist, dulcet fiction. If my obedient iron chest is serving to the magnet of your graces, attractive, what form are you courting me, flattering? If you will circumvent me, then fugitive. But you can't be blazing contented that your tyranny is triumphing over me, even if you're leaving the tight loop eluded. That was belting your fantastic figure. It doesn't matter to elude arms and chest if my fantasy is carving to you a prison.
What a beautiful performance. Thank you, Meagan and Giovanni, for sharing this beautiful music with us. I think it's a good reminder of why we're all doing what we're doing and what really matters, the music. Before we continue, I'd like to invite Dr. Antonio Damasio, the director of the Brain and Creativity Institute, to share a few thoughts inspired by this morning's talks with us.
Thank you, Assal, and welcome to everyone once again. Brains and music, these are my favorite pastimes, and I cannot think of a more ideal situation than this. I just wanted to make a quick comment because at the end of the beautiful talk by Virginia Terhune, I wanted to say it, and I kept thinking about it over lunch. And that is that not all brains are created equal. And we know that we have different parts of the brain doing very different things. And that's obviously the most important conclusion of a few decades of neuroscience. But there's something quite interesting that she described, and that is the fact that the cerebral cortex and the cerebellum were behaving in very different ways, almost opposite ways. And the brief comment I would like to make is the following. So it could be that what you have when you have motor cortices actually enlarging the surface that is occupied by a certain movement, a certain planning of a movement, really has to do with the training for that movement and with the development of the structures, the cellular structures that can implement that movement, but mostly represent that movement before they implement it. And the cerebellum behaves in an opposite way, possibly because what it is doing is actually something that the musicians in the audience know very well. It's refining the performance. It's having the possibility of doing something with actually less space, with a higher concentration, and with a more with greater perfection in the creation of the movement. So it's not, this may sound paradoxical, but it is not. It's just that we have a brain that has all of these different structures capable of doing different things and doing them in very different ways. And this is especially true and important in relation to the motor system because it has to do with execution. It has to do with the creation of a movement, and everyone in this audience who is a musician knows that that there is a progress and there's a movement in the performance that has to do with the repetition of those movements and the greater ability that we want. So this is just a very brief comment. Maybe people want to think about this, and there's greater work to do in the future on this, and probably even some answers already for the question that Virginia posed so beautifully. Thank you so much.
Thank you so much. So we are now going to turn our attention to our second session, which focuses on translation and clinical implications. How do we take the insights emerging from music research and apply them in educational setting, healthcare systems, clinical interventions, and communities? To guide this discussion, I am pleased to introduce our session chair, Jed Villeneuve.
Thank you so much, Assal, for the gentle introduction. Something that I wanted to, here's a story that I learned just recently. So I actually got my start in music cognition in a sort of leap of faith sort of fashion. So back when I was applying for college, I had no idea what I was wanting to do. So I asked my brother in passing, what should I apply towards? And he said music cognition, just out of the blue. And it turns out he, as a Peabody Conservatory student, was being taught by Dr. Karen Barrett. And it's just a nice introduction to be like, everything's connected. So in a way, she set the stage for my entire future. So, but as researchers, to transition into the panel, as researchers, a recurring challenge we face is translation. How do we go from understanding phenomenon found in a lab to applying it in ways that meaningfully impact people's lives. Music research is no exception, and in recent years, we've learned a great deal about how music informs cognition through its associations with attention, learning, and social connection. Yet, an equally important problem is understanding how these discoveries extend outside the lab and inform education, guide interventions for developmental and neurological populations, and translate into technologies that have real-world impact. In this session, our speakers all approach these problems from different perspectives, yet share a common goal of bridging the gap between scientific discovery and real-world impact. Their work spans research on executive functions and their neural mechanisms, the development of music-based interventions across the lifespan, and broader efforts to connect research with healthcare, education, and public engagement. Our first speaker is Dr. Kevin Jamie, a postdoc researcher in the USC Brain and Music Lab. His work focuses on music-based interventions that support cognitive development in children and includes research into rhythm-based technologies. Our second speaker is Theodore Zanto, an associate professor of neurology at UCSF and the director of the Neuroscape Neuroscience Division. Dr. Zanto investigates the neural mechanisms underlying attention, perception, and memory with a particular focus on neural entrainments. Next, we'll hear from Dr. Karen Barrett, an assistant professor at UCSF, whose interdisciplinary research spans music cognition, auditory neuroscience, and music creativity. In addition, through her work with the Sound Health Network, she looks to bridge scientific discovery with public engagement, education, and community impacts. Finally, our last speaker is Dr. Jennifer Bugos. She is a professor of music education and director of the CALM Lab at the University of South Florida. She spent her career examining how music training can support psychosocial and cognitive health across the lifespan. Her research has led to innovations in education and clinical programs for children and older adults, including interventions designed to promote well-being through music engagement. Allow me now to introduce the first speaker, Kevin Jamie.
Thank you, Jed, for the introduction. So hello, everyone. Thanks for inviting me here to give a talk on some of the research that we've been doing at the USC Brain and Music Lab. So before diving into any individual studies, I'd like to introduce a broader question that motivates much of our work. How might music influence health, learning, and well-being across the lifespan? And one possibility is that music engages a set of shared mechanisms that are relevant across development. So the first involves self-regulation. Learning requires sustained attention when playing music, inhibition control, delayed gratification, and goal-directed practice. And unlike many child activities, the reward often comes much later, only after extended practice, effort, repetition, and refinement. A second mechanism that involves, the second mechanism here that's involved could be social coordination. Music frequently requires people to synchronize actions, cooperate with others, and engage in shared experiences. So today I'll show two examples of how these processes relate to developmental outcomes. So our early work comes from a longitudinal study that followed children through approximately 4 years of development. Children entered music, sports, and no training groups before formal training began. The groups were comparable at baseline on socioeconomic status and cognitive abilities. And this allowed us to ask whether sustained music training was associated with differences in developmental trajectories over time. I'll focus on 3 outcomes here: brain structure, brain function, and self-regulation. This was one of the few studies long enough to test if music training is associated with differences in brain maturation. And the first structural differences emerged in the auditory cortex, where the processing of complex sounds occurs. All groups showed the expected age-related cortical thinning over time, but the music group showed a slower rate of thinning than both the comparison groups during the first 2 years. And this pattern is consistent with experience-dependent auditory plasticity and suggests that the earliest effects of music training appear in brain systems that are directly engaged during music training.
And this finding raised an important unanswered question. If training-related cortical thinning is slower in the auditory cortex, does it eventually affect broader auditory and cognitive motor networks? So for the first time, we examine here structural longitudinal data after 4 years of music training in young children compared to active and passive controls. And we see that the effects are no longer confined to auditory regions. In addition to the continued differences in the auditory cortex, we observed altered maturation trajectories in the right inferior frontal gyrus, which is a region involved in auditory motor integration and cognitive control. And importantly, these differences were evident not only against passive controls, but also relative to children participating in another structured extracurricular activity, the sports program. So one possibility is that the training-related effects may emerge first in systems directly engaged by music, and with continued training, they become more evident in broader auditory, motor, and cognitive control centers. Naturally, we're also curious to know if these structural differences are mirrored in the functional brain regions that support inhibition control and self-regulation in this study. So using an fMRI Stroop task, we found that after 2 years of music training, children showed greater recruitment of key inhibition control regions, including the pre-SMA, the inferior frontal gyrus, and anterior cingulate cortex. And interestingly, these neural differences emerged before measurable behavioral differences on the task itself. However, as training continued, the behavioral advantages began to emerge on other measures of inhibition control. The music group showed greater improvement on a flanker task and earlier willingness to wait for larger rewards on a delayed gratification task. So together, these findings suggest that music training may influence the development of cognitive control systems, with neural differences appearing ahead of measurable behavioral advantages with this type of training. Now, while the longitudinal study provides encouraging evidence, it could not fully establish causality because the children self-selected into the programs. So to address this, we launched a 2-year randomized control trial in children from communities around USC. Children were individually randomized to either music training or an active arts control, theater training, with both programs matched for duration, intensity, and social engagement. Participants completed MRI scans before and after training 2 years later. And importantly, the trial was designed around 2 core aspects of self-regulation: response inhibition and delayed gratification. And unlike our earlier fMRI Stroop task, these tasks provide direct measures of both accuracy and reaction time during scanning, allowing us to directly link behavioral performance and neural activation. So with that in mind, I'm sharing a preliminary analysis from the ongoing randomized trial. And here we're asking whether improvements in inhibition control track changes in brain function over the same 2-year period, regardless of training group. This analysis includes 28 participants with both baseline and follow-up scans. And here we're relating the change in go-no-go performance to change in bold activation during inhibition trials. And importantly, this is an exploratory quality control analysis. We're still blinded to the groups, and we used a liberal threshold, so it shouldn't be interpreted as anything definitive. But what is encouraging is that these emerging clusters are not random. They appear in canonical inhibition control regions that we have seen before. So while the primary goal of the RCT is to test causality, another question we're becoming increasingly interested in is whether all children respond to music in the same way. And that question has led us back to the longitudinal cohort to examine how cortical maturation unfolds within each group, and particularly in relation to timing abilities. We measured sensory motor synchronization at baseline, which is the ability to coordinate movement with an external rhythm, such as the beat of music, either individually or with a partner. And preliminary analyses here suggest that baseline synchronization is associated with later cortical maturation in auditory, motor planning, and cognitive control regions within the music group, but not the sports group. Now, interestingly, children who start training with lower synchronization ability showed reduced cortical thinning over time, which particularly in the motor planning regions. And this is possibly reflective of a different neural trajectory. While those who entered with higher or stronger synchronization ability, they went on to show the strongest motor proficiency at age 10 after the training, which was then associated with fewer behavioral difficulties. So taken together, what we see here is that these findings suggest that music training may not only affect every child in exactly the same way, and that early timing abilities may help shape how development trajectories unfold over time. Now, these exploratory findings raise an important possibility. Processes related to timing and coordination may help shape developmental outcomes. And that idea becomes interesting when we move beyond childhood, specifically when we look at how music influences social connection and well-being later in life. So far, I've focused on the brain development and self-regulation in childhood, but music may influence health and well-being across the lifespan. In older adulthood, social isolation and loneliness become a major public health concern and is associated with poorer physical and mental health outcomes. And this raises a related question: can music help foster social connection and belonging later in life? So now I'll briefly discuss work from our lab examining a music-based intervention in older adults. In the childhood studies, we examined synchronization primarily as an individual difference associated with developmental trajectories. In older adulthood, synchronization becomes a more central theoretical construct for understanding things like social connection. And one influential framework proposes that coordinated musical activity actually promotes belonging. The basic idea is that when people sing and move and make music together, shared behavioral and physiological experiences can foster social connection. And so this framework motivated the older adult study that I will discuss next. So older adults were randomized to either choir or music appreciation in a 20-week training program. Both groups were social, but choir involved active, coordinated musical performance, like singing. And here we measured belonging, loneliness, well-being, and physiological synchrony, as well as attentional and auditory processing using EEG. The main findings from this study cohort touches on social, physiological, and attentional outcomes. So first, both music programs improved belonging and reduced loneliness over time. And this suggests that repeated engagement with a consistent social group can foster meaningful social connection. Second, we found that physiological synchrony was associated with momentary feelings of belonging in the choir group. Participants who were more physiologically synchronized through their heartbeat during sessions tended to report stronger feelings of connection to the group. At the same time, the heart rate synchrony varied considerably across the intervention, suggesting that we do need more complex physiological measures, and that could help explain how social connection emerges and interacts with other factors in other contexts. But interestingly, we're also beginning to see evidence that choir participation may influence attentional processing as well. During an oddball task, auditory oddball task, the N1 response here that you see appears stronger following the choir training than the music appreciation, suggesting that active musical engagement may influence not only social outcomes, but also basic attentional mechanisms. So these analyses are ongoing, and a second cohort will be launched in the fall with broader cognitive profiles, including mild impairments. But together, these findings suggest that music may support well-being not only through individual cognitive processes, but also through mechanisms related to attention, coordination, shared experience, and social connection. So to sum up, across these studies, we see a common theme arising. In childhood, music training is associated with changes in auditory, motor, and cognitive control systems, and our ongoing randomized trial is testing those effects now more rigorously. In older adulthood, music participation appears to support belonging and social connection, with physiological synchrony being one possible correlate of those effects. Now, while the outcomes differ across developmental stages, common themes of coordination, self-regulation, and social connection emerge across both lines of work. And importantly, these findings come from community-based programs implemented in real-world settings, rather than highly controlled laboratory environments. So together they suggest that music-based interventions can be then both feasible and scalable in diverse populations across development. So to conclude, across the lifespan, music provides a unique context in which cognitive, motor, and social processes interact, and understanding those interactions better may help design more tailored, more effective educational, health, and community-based interventions. Thank you all for your attention. I'd like to thank our funding agencies, our co-directors, Hannah and Antonio Damasio, co-investigators Beatrice Elari, Jonas Kaplan, the entire research team, Caitlin, Melissa Mizell, Jed, Colin, Sarah Mendoza, Sarah Hennessy, Allison, Priscilla, Ellen. Finally, special thank you to Assal Habibi. After spending only 1 year working on this project, I've come to the conclusion that you have to be at least a little bit crazy to launch a 5-year neuroimaging study with children, to launch several of them. And well, fortunately for the field, Assal appears to have exactly the right amount of that kind of bold determination. Thank you.
That's tough to follow. Whew. All right. So it is an honor and my pleasure to speak with you today about mechanisms of cognitive change following a digital form of musical training, or specifically rhythm training. I apologize in advance for those of you who have heard me already speak on this topic. I switched it up a little bit, so maybe you can spot the differences, give you something to do. What you're seeing here is what we call the glass brain. It's a real-time visualization of neural activity. And I'm going to just show this to you so you can understand the system that we're working with and the complexity within it. The different colors represent different frequencies of activity, where the reds represent the lower frequencies in the theta band if you're into EEG. This is source localized EEG. So theta being 4 to 7 hertz, blue is 8 to 12 hertz, the alpha band, and green is the beta activity around 12 to 20 hertz. And it's following what is our best guess estimate along those yellow white matter tracks. And so it gives you an idea. And this is just a very small fraction of what's actually going on in your brain. And if you want to see what it looks like when a pianist plays, and if you want to see what his brain looks like, come and catch me during the break so you can see what it looks like. But I'm going to talk to you today, not just about visualizing neural activity while playing music, but cognitive training. And by cognitive training, I'm talking about doing tasks that you might get better at in order to facilitate cognitive function in every day. So for example, if you do attention training and inhibitory control training tasks, that hopefully you don't just pass some test in a lab, but perhaps it facilitates your ability to focus your attention when it matters most in everyday life. Now, there's if you look at the literature, there's a lot of evidence that you can see this transfer of benefit to what you trained on. So if you train on a sort of short-term memory task, you might improve short-term memory on another task. So like an NBAC task where you have to remember letters. You might get better on an NBAC task where you might remember numbers. It's a little bit different, but it's the same system. Now, there's a lot of evidence that indicates you don't see far transfer of benefit when you train working memory, but you test, say, long-term memory. You train your short-term memory abilities on an NBAC task, and it might not improve your ability to do a mnemonic discrimination task or something of that nature. But there is still some evidence, and this is where I think music has a lot of potential, where you can train, say, working memory on an NBAC task, and it might improve working memory on other tasks, such as perhaps memory faces. Now, that's a little more realistic and important. I know I forget faces all the time, and if I forgot any of your faces, I apologize. Usually it's about 4 or 5 times before I actually remember someone. And that's why I study memory, trying to beat the clock. So when it comes to cognitive training, there's a lot of different ways that it can be done. More modern technologies will use VR or computers, laptops, tablets, phones, but it could use something just as simple as playing a board game, or, as we're all interested in here, playing a musical instrument. Now, playing a musical instrument taxes a lot of different cognitive, emotional, motor, sensory systems. You can see here that almost the entire brain is engaged. And as you saw from that video at the very beginning, there's always activity going on in all parts of the brain. And so what is interesting here is that if you exercise those abilities, your ability to focus your attention on the instrument, dial in your senses, dial in your auditory senses to listen to the music, your visual senses to read the sheet music, dial in your memories so you can remember what you're supposed to play and how to play it, your sensory motor coordination, and that will evoke emotions. So you're engaging all these things. Hopefully by engaging these systems, you can then benefit, and those systems will perform better when you need them most out in the real world. So and there's, a lot of evidence already out there. Ideally, some more will be coming. But there is, evidence that by engaging these systems through musical training, you can facilitate things such as sensory processing, timing ability or temporal attention, your ability to orient attention in time, short-term memory, long-term memory, episodic memory, processing speed, and even reading fluency in children. So what I would like to do, although all that research is done with traditional musical instrument training, I would like to try to digitize it in some sense, and then assess the potential mechanisms that might underlie those putative cognitive benefits. So now, why would I want to digitize musical training? Well, come on, it's fun. There's a reason why video games is a multi-billion-dollar industry. An intervention is never going to work if you don't do it. So you need something that draws you in, and video games can do that. Also, digitization is affordable, right? So I don't know if you have taken musical training or if you've put your child through lessons. My kids are going through piano lessons right now, and I feel the financial burden. It's expensive to buy a piano. And then, of course, there's the recurring costs of an instructor. That is non-trivial, especially when you have more than one kid. Anyway, it doesn't really matter what the numbers are. The bar graph speaks in and of itself. You see, it's more than just digital cost, right? An app is relatively cheap. Maybe there's a subscription service that could be a regular cost, but it's generally pretty cheap. And it runs on a platform or an instrument that you already have in your pocket, like a phone or a tablet or your computer. And these devices are accessible. Oh my goodness. Yeah, maybe I didn't proof my slides. It looked good once upon a time, but more than 9% of the US population, it's actually 97% of the US population has a mobile device to some extent. 97% of families in the US have access to some mobile technology, whether it's a phone or a tablet or a laptop. And that's 83% worldwide. So digital platforms are a way to reach so many people around the world. So what we've done here is created our first app that we created in this space for music training is what we called Rhythmicity. And you can see it's heavily influenced by Space Invaders for those of you who used to play in the Atari. I'm dating myself clearly. But it's played on a tablet. It's adaptive. So as you get better, it gets harder, which is normal for video games. But as you do poorly, it gets easier. And that's not how a lot of video games work these days. I think it's important that you challenge people right there in their sweet spot so that they're not too not too difficult so that it gets difficult and you get frustrated and quit. But you don't want it too easy. Otherwise, it gets boring and you quit. And Rhythmicity really does challenge your sort of timing abilities, your sensory motor synchronization abilities. These aliens are flying up to the mothership and you tap at the line there. And if you tap at the right time, it'll create a little sound like a drum beat, and it should synchronize with the beat of the music that's going on. And so it challenges your timing abilities. It also challenges your short-term memory. And short-term memory, because those cues, like in this context, you can see there's 3 sets of aliens. Your left hand is tapping on the blue part or the red part of the screen. Your right hand is tapping on the blue. And in this sense, you'd be tap, 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 tap. And eventually those cues go away. And now you have to play that rhythm from memory. And of course, it'll ramp up if you do, better. It'll ramp up to paradiddles such as left, right, left, left, right, left, right, right, left, right, left, left, right, left, right, right. And then we compared that against a control group that just did word search training. We randomized non-musicians, older adults. So these are 60 to 80-year-olds who have never played an instrument, or at least not more than, I think 5 years was our cutoff. They did 2 months of rhythm training, 5 days a week. And then we assessed their timing or their sensory motor synchronization abilities, as well as their short-term memory abilities. Pre-post training, we used EEG to assess the neural mechanisms that might change in response to this training. So these outcomes that we looked at, this is where I'm going to diverge a bit from some of my previous presentations. We looked at different forms of timing. So exogenous timing. This is where timing is sort of spoon-fed to you. In this case, it's a metronome. You can see this ball going back and forth, and you have to synchronize your taps. It's a sensory motor synchronization task. And so the timing is presented from the external environment. So it's exogenous timing. We also addressed endogenous timing. So this is where you're given a cue to say, oh, you know what? I'm going to present a target and it's going to happen about a second from now or 2 seconds from now. And so you have like a short delay and a long delay, and you have to remember what the timing is. There is no external cue to indicate what that duration will be. You just have to remember, what is a short delay? What is a long delay? And then we tested short-term memory with a particular focus on faces. And this task is we just said, I'm going to show you a picture of a face. Here's a face, hold it in memory. And then we asked them, what did you just see? So in terms of exogenous timing, we can see that rhythm training made them more rhythmic. Not terribly surprising. It's kind of cool, though, that they got better at rates that were actually right in line with what would be considered optimal or ideal tempos. So as you get older, those ideal tempos get a little bit slower. If you're younger, it might be a little bit faster. Children find these slow tempos incredibly boring. Older adults find the fast tempos incredibly difficult. And then we localized that to regions that actually Kevin was just speaking to us about. These changes were related to increased synchronization of the brain in this sort of sensory motor network that includes the anterior cingulate, the inferior parietal lobule, as well as premotor cortex. And that was in the delta band, which is the frequency at which a lot of these rhythms exist. Now, endogenous timing, sort of that internal timing, that memory for timing, that didn't actually improve. The higher means you benefit from predictive cues. Younger adults will benefit from these predictive cues, whereas older adults generally don't. And this type of rhythm training did not do that. And why is that? Probably because we trained them on exogenous timing. It did not transfer to endogenous timing. If we wanted to improve endogenous timing, we probably would have had to remove the music from the intervention and let them drum from memory. Let them remember what the rate was. Then in terms of short-term memory, we did see significant improvement following rhythm training. And it turns out that those people who improved the most on their memory for faces were the ones that remembered the rhythms the best. And that was not associated with any sort of neural markers of temporal attention or sensory processing, but rather it was involved in markers associated with memory encoding. And so the P3, if you're interested in it, It's like an neural measure that peaks around 300 milliseconds after the face onset and is localized to an attentional control region, the superior parietal lobule. And then what we did is source localized a random tree classifier to see if we could differentiate whether they were holding faces or scenes in memory. And as it turns out that post-rhythm training, our ability to decode the contents of their memory improved only at the beginning and the end of that maintenance period. So we didn't really facilitate their ability to hold information in memory. We facilitated their ability to encode and decode memory information from memory. And that was, again, localized to the superior parietal lobule, which is an attentional control region of the brain. So we learned a lot from that original rhythmicity app, one of which is that older adults don't necessarily like electronic music. So we created a new app called Coherence, which has a bunch of different genres of music, and you can kind of self-select the music you want to listen to. And then we also developed it so that it could be useful in not just older adults, but hopefully in children. So we deployed this in a couple classrooms, third graders in this context. They did 6 weeks of in-class training, and we were particularly interested not just in sensory motor synchronization, but also reading and math fluency, because others have shown, particularly reading fluency, that music training can improve. So here's just a quick graph showing that, yes, their rhythm training made them more rhythmic, great. But then we did not see any changes in math, but we did see changes in reading fluency, which was pretty exciting, that about a 27% improvement in this particular test compared to a class that didn't get rhythm training. They just got classroom instruction as usual. And those improvements in reading were correlated with improvements in sensory motor synchronization. So those kids who got better in terms of timing were the ones that got better in reading fluency. So now we're basically doing this coherence in children with dyslexia. We're trying to see if children who need the intervention the most are the ones that might actually benefit from it. So we're also doing this in VR because we have some data indicating that a more immersive environment can be more beneficial. So we're doing this in VR with children in dyslexia, and we're also assessing whether coherence might facilitate memory in older adults with mild cognitive impairment. And that's on a tablet. The older adults, unfortunately, don't get the VR. So anyway, just to recap what we've seen here, there seems to be numerous cognitive abilities that could be engaged by the same sort of rhythm training paradigm. It can improve short-term memory for faces in older adults. It can improve reading fluency in children. These improvements can occur through distinct mechanisms. In this case, memory for faces was related to increased superior parietal lobe activity, so it's really facilitating attentional control. Whereas reading fluency was related to rhythmic timing. And that was likely, we didn't do source localization, we didn't have neuro on the kids, but we did it in older adults. And unless their brain drastically reorganized, we would assume that that their changes in reading fluency was related to changes in the sensory motor timing network, which includes the premotor cortex, anterior cingulate, and inferior parietal lobule. So I think it's just, to bring it all together, I think rhythm training can engage multiple cognitive abilities that can improve performance on multiple non-musical cognitive tasks. So I just want to thank the people that made this happen, the people who actually funded it, and thank you for your attention.
All right, can everyone hear me okay?
Yes.
Perfect. Thank you so much. Ted's talk leads quite nicely into mine. Thank you to my UCSF colleague. I also just want to thank USC, Assal, everyone for bringing us together for this lovely day today. I love this community, and it's been so meaningful to be back with my former trainees, these colleagues I love, and everyone who's interested in this work. So thank you. Today, I'm going to talk to you about neural mechanisms of musical improvisation, like how we could use musical creativity for health. So as an introduction, how I'm defining music improvisation, it's a spontaneous creation of music or a form of real-time musical creativity. We think of it as generative creativity. And while that may seem like something magical, if you are a very bad improviser like me, watching someone else improvise, it's actually a neural process that can be examined using rigorous scientific methods. So today I'm going to talk to you about some of our lab's work on the neural substrates of music improvisation, including past studies on adults, my new study on children, and then some in-progress study on older adults. So I know we've heard a lot about fMRI today, but just as a reminder, functional magnetic resonance imaging uses blood oxygen level dependent imaging. What that means is we take the change in neurons' oxygen consumption as an indicator of neural activity. So those areas of the brain that are using up more oxygen are more active during a particular task. Now, as you can see by this scanner picture, it's really hard to perform music in an fMRI scanner, but we have in our lab developed ways to scan jazz musicians as they are improvising, despite the fact that the scanner is noisy, magnetic, and spatially restricted. So in the last 10 years, many scientists, including my mentor Charles Lim, myself, and other labs, have used fMRI to study musical improvisation. Now that could include mentally improvising, singing, playing custom-made non-photomatic keyboards held on your lap, or even playing button boxes. So basically, you'd lie on your lap in the scanner, just moving your hands or mouth to sing while staying really, really still so that we can get a clear image. It's not exactly the most natural thing, but people do it. So by comparing control blocks of memorized pre-learned tunes, so that's the control, versus our experimental blocks where you're improvising, but keeping to the same tempo or harmonic progression, you can start to isolate the brain areas involved in generative musical creativity, like improvisation. And overall, although there's been a lot of variety in like the people studied and how we studied improvisation, these areas are areas of the brain that are involved in improvisation. And what's interesting is we generally see that things like the medial prefrontal cortex, which is very goal-oriented, is involved at the same time that you're also seeing dorsolateral prefrontal cortex, which is kind of turning down your own critical voice or that when you're improvising, allowing you to hit a state of flow. And as not surprising, as we've been hearing today, there's a lot of areas like the premotor, areas of cerebellum involved in improvisation. Now, as a reminder, many of these studies are on the correlates of musical improvisation in older adults, primarily musicians. But what happens if you have no musical training whatsoever? In our study last year, we looked at school-aged children. And here, I think this will be an example of how we're able to study music improvisation in the scanner. We took 9 to 11-year-old kids who were not musicians or had very little musical training, and we scanned them. And we created a paradigm based on the pentatonic scale, which are the 5 black note keys of the keyboard. So for the control task, they just played the notes of the pentatonic scale up and down to a provided backtrack, which gave the beat and the rhythm. And then for the improvised condition, they had to still play those same rhythm and tempo, but now they could play the notes in whatever order they want, thereby improvising really simple melodies. So I'm going to play this so that you can hear it, and you can see that while that may sound boring, we try to make it as realistic as possible to so that with some groove. Scale. So that's just them playing up and down. And here's an example of them playing melodies. Improvise. So the beauty of this design is that with that pentatonic scale and the backtrack that we provided, it literally always sounds good. You can't make a mistake if you just do what we tell you, because it always sounds musical. And that really encouraged our children to dive into the experiment. And incidentally, this is a task often used pedagogically to teach kids how to improvise. It's a beginner paradigm. Now, this is some of our kids getting into the scanner. And we took some, if any of you want to scan children, please come talk to me. We've learned a lot about how to do this. But basically, we prepped all the kids before they got to the scanner about what it was going to sound like. They thought it sounded like a rocket ship blasting off, so they weren't scared of it. Prior to scanning, we also had them work with me in another room with a MIDI keyboard, so they knew what the instructions were going to do, so what they would know what to do when they got into the scanner. And then this is the most fun. I had to teach them how to lie really still, which is hard if you're little. So we played a Lego game. I literally had them lie down on the floor, and I put a Lego on their forehead, and every 30 seconds, I added another Lego. But it only hit 3 minutes, and they loved this, because if they stayed really still and kept all the Legos on their forehead, they got not only they got a special magnet with our lab logo that I had made for them, but I also had little toys in basically a treasure chest, like when you go to the dentist and you get pick out toys. So this was really popular with the kids. So what we saw is it's actually a little different from what we saw in adults. So improvisation was generally associated with deactivation of the brain. So that's why we have all these blue blobs on the brain. And we saw deactivation of limbic, parietal, and auditory areas like the angular gyrus, the precuneus, cingulate cortex, et cetera, as well as this dorsolateral prefrontal cortex. Now, because these children were young and had little no prior musical training, it shows that children can be creative even without any training. And moreover, they're born with an emerging creativity network. Because as in our adult experts, structures like the angular gyrus, the precuneus, and the cingulate cortex are implicated in creativity. So children are using some of these same structures, so they have kind of the roots of the adult creativity network. And more specifically, the angular gyrus, precuneus, and cingulate cortex are all sensory hubs involved in self-referential processing. So the fact that they're deactivating here suggests children are not using self-referential processing or expressing a unique artistic voice. And that's where they're different from mature artists who might use improv as a means of self-expression and creativity. So it's possible that these sensory hubs are present and engaged in children in musical creativity early in childhood. And then with development and additional musical training, they get further refined. And so maybe some of these particular structures may be kind of the neural basis of generative creativity. Now, another important finding from our study was that improvisation engages reward structures more than the control condition, specifically areas like the amygdala, caudate, and nucleus accumbens. And our functional connectivity analysis, which looks at which parts of the brain are working together at the same time, showed stronger correlated activity specifically between the amygdala, anterior cingulate cortex, and supplementary motor area. But there's always a but. The story is not so simple as to say that improv is more rewarding than playing something from memory just because it engaged the reward structures. We have to think about the reward valence, positive or negative, because it reveals a complex story when you hone in on the contrast data. So when the amygdala deactivates, like in our data, that is associated with positive emotion. The amygdala will deactivate once you're over your whole fight or flight response, right? But the caudate, normally activation would be involved in the positive things like anticipation and musical reward. Whereas deactivation, this is what happened in our study, occurs when you missed a reward or when you had a prediction error. And the nucleus accumbens is also a little complicated. Normally, if it were enhanced connectivity, you would have, again, positive reward. But in our case, we saw deactivation, which is actually associated with anhedonia, depression, and harm avoidance. So the amygdala shows positive valence, but the other two do not. So it's not quite so straightforward as what we thought. So why might there be this mixed valence? Well, for one, it's a really novel task in the fMRI scanner. It's a little bit intimidating as a kid to hop into a scanner, and maybe that's why there's some mixed emotions and valence. And improv, as we know, is a very complex kind of process, both cognitively and motorically. But, it's also interesting that maybe music is a safe space to feel the full spectrum of emotions, right? Music might allow the entire emotional spectrum to experience in a way that's not painful or stressful. After all, we don't just listen to happy music. We also like music that lets us feel stress or sadness or other negative valence emotions. And so listening or playing might be a cathartic way to explore those negative emotions. But either way, maybe the biggest takeaway is that improvisation engages the reward system itself. And if improv engages the reward system, that might be why children gravitate towards creative behaviors. They do activities from drawing to cooking to gardening and construction, even though they don't have any prior experience or mastery of these domains. So something I thought about is maybe these results indicate the neural correlates of the beginner's mind. And if you haven't heard this term, it's a term from meditation. And it indicates an attitude of openness and lack of preconceptions, like the idea of having a very ready, flexible mind. Children are the ultimate beginners, and they have no schemas or background knowledge compared to adults, and maybe that's why they are driven to create. And maybe that's why their creativity has such a raw quality compared to an adult master. Now, one major limitation of our study is we can't disentangle the influence of development versus expertise, because most of the neural imaging of improvisation is done in adult jazz professionals. To our knowledge, though, this is the first fMRI investigation of children and creativity, and therefore kind of is a starting point to look at development of creative brain mechanisms with age. And so that kind of leads me to my next point, because this session is about where are we going as a field. So now I'm going to wander into stuff that's ongoing that we don't know as much about. So as I've been saying, we do know that improvisation is a unique neural process from performing pre-learned music that you've memorized and really got mastered. And if you think about musical improvisation as a process, it requires a lot of complicated things. Novel idea generation, cognitive flexibility, self-monitoring, rapid motor execution, because you have to put all your ideas onto the instrument right away. And it's all while being in a state of flow, which is this kind of this optimal state of immersement and creativity. So that made me wonder, could we leverage improvisation for health? We know that in adults, older adults with mild cognitive impairment, which is a preclinical stage between healthy aging and dementia, there's neural dysfunction of structures like the hippocampus, the amygdala, the occipital lobe, precuneus, cingulate cortex, and prefrontal cortex. But musical improvisation actually utilizes many of those specific structures, and therefore it's possible that musical improvisation is a promising avenue as a behavioral intervention to target these brain areas particularly. So we are involved in an NIH-funded project that wanted to investigate the impact of piano improvisation training in older adults with mild cognitive impairment, or MCI. As I said, that's the preclinical stage before you get to Alzheimer's disease. In this overall parent randomized controlled trial, older adults are randomized either to piano improvisation training, a group setting, or an experimental or the music appreciation and listening classes as an active control. Now, these interventions take place in a group format for about 12 weeks, and they're taught by experienced music teachers. In fact, we found teachers through SF Jazz to teach these music improvisation classes. Dr. Julie Johnson is PI of this grant, and Jennifer Bugos, our next speaker, along with Charles Lim, Teresa Allison, and others like myself, are involved. In my particular portion of this larger parent study, we did a very exploratory study where we scanned 8 older adults. Now they had both normal aging and with MCI. And these were all 8 older adults who were randomized to the piano improvisation intervention. What we did is we scanned them both before and after the 12 weeks of piano improvisation training. And while they were in the scanner, they did that same pentatonic beginner paradigm that I showed you before in the child study as a baseline and a post-intervention activity. Now, keep in mind that this is a very small sample size, so this is very preliminary and exploratory. And because of that, we looked closely at the raw data, looking at improvisation compared to rest, where they weren't doing anything, as well as that scale condition compared to rest. And what we found is that relative activation is plotted here in red, and relative deactivation is shown in blue. And we're looking at the impact of the improvisation training by looking at pre versus post. In general, this is speculative, but basically we find that there's reduced activation in auditory, motor, and proprioceptive areas, and increased deactivation in visuospatial areas, along with the angular gyrus. Now, what might that mean? Well, I think it might mean some neural efficiency. We see reduced processing demands to map space to sound because you're doing improvisation training, focusing on mapping space to sound. I also think that the deactivation of the angular gyrus is showing that improvisation training impacted a region involved in creativity. So older adults, even though they had no improv training, were able to hone a creativity center. Now, because I'm very low on time, I'm going to go through this really quickly, but I recently received a KO1 NIH career training grant to also look at improv music therapy for people with dementia and their care partners. Most of the research in music has shown that you can reduce caregiver burden as well as behavioral symptoms of dementia in people with dementia. So things like agitation and lethargy, et cetera. But most interventions target either the caregiver or the person with dementia and not often together. So in mine, I'm going to use improv-based music to tackle the dyad together because I figure they have a reciprocal impact on each other. And my hope is that by using improvisation, it's possible that this will lead to positive emotional regulation and then reducing stress, and therefore lead to positive behavior change in people with mild dementia and their care partners. And overall, in my project, we are doing several refinement things where we make sure there's high satisfaction with improvisation music therapy. We're then going to do a waitlisted controlled pilot study, and then we're going to see, does improv music therapy actually help with stress reduction and emotion regulation? And music therapy, unlike musical training, is where you're working with a board-certified music therapist in trying to achieve a certain goal. And they're all going to play marimbas in this. So this is ongoing. I just got the award in October, so we'll see what happens. But to summarize, basically, what I'm trying to say is that we can measure the creative brain in real time. Improvisation is proving to be a very rich model for studying the neurocorrelates of creativity. And you can use scientific rigor to actually study something like generative artistic creativity. Moreover, we can also, because of the unique neural mechanisms of improvisation, we can start to leverage that for healthy aging in older adults with MCI or dementia. So I want to thank the National Endowment for the Arts and the NIH for supporting my work, and of course, all my colleagues, and thank you for all your attention. Thanks.
Good afternoon. My name is Jennifer Bugas, and our talk is titled Neural Harmony and Music Training on Cognition and Well-Being. And I'd like to thank Assal Habibi for the opportunity to present this work. So you know that music training is commonly associated with enhanced cognitive performance in children and young adults. We've heard a lot about it today. We're going to also hear something about older adults. And so I'm going to be sharing some work with you that about music engagement as a cognitive intervention, and some of the studies that relate to older adult research that we've conducted in our lab in terms of training studies and the randomized controlled trials, as well as some benefits to adults and children and how this maps onto music training on incidental learning and memory encoding. So first off, we know that music training is associated with enhanced executive functions. There's been many cross-sectional studies that suggest this. Strong and Mass found that those that began earlier were associated with higher benefits in visual spatial ability, naming, and executive functions. Alice and Balbag measured twins and found that those that played a musical instrument were associated with less likelihood of dementia or cognitive impairment. And we know that those that participate in choirs tend to demonstrate enhanced verbal flexibility. So we know collectively that these studies support the hypothesis that engagement in musical activities enhances cognitive reserve, and which may promote healthy aging and also may help clinical populations. We know that also that there have been some neurophysiological studies that show benefits. For instance, and the Andrews study suggests that there's been increases in fiber tracts, white matter integrity in musicians compared to non-musicians. And we know that in Yamashita's study, that gray matter volume is greatly increased and larger in musicians as compared to non-musicians, those that have had extensive periods of time training, those in older adulthood. But we know less about novices, older adult novices, and what happens when we provide training to older adult novices. And one hypothesis that we had was that if we were to engage in training that stimulates an area called the cerebellum in the back of the brain that we've heard about earlier today, we stimulate this area, we could possibly stimulate the cortical cerebellar tract, which leads to improvements in executive functions, which is an area thought to be classified as or occurring in the dorsolateral prefrontal cortex. So we tested this hypothesis out in many different studies looking at cognitive and neurophysiology. But first, I wanted to mention that there have been several studies that are experimental studies that have shown the benefits of music training. Particularly, choral music training has been associated with increased mood and less loneliness. Those that experienced 3 months of general music training in older adulthood demonstrated increased sensory responses as compared to those that experienced visual art training or no treatment controls. And we know that drumming, after 4 months of drumming, older adults demonstrated enhanced verbal memory performance. Well, we sought to first test this out with piano training, and this was a while ago. This was published in Aging and Mental Health. But I bring this up because we found longitudinal differences between those adults that were randomly assigned to piano training as compared to those that were in a no treatment control group. And granted, we did control for, have more rigorous controls in our future studies, but this was a pilot. It was published in Aging and Mental Health in 2007. One of the things that we thought was really prominent about this research is you'll notice that there was some increased performance over all 3 time points, even after they were asked to discontinue performance after 6 months of piano training. And you'll notice this was a digit coding task. They increased their performance after all 3 time points. And the figure at the far right-hand side of your screen, notice you decreased their time to complete the task on all 3 time points. Now, this was interesting, but what was also interesting is that the way they sounded afterwards, because all of our adults that enroll in our studies are novices. They've had less than 3 years of prior formal music training, and we screen for their knowledge of music before they come into the study to ensure that they don't have a long background with music training. A lot of people will want to enroll in studies to receive free lessons, which is exciting, but at the same time, we want to make sure we have the right population. And so the other part of this is that after the 6 months of training, they completed a recital. And so at the recital, there was a person that had no previous musical training experience. You're going to hear an excerpt of that. And then you'll hear a quick excerpt of a person that's had a year as a child, and then they were discontinued because their family could not afford lessons.
It's me, oh Lord, standing in the need of prayer. It's me, oh Lord, standing in the need of prayer.
So this individual had no previous musical training. Now, they were the same age. One had 1 year of training as a child and the other one didn't. So something profound was happening. Music is definitely preparing the mind for learning later on, and things will come back. And so we started studying what are the preferences of learners, right? And they have their own motivations. We follow the principles of andragogy, which is the way that adults learn music, which is very different than the way that children learn music. And what learners prefer, what older adults prefer, is to learn as a group, and they prefer to learn, many of them enroll in studies to learn to read music or to learn music theory. So these are some of just some principles of andragogy, of course, is that need to know their relevance. They, of course, have a self-concept and a wealth of prior experiences that they bring to the table, as well as this readiness to learn and orientation to learn, and certainly they're self-motivated. So these are things that we've taken into consideration in all of our studies. And a lot of our studies include group piano training because of that, because group piano training seems to be more preferable to older adults. We do know that in some of our studies and other labs as well have shown that 4 months of group piano training can actually increase verbal fluency. That's the ability to generate words. And it's one of the first symptoms, or decreases in verbal fluency, I should say, are one of the first symptoms in mild cognitive impairment. So it's really profound that we're able to find this after training for 4 months, and that was twice a week for 90 minutes. And then also other labs have found benefits in inhibition and divided attention after 4 months of music training. I also have been testing out intensity-based training paradigms. So what can we learn in terms of our dosage and how much training we have, and then the duration and type of training. So for instance, in the study that's cited up here by Bugus and co-chair, we had an intensity-based program that included 3 hours per day over a 10-day period, in which individuals were asked to practice and perform in terms of a group-based lesson for 3 hours. And afterwards, they completed a series of measures, standard cognitive measures. Also, we see that same area of verbal fluency increases. And in terms of self-efficacy, their self-efficacy shot up after 2 weeks training. Other studies have conducted randomized controlled trials of piano training and have found benefits in terms of speech and noise processing. And one thing that we noticed in our studies and those in others, the key ingredients to a cognitive training intervention include all of these following elements. And I think one of the most important of these elements is that ecological validity. Taking a task and enjoying playing the music, making it meaningful to them is so important. Our participants come out of studies and they're able to play for their grandkids and their significant others, and some go and play for churches afterwards. So it becomes a task that is not just for a study, it's something that becomes part of their life forever. So I think it's so meaningful that music can bring that to the table. All right, so I'm going to shift gears and tell you just about a couple of randomized controlled trials that we've conducted in terms of piano training. We've compared it to Posit Science Brain HQ in a randomized controlled trial where adults were either randomly assigned to Brain HQ, computer cognitive training, piano training, or a no treatment control group. And they completed a course of pre-testing, post-testing, and a follow-up to look at sustainability. And I think one of the things I'd like to mention is that many studies that involve cognitive training fail to measure the training in the learning in the domain. This is one thing that we've been cognizant of measuring each time. So we measured music reading performance. And so this upper slide, the upper part of the slide, that you'll see music reading increased for the piano training group as compared to the other two groups. Which may be not surprising, but at least we taught them something in the domain. In the lower slide, you'll notice that the category switching was significantly increased for the piano training group as compared to the other two groups. And maybe most profoundly, it's important that that you note that the greatest improvements were those that had the lower MoCA scores or lower cognitive scores at the beginning of the trial. So, which is similar to other trials, randomized controlled trials of cognition. All right, we conducted other randomized controlled trials that involved piano training, music listening, and percussion training because we wanted to isolate the effect of the motor component. And we used a bimanual coordination task and found that the piano training group was more synchronized in their coordination as compared to the other two groups. However, the percussion training group demonstrated enhanced rhythmic performance. So there are benefits from both kinds of training. More recently, we've been looking at dosage effects of training, where we recruited a piano training and percussion training group, and both younger adults and older adults. And in looking at how people learn throughout the lifespan in terms of dosage. So if you have 2 classes a week for 90 minutes, and you're asked to practice 30 minutes a day or 3 hours a week, you'll see a benefit over the 12-month period. Every 4 weeks, we measured their cognitive performance and their motor performance. And we see that percussion and piano perform very similarly. However, younger and older adults perform very differently. And so, so it became really apparent to us that, obviously learning is not a linear process for everyone. Obviously, it depends on other factors like age and cognition and previous experiences. And we're still looking through more of the data on this. We've also applied piano training regimens and protocols to clinical populations. And so we recruited older adults who with Parkinson's disease, stage 1 and stage 2, and randomly allocated them to a piano training protocol or a no treatment control condition. And in this case, we found that enhanced performance on the Stroop, less reduced errors, significantly reduced errors, and then also increases in musical self-efficacy. And this was an intense paradigm of a 30-hour training over a 10-day period. We conducted a 9-week trial in patients who are undergoing treatment for breast cancer, who are currently undergoing chemo. And we randomly allocated 2 groups. This was to isolate the social element in piano training. So both groups received piano training and using a standardized manual-based intervention called Keys to Staying Sharp. And they were given 9 weeks of training once a week and asked to practice. And we had a significant increase on the flanker inhibition task for the group versus the individual. And the decrease could be because of the current state of the participants were undergoing chemo at the time. But you notice that some of the interview data suggests the meaning that's making in their lives. So it was very meaningful. Many of which went out and got pianos afterwards. So we've also looked at the stylistic differences in learning jazz and learning other types of training. And of course, my colleague Karen Barrett gave a wonderful talk on the follow-up studies to this. This was the original pilot study that was used to look at the R01 that we have now. But we conducted an intense 10-day intensive program, 3 hours per day, to look at the differences between those that take piano lessons, jazz piano versus no treatment controls. And you'll notice that after 10 days, what can an older adult play after 10 days of intense piano training? Well, I'll show you. This is an example of the 12-bar blues that they play. So that's after 10 days of training. So you'll notice that we also found behavioral data that suggests benefits in terms of inhibition and processing speed and a recruitment of alpha power. All right, so most of our research then has looked at then details of what happens in training studies that were already published. For instance, I looked at neural oscillations in Claude Alain's work, and we found a recruitment of theta, because these things weren't looked at initially in terms of the training studies. So what neural mechanisms are we recruiting during training? And more recently, we've published a paper to look at that memory encoding in non-musicians and older adult musicians, though looking at a cross-sectional design over a 5-tone sequence. And we see a recruitment of enhanced sensory processes for those older adults that currently play music. Also, it's noted that we saw in looking at source analysis, a left lateralization for the groups that, for our musician group compared to the non-musician group. So there's been some benefits in hearing performance. I'm going to skip over this a little bit because we've talked a little bit about that, but our more recent trial is dealing with a random assignment of children 8 to 12 in middle childhood who received music versus visual art versus a no treatment control. We found benefits on their respective achievement activities and enhancements in sense, speech, and noise processing. But that also was a benefit to attention and emotion regulation in young children 8 to 12. And this is after an intense 9-day paradigm, which we had 3 hours per day of piano training. So overall, we know that piano training can preferentially enhance verbal skills, processing speed, bimanual coordination. We know that playing a musical instrument is more beneficial than listening, and that improvisation may help recruit some other areas like parietal alpha. But we also see that these results are pretty prominent, even in the face of some rigorous controls. And I'd like to, of course, thank my colleagues, and then, of course, thank the National Endowment for the Arts Research Labs for their generous support of this research, and my colleagues. Thank you so much for your attention.
Anywhere.
All right. So while we're getting situated, we have about 10 minutes for questions, but to get us started, I wanted to push back a little bit. We heard a lot about the positive findings related to music training and FAR transfer. However, I'd like to push again on that and ask if, first of all, if you all think that there's a reproducibility problem here, and if so, what might potentially explain these inconsistencies or contradictions in the literature? Anyone can start. Yeah, it's a tough one. I might have opened.
The answer is yes. Yeah, no, I think small sample size. I think that's a problem. Obviously, we need bigger trials, and I think another problem is fidelity of the intervention or what you're doing. There's a lot of details to any sort of music-based intervention, so it's unclear if what a lab did and published, you try to replicate that. Sometimes it's not exactly how it was done. Different populations can respond differently to interventions. There's a lot of different reasons why you might have replication issues. I'll be publishing a paper soon showing that coherence didn't seem to work in healthy young adults.
There's also a lot of noise in the, I would say, the review articles that sort of don't consider all of these details in terms of the type of training and then the type of instrument that's used. I mean, there are a lot of studies lump musicians into one category, one size fits all, and that's not the way it is. Actually, training is very specialized.
And I'd also like to add that for those of us doing music-based interventions, we are, with the NIH's help, trying to make this music as medicine more rigorous and really reproducible. So the work of Assal, Emmeline, Miriam, and others, we now have reporting guidelines and toolboxes. So if you are going to do a music-based intervention, you should be categorizing exactly how you did it, for how long, the dosage, the format. So we're hoping that in the future, rather than us all having all these smaller pilot studies, smaller sample size, we'll be moving towards more rigorous studies that can be reproduced.
Yeah, and I think there's also two important dimensions. The fact that it's a social environment and it's very motivating. We know that helps learning no matter what. But then also the aspect of having very specific predictions about specific outcomes, about components of music. There's much more hope in finding results and effects that way. For example, combining rhythmic training with executive functioning, or for pitch-based training with phonological awareness. We're already starting to see that some studies are doing this, and they're finding very direct links between specific relationships. So I think there's more hope in looking at that, and also incorporating individual differences, as we saw in some of the data too. That's really important. Just try to tailor more specifically now to smaller groups exactly where we want to improve.
And to expand on what you had said, Karen, about being very clear with your methods and everyone reporting sort of the same thing, there will be a paper coming out very soon from the Music Research Networks. I think this was led by Sherry Robb, and they have a music taxonomy, so that we're all using the same language. So when we're trying to describe something, we actually have very specific verbiage to use that has very explicit meanings, and that makes it a lot easier for us to replicate what we're doing.
Great time here, Vani.
Haley?
Thank you so much. My question's for Karen. Mad respect to anyone putting kids in MRI. Like, hard for me to imagine. I'm curious about your sense for how intentional the children's improvisations were able to be, because I'm wondering if there's a possibility that, like you said, it all kind of sounds pretty good and you can kind of play randomly, and then you're really more doing a response to what you're hearing as opposed to any kind of planning, maybe potentially. And so I'm curious if you have a sense, if you ask them, or if you have some other way of sort of measuring or getting at whether they produced what they intended to produce, or if they were surprised by what came out.
That's a really good question, and one that I get often. So the instructions were to improvise a new melody, and I just make up a melody that you want. Now, as anyone who's tried to improvise before, sometimes you don't know what to do. And I was like, look, if you get really stuck, just repeat a note until you figure out what you're going to do next, right? And so that one is the example I gave was maybe a more musical version, but there were some where people are like, okay, I'm going to keep the note until I figure out what next to do. That's also a good point too, is that this project let them hear themselves playing. So auditory feedback was totally a big deal. We are actually collaborating with a group out of both Italy and Malta who's looking at the effect of auditory feedback on improvisation in the brain, because I do think the kids were like, oh, I could do this and this sounds good. From a design perspective, because these were kids, for many of them, they had never even seen a piano keyboard before. So like when I sat outside the scanner with them, I said, put their little hands on the keyboard. That was their first time ever doing it. So we had to try to think of something that was very encouraging and warm and things like that. And yes, for anyone who is scanning kids in fMRI, there were tons of little breaks for snacks and potties and everything. So this was my postdoc project, and I'm done. I'm not doing kids again. So just in case anyone asks me if there's a follow-up project, no. Not for me anyways.
We have time for about one more.
One more.
Thank you all for your incredible presentations. And we were just remarking on oh my gosh, the sheer amount of work that goes into this is mind blowing. This is actually maybe kind of a follow-up to the question that you were asking, but I guess where do you see these studies on that sort of efficacy to effectiveness kind of pipelines? And what do you think it would take? Are you looking to move more towards that effectiveness research? Because I'm hearing your training paradigms and I'm I want to take lessons from each of you. And then I can think about all the shortcomings I would bring to, not playing 3 hours a day and things like that. So yeah, maybe I would love to hear how you might be moving towards that effectiveness.
Well, I guess having a digital intervention as we do, it makes it a little bit easier to blur the line between effectiveness and efficacy. So the research we're doing right now is all completely remote. So we are now mailing tablets to people and letting them do the entire intervention. The pre-measures, the post-measures, everything is done at home. So we never actually really engage with our participants. So that's, in our mind, kind of efficacy. I mean, yes, we're there to support them, so it's a hybrid somewhere between effectiveness and efficacy.
And I think that in our interventions, we try to test out pieces of it before we start to ensure that that the intervention is delivered appropriately. And we also look at fidelity, even to make sure that the standardization of the manual is intact and it's going to work for that population. So Keys to Staying Sharp worked for those with Parkinson's, and it worked for some with breast cancer. But then we also have separate ones for different age groups and different ability groups. So, for instance, when I developed the program for Julene Johnson's project, that took into consideration, we were training those with MCI, and we had to test out pieces of that. We took a lot of time to prepare. I prepared 16 weeks of the intervention. It was tested out by I'd say at least 6 other professionals in the SF Jazz to look at the intervention itself. And I arranged a lot of pieces in that particular intervention to ensure that they were able to be fingered pretty easily for them, be able to play them easily, but also to be able to move smoothly with the voice leading was appropriate, et cetera. So a lot of testing out to ensure that and looking at feasibility of the training.
And I will say, because I had to rush through my KO1 slides, I will say that mine is not fully powered right now. I don't intend for it to be fully powered to test full effectiveness and efficacy. So my plan is first to just start with, get some high satisfaction with developing intervention, codifying it on the intervention manual for rigor, and then using that waitlisted control pilot study to get some preliminary numbers. So it's just going to give me preliminary effect sizes, things like that, with the idea that I will then later apply for bigger funding, NIH, et cetera, Alzheimer's Association, to actually do something fully powered. So it's kind of like I'm doing it in baby steps.
Oh, yeah. I mean, I think for these longitudinal studies that are much longer, there's a lot more risk and a lot more variability, and different populations. There's a lot of work being done beforehand with piloting and feasibility, meeting the parents and the family and seeing how well they respond to the interventions. There's different phases, but we don't necessarily get funded for everything from the beginning. So once the first phase works, then you can lock in a second phase once you look at preliminary data. So it's a very long process. Everything's very well documented, organized, registered beforehand. And then we have to track fidelity throughout the entire process. So we have people coming in and observing all the sessions externally, rating, level of social responsiveness, how much music was taught, how much music was taught in the control group, for example, to make sure that, they're different. Or if there's changes to be made along the way, then you can adjust. We need to measure quality of the instruction that's being done by each instructor. There's really, this is a giant piece of work to do. And so I think that, we have a lot to learn still, but the more we can publish about, these procedures, the more we can harmonize our procedures. And then ultimately, we want to be doing some multi-site work here where we're coordinated, we can increase our sample size and be as harmonized as possible. And I think we're at that stage now. We have, we can see we have a lot of evidence, neural, behavioral, we're all converging around the same themes. So now we need to start thinking a little bit bigger, I think, and more coordinated.
All right, thank you. So if you have any other questions, I'd encourage you to write them down and then ask and get in contact with our speakers later on. But for now, we'll be transitioning into the next talk from Veronica Alvarez.
Thank you, wonderful panelists. I am reminded to remind you all that the summit at the LA Opera is happening tomorrow, and you can still register at the laopera.summit.org. It's the accumulation of events of arts and health in Los Angeles County, and multiple great speakers and panelists will be there as well tomorrow. So we are moving from the space of science and data to space of implementation and practice and policy. It's my great pleasure to introduce our next speaker, Dr. Veronica Alvarez, who's the Executive Director of Create California, which is a statewide leader in advancing arts education policy and access across California. She'll provide us with an update on the current state of the arts education in California and discuss how recent policy initiatives are shaping opportunities for students across the state. Let's welcome her.
Thank you, everyone. It's my pleasure to be here. Thank you for Dr. Habibi for inviting me. And thank you to my colleague, Abe Flores, who's provided immense leadership in this area. And since I'm the first non-brain scientist, I think, to speak, I think I was brought to let you all know that Mexico won 2-0 in the I was born in Mexico. So. As Dr. Habibi said, I'm representing Create California. We advocate for high quality arts education for students. And earlier today we were talking about access, and that's what we do. We advocate for equitable access for all students in the state of California. And because the history of the state of arts education in California is very complex and slow, just like our voting, I thought I would show you a very quick video of what it meant to, we did a very brief history of arts education in the state of California.
Hi, I'm Veronica, Executive Director at Create California.
And I'm Ricky Abeles, Program Director.
And we're going to put our educator hats on to give you a very fast history lesson on why arts education isn't where it should be.
Spoiler alert, it involves some bad policy decisions, glimmers of hope, and one massive win. Here we go. 1970, the Ryan Act. California quietly removes arts training requirements for elementary school teachers. Just gone. No mandate, no training, no accountability.
1978, Proposition 13. School funding collapses overnight. California goes from 5th in the nation for arts education funding to 47th.
Yeah, not cute. And can you guess what got cut first? That's right, the arts. Music, field trips, color me shocked.
In the 80s and 90s, leaders like Willie Brown and Delane Easton tried to fix it.
Thanks, fam.
But without sustained funding, it didn't stick.
2001, No Child Left Behind.
Standardization gets creativity and individualism. If it wasn't on a standardized test, it got pushed aside. Arts education, forgotten. Meanwhile, researchers were hard at work to prove the positive impact of the arts on youth.
And what did they find?
Arts education improves academic outcomes. It supports mental health and social-emotional learning. It builds creativity, collaboration, and civic engagement.
Evidence was there, but the political will wasn't. So, in 2017, we launched the Public Will campaign because data doesn't move policy alone. People do. And then,
in 2022, California voters overwhelmingly passed Proposition 28, nearly $1 billion for arts education in schools every year. But here's the thing, the money only works when it's spent the right way, equitably, transparently, and in compliance with the law.
That's what we're working on every single day at Create California. And that Public Will campaign is still going strong because this only works if the public stays loud.
If you care about creativity,
if you care about student mental health,
if you care about equity,
go to createcalifornia.org, sign up, learn more about Prop 28, and use our tools. Hold your districts accountable.
Let's make sure that California schools become creative incubators that kids can't wait to walk into every morning. So we wanted to show that video to say a thank you to all of you because it is your research that helps us do our work. It helps us advocate for policy and it helps us in terms of building equity, It's, as you can imagine, as many of you have said, people's family lives, students, socioeconomic background provides access to students. And so heavily reliance on local public and private funds depends on arts education and equity, allowing affluent districts to offer more robust programs, and high-stakes testing and narrow accountability crowds out the arts. So if you're a Californian, I hope you voted for Prop 28 because I will judge you if you did not. And for those of you that are in California, this is just a quick primer of what Prop 28 is. As we mentioned, it provides $1 billion. It's a statewide permanent funding resource for pre-K to 12th grade. And low-income students receive additional funds. It
it has to increase art spending. If a school had arts already, it was meant to increase whatever arts they were providing. And there was an 80-20 requirement. It meant that 80% of the funds had to be used to hire credentialed arts teachers. 20% could be used for other things like equipment, musical instruments, field trips, things like that. And then accountability. Schools must report how those funds were spent. So June 30th, in just a few weeks, the first year allocations are supposed to be reported. However, implementation is, the voters were very clear on the intent. It had to be sustained, protected funding. However, and access has expanded. That's a really positive outcome of all of this, especially in elementary grades. And investment in qualified arts teachers to deliver standards-based arts instructors have all increased. And it has been a rallying point for arts education. Now we have a huge thing, like there's funding usually, as people have mentioned before, the arts get cut first, and now we're like, there's funding available. However, $1 billion is not enough. So community perspective, our work deals a lot with advocates throughout the state. We mobilize our parent advocates, schools, teachers, districts. There's a lot of optimism. However, there is some confusion about whether school sites are seeing increases in funding. There's changing roles, especially the community arts organizations. A lot of community arts were providing that arts education that was not happening in the schools. They have been severely impacted by Prop 28. And then we try to provide a critical friend to our advocates to balance equity, empathy, for school districts, fiscal and operational challenges, while still trying to adhere to the Prop 28. So these are just very quick implementation. As I meant, it was a do not supplant. Schools were supposed to supplement, not supplant. There's still some confusion around that. There is declining enrollment and how that impacts budget shortfalls and rural school districts. So a lot of the challenges that we're finding within settings and urban settings, rural school districts are even more exacerbated. And then accountability and transparency. As I mentioned, there's the reporting. The reporting is a little bit vague. And as we talked about, we did this hearing in Sacramento. There's one person in the Department of Education in California that is overseeing this $1 billion funding. And then arts education teacher recruitment and pathways. We see that as a huge growth opportunity because what this has allowed and what we have found is that in order to fully implement Prop 28, the state of California has to hire about 5,000 teachers, and across the state, universities are graduating about 600 to 700 annually. And then we want to promote promising practice, strategic planning. What we find is if there is someone like an arts administrator that is leading a strategic planning process so school districts know what those funds should be spent on, that's where we find the most success. And so I want to highlight some of the successes of some school districts. For example, Long Beach hired itinerant art teachers from all arts disciplines in all 35 of the elementary schools. Middle schools, they hired positions. And now what that has meant is that every student in Long Beach Unified gets arts instruction from K through 12th grade. So what's next? We said $1 billion annually, but it's not enough. Implementation across the state has been uneven. We do need clearer guidance and stronger education workforce strategies and pathways and better data. So what we do at Create California, as I mentioned, we highlight some policy goals and we provide, we wanted for this year to provide clear statutory administrative guidance on how to consistently invest in Prop 28. And we were successful. I think we have to go back to on Wednesday, right, Abe? To advocate for this bill, AB 244, is we were asking for clarity on the do not supplant requirement, what funds could be used for supplant and supplement. We wanted to ensure that funds meet the state standards and improve data and transparency. And a big part of what we want to do is obviously strengthen the arts educator workforce pipeline. So just to go very quickly, another part that we really do is data and research.
We also lost NEA funding, and so we did a statewide qualitative and quantitative analysis of the impact of Prop 28. As we said, we did some qualitative stuff with interviews and attendees, and then we did a statewide quantitative survey. And we were able to get representation from most counties, and these are the respondents. We got mostly at the school level, but I mentioned a lot of arts organizations. And what we found is the primary uses of Prop 28 are to purchase art supplies, hire increased arts educators, and field trips. And these are some of the challenges that we're still finding with groups, and we've separated it by county, district, and school. But as you could see, competing academic priorities, as we mentioned, when funding gets cut, what are those priorities? But the lack of credentialed staff to teach the arts was pretty consistent. And so to wrap up, and what I wanted to wrap up with is how can we empower teachers to apply the evidence-based strategies that were discussed today? I come from the visual arts, and the work that I've been doing, I specifically work with multilingual learners in the arts. That's what my dissertation was on. And so I've done a lot of work with arts integration, arts and my multilingual learners, arts and SEL, as a lot of you talked about with self-regulation. That is one of the SEL competencies that teachers are trying to train, that I think we need to train teachers on, where teachers have expressed that they need additional training with. Arts and culturally sustaining pedagogy. The arts are such an amazing opportunity for us in this very divisive world. The arts connect us across time, across culture, across media, and then arts and healing, as what you all described today. So I'll end with this quote, but again, it's like how can we support teachers as critical partners in this work? How can we adapt the science that you all expressed today to the art of teaching? Because they're the ones that are seeing all of the students that we all want to benefit from the arts. So thank you.
Thank you, Veronica. Okay, great. Our next speaker is Dr. Joy Allen, Executive Director of the Sound Health Alliance, whose work has helped advance national conversation on the intersection of music, health, and well-being. Today, she will share perspectives on emerging opportunities for collaboration and the growing role of arts and health initiatives in research, practice, and public engagement. Let's welcome Joy.
As I get set up, just take a moment if you need to move around a little bit and stretch, because I know we've been sitting for a moment. So, all right. I'm Joy Allen. I'm a music therapist by training. And how many of you know about music therapy? A lot more than back in the day, but what music therapists are really good at is learning how to speak to so many different disciplines and sectors. What I have to say, what I do to a CEO of a hospital is much different what I have to say to the patient who's in pain, who I've been referred to see, which is much different than the funder who I'm asking to help fund new program development, which is much different from a scientist who is saying, how does this work? So it's that translation that really comes into play that we really need to do. And as you're hearing over and over today, is how do we put this all together to make sense and have a party through music, right? So I think, okay, there it goes. I think one of the things that we can all agree about is that we know music works. There is evidence. Of all the arts, music has the most and strongest and most stringent evidence base about how we can use it in different ways. We've heard a lot about childhood learning. We've heard a little bit about older adults, but I encourage you to think about domain levels, how music impacts you physically, how music impacts you emotionally, socially, spiritually, behaviorally, and how that is about really not about becoming necessarily the next Grammy-winning artist, that would be nice, but how it really connects to flourishing. Because at the end of the day, all of us are going to struggle in one way, shape, or form, right? We're going to have those ups and downs. In some ways, if you think about your heartbeat, keeps you alive. I want to think about it in a positive way, but it's also why we know music can work in those different areas. So we have evidence silos. And we're like, okay, so this was great that this worked, but how does that translate into helping my loved one? Or we know that there's a gap between theory and practice. We've heard a lot of basic science, but how are the clinicians using it in the hospitals? How are artists using it in their communities? Or how are you using it in your everyday lives? How many of you use music for your own motivation? How many of you use music to help connect with a loved one? But how many of you, if I just said music works for dementia, would say like, okay, now what? How do I do that? So the whole point being is that evidence alone doesn't drive adoption. And how do we work together to really look at evidence, raise awareness, but also see where the implementation gaps are? And that's really what we're hoping to do with the Sound Health Alliance, or what we're calling Sound Health 2.0. So I think many of you know about the Sound Health Network and the unfortunate happenings with funding. And many people who were involved in that were very excited about finally having conversations from all those different entities. So the Sound Health Alliance, what we're really doing is trying to build that back up, but also look at it from an action-oriented standpoint. We know this, but how do we put it into action? How do we make sure the healthcare leaders have the evidence summaries, the implementation models, the evaluation frameworks on how you to define success? How do policymakers have population evidence, economic impact? How do funders look and judge on scalable models, field priorities? How does the everyday caretaker say, okay, how can I help me? How can I help my loved one? How do community organizations see where they can have an impact in their communities and improve the lives of those that they're working with? How do everyday people use this? So really what we're trying to do is really have that shared language, the practical resources, the public engagements, and the cross-sector activities that are needed. So we're anchoring it at Berkeley, Berkeley College of Music in Boston, not UC Berkeley. So why Berkeley? Because one of the things, again, we have one of the largest undergrad music therapy programs worldwide in music therapy. We have the Music and Health Institute, which is all about cross-sector and cross-discipline engagement. We're in Boston. We always integrating with Harvard and MIT, technology, biotech, pharmaceutical companies, artists, and communities. So it makes sense that we can anchor it here. In hindsight, I wish I would have put up here about some of the stuff that was already in place before we started taking this. And that one of those big things is the Music and Health Research Repository. That repository has a taxonomy where you can search by conditions. And we're saying conditions because this is, again, how do we take all of this knowledge and put it into action for human impact? So you can search. We have collections. Because one of the things that often happens is, where do you find the evidence? If I'm a doctor, I might be going to the New England Journal of Medicine. If I'm a nurse, I might be going to the nursing journals, counselor going to counseling. We put them all together so that you don't have to worry about what database, or more importantly, you might not even have access to the databases. If you're not working in academia, if you're a clinician in the field and not connected, how do you access that? So we put the collections together, and you can search and built a taxonomy that you can search by setting, by outcome, by type of music intervention, by expertise, by area of practice. That collection now has specialized within it, where you can now search by music and cancer, music and substance use and abuse, music and mental health, music and anxiety, music and Parkinson's, music and dementia. So we built these to make it easier for people to see where the evidence is, but also see the cross-sector nature and the cross-discipline nature of how that connects theory to practice, from basic science to applied, but also where there's gaps for more learning and bringing in technology and more training programs to help increase the number of programs that are out there. So how does this work in real world? We start with that taxonomy and we say, okay, we have all of these articles, 370 on just music and substance use. Doesn't sound like a lot, but if you think about how much is out there and how we put it into play. If I go to the CEO of a community health center and he says, okay, but where's the evidence? I just have to point to it.
Is he going to read all 360 articles? No, but it opens the door for a further conversation. Then we develop research briefs and we say, here's how it works within substance use, from the biophysical to the psycho-emotional to the psycho-spiritual, that same language that people use within substance use treatment. Then we can have further conversations. What does a program look like from harm reduction to detox, to residential, to long-term peer recovery, and how music is being used in some of the very ways that we're talking about today. So even knowing that rhythm helps ground and regulate heartbeat, which is very intentional with what happens during detox. You're not regulated, and how we can use that. So it's an example of how we use the briefs. Then bringing that into toolkits. So using the example of a toolkit is saying, okay, if we're talking about music and dementia, how does it work? What are the things that I need to know if I was going to implement a program? Where are the resources at my disposal? Then I can further take that into the research brief and say, what about music, sleep, and dementia, music, agitation, and dementia, music and cognition, and bringing that information together so it's more digestible for people. That same information, if we think about even today, not to put anyone on the spot, if we have a toolkit on music and dementia, we can automatically say, yeah, electronic music might not be the best. Lower the key signature, slightly lower the tempo. Here's ways to engage so that it's saving time, but more importantly, putting immediate access to tools that we know work. From there, we're really focusing in on regional convenings. Very condition specific on purpose, because again, we've had lots of conversations about how music works. Now we need to see it in action. So we just had a recent one on Parkinson's in New York City, intentionally putting scientists, clinicians, practitioners, community organizations, and musicians together to paint the picture from research to practice, but also to work on field building within those areas, because oftentimes people don't know who are the people in your neighborhood. And that way they can continue those conversations. But at the end of every convening is roundtable discussions. Roundtable discussions are important because they help tell us what they feel is most important. What do you feel like is needed to move this forward? Do we need more trainings? Do we need more programs? Do we need more information? But it allows people to be engaged and be part of the conversation. So we're not talking just at, we're engaging with. So webinars to continue those conversations. So for example, just with the convening in music and Parkinson's, there'll be a series of webinars this fall on music, Parkinson's, and speech and communication, music, Parkinson's, and movement. Again, tying in those areas that people were most interested in finding out more information, but putting it into digestible ways of information sharing. To then creating the digital platform so that when people are looking for information, they can easily find it. So that we can say, here's music and dementia, here's ways to get trained, here's ways that our programs are existing. Here's organizations that you can go to. Here's research labs that exist. Again, knowledge is power, and putting it, we're not recreating anything. We're packaging it so that it's no matter what your expertise, no matter what industry, that you have access to the information. So creating that pipeline of circularization. So we know this works here. We can measure that impact back. When we're looking about, again, I'll go back to dementia, we see what happens in a community choir. What outcomes are really important for the Public Health Commission to know in your city? How is that going to then feed back into, okay, we don't have good measures of that. Let's put that back into the research lab so we can have better measures. Or let's connect that back to this person's also doing similar work and how we can feed that information. So again, looking for that evidence to practice to the evidence to practice to evidence pipeline. I don't know why I put evidence to evidence pipeline, but it's evidence to practice to evidence pipeline. You get what I mean. That's what happens when you do slides late at night. But it's about not only just having that evidence, but whose evidence counts and how do we define success? And those are the conversations that are important in the different spaces that we work in. So how do we ensure integrity of this information? And it's through that dual governance model. We have an advisory board made up of nationally recognized leaders who help ensure that whenever we create a toolkit or a research brief, that it's actually factually based, But then we throw it to the organizational partners and say, is this in a language that makes sense for you? That's really key, right? Because why put something out there if it's not going to be usable? You can see our advisory board. Neuroscience, clinical practice, creative workforce, community practice, and public voices. You can see the organizational partners that are involved who help sure that implementation expertise and field connectivity, helping us see what is out there, but also helping us host those convenings and making sure that we're staying true to what it is that they need in order to continue to meet their member needs. Those organizations up there alone have over 150,000 members. That starts to develop tributaries of information. So that again, that information flow becomes continuous in moving the field forward. So at the end of the day, it's about systemic catalyst. It's about making, as the field matures, making sure that from the theory to practice, from the science to the implementation, to the different voices that need to be heard and included, to also to optimizing that massive opportunity for innovation, because there's a major gap from clinic to practice and from clinic to community in how we work, so that we can start working together, but also understanding what it is that we might need in order to do that. If I don't know what I'm looking for, it becomes really hard to put it into play. So that systemic catalyst about really moving forward with increasing access for not only ourselves and whatever role that we play, but making sure that we have access for our communities and for people who might not even have the opportunity to be engaged, but their level of expertise is so important to the very work that all of us do. So from a fragmented landscape to a coordinated field, the Sound Health Alliance is continuing the foundation that the Sound Health Network so beautifully laid with mobilizing the neuroscience community into helping to improve public access to information by making sure that we continue to take the actions necessary to put the information in the hands of the people that can continue moving this momentum forward. Thank you.
So much. We're going to take a 10-minute break. Please be back before 3:30. We have two fantastic panels for the end of the day. And I heard that there's coffee and more drinks outside. Like to freshen up. Okay, we're going to get started. And you want to hear about this because it's about money. So come back. So as we move to the late half of the afternoon, we are shifting our focus toward an issue that is critical for the future of the field: funding priorities and research support. Scientific progress depends not only on good ideas and rigorous methods, but also on partnership among researchers, foundations, government agencies, and community organizations. We are very fortunate to have leaders from several major funding organizations with us today to discuss priorities, opportunities, and future direction for arts and health research. To guide this discussion, I am pleased to introduce our session chair, Dr. William Coppola.
Hello, everyone. My name is Will Coppola. I am the Associate Professor and Chair of Music Teaching and Learning here at USC. I am one of the black sheep here yes, I'm in the music world, but I'm the philosopher, wannabe philosopher at that. So thanks for letting me join you all. So I guess we'll advance forward. Perfect. So we're just going to open with some opening remarks first, and then we'll follow up with a panel discussion and make sure we save some time for questions from all of you. So we will start first. Let's start with Kevin Cluck, who is the VP of Operations and General Counsel, the Foundation for the NIH. That's okay. Right, and then once we do our opening remarks, we can just grab a seat in the middle and have a conversation. Thank you.
There you go. So William started out by saying, he's crashing the party as philosopher. I can double down on that, Matt. I'm the lawyer. So, and I'll try to go against type by keeping this rather short because I'm really excited to hear from Sunil and Wen, who've been great partners in the original version of the Sound Health initiative. And have really enjoyed working together. So what I want to do with my short time with you is give you just a couple of minutes on the foundation for the NIH. I've had a good opportunity to talk to many of you over the last 24 hours. I said I didn't know NIH had a foundation, so let's all get up to speed together. Then I'll give you a short anecdote and end by talking about the program that Renee talked about at the very beginning of the session, which I hope will be very exciting to you. So starting with NIH, we know and appreciate that NIH is the greatest biomedical research agency in the world. Evidence of that is plain today. There is an NIH logo at the end of every presentation that we've seen today, and that's appropriate. Of all the drugs approved by FDA during the decade of the 2010s, over 99% of them had funding originate from NIH. That's extraordinary, and it's hard to imagine the biomedical research enterprise without that. So Congress created the foundation for the NIH to support the NIH mission and to create and lead public-private partnerships to advance the biomedical breakthroughs. And how do we do that? So we convene research partnerships that bridge NIH scientists with those from life sciences companies, universities, and philanthropies. We raise private sector money for the public good. Over the last 5 years, we've raised $14 from the private sector for every $1 of operational support we get from the federal government. That's a great deal for the American taxpayer. And we manage relationships and project timelines to drive results. So let me talk about the program a little bit, start with an anecdote. 15 days ago, I didn't know if I would be here. And the reason is that I was sitting in the neurology unit of the University of Rochester Medical Center because one of my parents had fallen, had 2 hematomas, and ended up going into brain surgery twice in 3 days at the age of 82. And as a coming out of that, you can imagine an 82-year-old person going through 2 brain surgeries of probably, having a hard time coping with that. And I had an idea that Wednesday after Memorial Day to bring a little speaker, and I put it on his table in front of him and just played some music that he really likes. And you could see him visibly relax as it soothed him. And I think a lot of us have these experiences, and we've talked about that we instinctively know that music can reach people in moments when other interventions can't. And so the question becomes, what if we could move the experience, as this group has already started to do, from anecdote to rigorous science and improve patient care? And so that's the ambition of the Music as Medicine Neuroscience Research Initiative. The program is built to advance serious neuroscience research at the intersection of music, brain, and patient care. We're talking about conditions where the need is enormous: Parkinson's disease, Alzheimer's disease, depression, and any number of neurological conditions that affect not just patients, but their families as well. For centuries, we know people have used music for comfort and healing. And now the science that you're putting together and bringing to us is beginning to explain why, how rhythm and melody and memory and attention and emotion interact in the brain, and how those insights could shape recovery and quality of life. The power of this initiative is that it does not treat music as a soft extra. It treats it as a serious frontier for discovery. So this project is housed at the Foundation for the NIH and will be guided by a world-class scientific selection committee, as you now know, chaired by Dr. Habibi. And when we are public with the rest of that committee, you'll recognize a lot of those names as well. And the program will support high potential research through a disciplined grant process. It has extraordinary momentum. It's being advanced by an unusual coalition of the arts, sciences, philanthropy, and communications. That includes Renee, thank you, as well as FNIH board member Jim Weiss, Grateful Dead founding member Mickey Hart, and biotech and biotech executive and investor Paul Secretary. And that combination is rare, but it's what a field like this needs: rigor, imagination, resources, and a cross-disciplinary approach. So the opportunities in front of us to help build that evidence base for this category of care, to build on the work that you so ably have done. Next month, we're going to invite you to apply for support from this. And also with a new round of philanthropic investment, we can sustain this for many years to come. So I hope you will see this as both inspiring and actionable. We know that music matters, but now we can get coordinated support behind the work to really accelerate things. I put a couple QR codes here on the screen where you can contact me, or you can find more information about the program. I invite you to join us and our champions to see this through. And thank you for the work that so many of you are doing. Thank you.
Out of order?
Yeah, it's okay.
Sorry.
Good evening.
It would have made more sense to just go in order from the slides, but yeah. Philosophers make things difficult. There you go. Great. Okay, now we'll follow the order. Okay, now we have Dr. Wen Chen, who is the director of the Division of Extramural Research at NCCIH and NIH. So welcome. Thank you very much.
Hi, good afternoon, everyone. First of all, I wanted to thank Renée and Assal for inviting me to be here. Really, it's just such a joy to be with everyone. So you just heard from Kevin about Foundation for the NIH. So you might wonder, what does NIH do? So I'm going to tell you a little bit about what one of the 27 institutes and centers at NIH called the National Center for Complementary and Integrative Health, and what we are trying to do in terms of supporting research on music and health and the related art forms. So, gosh. Here it is. This is a diagram that we typically show to the general public about what NCCH is all about. You will see the, okay, yes. So you might wonder, what does the NCCH study? And we actually sort of, we're basically intervention centers. We study therapies, interventions, and we kind of bucket them into three categories. We call physical approaches, like massage, that kind of, and then psychological approaches like meditation, and then nutritional approaches that like a herbal medicine. Just to give you, just name a few. That's not trying to be comprehensive. But so where does music-based intervention sit? I think in our mind, it kind of sits between the physical approaches and the psychological approaches, and it is within the mission of NCCH as a form of non-pharmacological intervention. And the way we study them is we're trying to understand the biological effects of those interventions, their impact on the whole person, which I'll delve into a little bit more later, and their clinical effects, how to implement them, implementation, and whether they're safe. And then all of this is really trying to target issues like symptom management, like pain, depression, anxiety, stress, and then well-being of a person, health restoration. If you get sick, how do you get better? And then health promotion. How can we get, if we're good, how can we be better? Or we're not so great, how can we be better? So that's really what NCCH is really about, and how this is relevant to music-based interventions. Okay, let's see if I can. Now, I want to go into a little bit more about that whole person health research. And this is something NCCH have been developing in the past 6 or 7 years, and it's part of our past strategic plan. And interestingly, it's being adopted by the National Health Research Priority in terms of Make America Healthy Again as well. So we're kind of very flattered for being sort of co-opted into that National Health Research Strategy called Whole Person Health Research. And this is how we define what whole person health research is all about. So it is really trying to study a whole person, the impact on the whole person from microbial, immune, musculoskeletal system, all the way to brain, psychological, and social interventions. It's really comprehensively about a whole person, not studying just parts. So we're not just studying heart, not just studying the brain, we're studying every system together. And in that spectrum between health and disease. And also, we're not just studying individuals, we're studying individuals in terms of their biological, behavioral, social, environmental context. And we also study them as a family or in the community and a bigger scale in terms of at the population level. So that's sort of the NCCH definition of whole person health for the last 7 years. And another sort of priority topic at NCCHA we've been pursuing is called interception. It's actually sort of a newer concept, but it's an old concept that being sort of revamped a little bit in the last few years. And interception is really the idea of the interaction between the brain and the body, how our brain sense what's going on inside our body and regulate those signals. So it is, we have been really thinking about interception as sort of a central mechanism that could be utilized to study whole person health as well. And that's being, the concept being sort of described in the paper that was published last year in PLOS Biology. And in terms of how it is relevant for music and music-based interventions is if we consider music-based interventions one form of complementary integrative health interventions or therapies, what we would really like to encourage the community to study is to look at its impact, not just on the brain, not just on the particular organ, but sort of maybe look at the interactions between brain and different parts of the body. And that's what we call the interception. And here's sort of the brain in the center and with multiple organ systems around. You can pick one of them or you can pick multiple of them, depending on what your scientific question is about. And what we're really trying to do is to encourage scientists and investigators to really utilize and develop new technology that can help us to map, to measure very precisely what are the reactions in the interceptive processes, monitor, map the location, the anatomical location, monitor the responses and modulate its effect in human and model systems. And most importantly, we would like to enhance the research rigor. We want people to really define the anatomical specificity, look at the temporal position, as well as the quantitative dosing of the interventions. And some of those ideas were mentioned earlier during the talks today. So I think this is really a recapitulation or synthesis of those ideas. And most importantly, we wanted to see when, if we can modulate the interceptive process, how would that impact what we call a whole person health index? And this is a new index that was developed by our former director, Dr. Ellen Langevin. It's a very nice 5-minute questionnaire. I certainly encourage people to think about incorporating that in your studies. Because it really just asks 9 domain questions about your diet, physical activity, sleep, stress, your social networks, and the meaning and purpose, health management, quality of life, and overall health. And this will give you a sense of how well your whole person health is at any given time or in response to intervention. So at NCCH, we actually support 2 general categories of science, scientific research or biomedical research. One we call it the fundamental and translational science. That's really looking at many different scales from genetic, epigenetic studies, which we heard a little bit today earlier in some of the talks, molecular processes, tissue, level, organ, physiological analysis, behavioral, social, and environmental. And this is a kind of scale. Investigators can pick any one of the scale to look at the impact of music and music-based interventions, or they can do a multi-scale analysis. Obviously, that will get very complicated. To really support this kind of approach, we have funded 3 research networks. specifically on music and music-based interventions, in particular in the context of pain and chronic pain management. And those are music for pain network, ensemble, and audio and analgesia. Many of you I know are being sort of associated, affiliated with one of those networks, and that is really wonderful. And this is sort of what we consider as a launching pad for the most highly innovative ideas to be tested before it can be competitive as a research program at NIH. So the next sort of like the other side of research is on the real world impact of complementary health approaches, and that's highly relevant to music and music-based interventions in terms of, can we collect the real-world data, look at the real-world evidence and their usage in healthcare, and we have quite a few programs that supports this. And I want to just to highlight one of them. It's called NIH-wide Dissemination and Implementation Research in Health Funding Opportunities. So these are actually active funding opportunities. I certainly encourage people to, take a picture of it and look into that. I'm happy to talk to you, afterwards or reach out to me later. But these are really wonderful opportunities for you to study how to disseminate and implement music-based interventions in real-world settings. I'm going to skip this next slide because it's kind of how to make it competitive. We may have to talk about this offline. But at the end, I wanted to share this slide with you just to give you a quick overview of some of the funding opportunities that's currently active that NIH support music research. And I also wanted to emphasize that it is, NIH is going towards a very investigator-initiated research program. So this is not trying to restrict the type of research you wanted to do. It's just give you a sampling of what may be available. And you are always welcome to pursue your own passion idea and submit an application to NIH. There are many different, what we call a parent announcement that are available for people to submit application to. So with that, I'm going to end my presentation. I guess we will talk about questions later. And here is the slide on my contact information, and I'm happy to talk to you anytime after today. Yes.
Wonderful. Thank you, Wen. And then to our third discussant today is Sunil Iyengar from the NEA, the Director of Research and Analysis. Is that right? Research analysis. That's it.
Thanks. So interoception sounds like a Christopher Nolan movie. Actually, it was great. I wanted to, of course, like everyone, I put heartfelt thanks to Assal and to Renée. Assal, I really think that musical interlude was really great. I think a lot of us, it's still resonant in our mind, what we experienced. So thank you for having that. As often those things are forgotten in convenings about music, of all things. Before I go forward, I just wanted to make some quick overview notes since I've been had the pleasure of listening to so many great presentations with all of you. Well, Assal, of course, is the director of one of our NEA research labs. We're very proud of the work she and Kevin are doing and others in the lab. But I also wanted to say, since I was asked today to speak about arts and health priorities rather than specifically music, although I'll refer to them, of course, I did want, is this hyperactive or maybe I'm too quick at the draw here?
Yeah, just click once and give
Oh,
it a
no,
moment.
okay.
There you go.
I don't want that. Back. Okay. Stay. All right. So I want to just say that, a couple of quick notes if I could. So I'm not going to be mentioning them because, these are some of the music labs we're funding other than the ones I might mention. You heard Vani talk about the work with Zakir Hussain at Charles Lim and Karen Barrett's lab, UCSF. We're very proud to be supporting that lab. Also Jennifer Bugos, of course, you heard at University of South Florida. And also, they're not here, but Tony Brandt and Christopher Fagundes at Rice University, where we support a lab focused on music and mild cognitive impairment. So great work there. And then I just want to also add, and I think you saw some of this with what Kevin was saying, We're trying to all be intentional insofar as we can as funders and cognizant of what each other is doing. And there's a great collegial environment right now among us funders, which we've been trying to hold on to. And I think that, the way we regard our work, and maybe this is also true of the Renée Fleming Foundation's work, is sort of part of the pipeline into funding for larger grants and larger awards that ultimately we hope will result, at least on our side, we hope, some large scale randomized controlled studies and or quasi-experimental studies, probably waitlist control studies in things like arts education or music and education, for example, or any of these other, some of the therapeutic outcomes. But one of the signs of success or the key performance indicator for us is if our grantees turn around and get funding from other sources. We're really privileged to hear about all this great cross-fertilization. And lastly, we were at part of the Music and Health Research Network convening earlier this week, and Borna Bonak-Darpour from Northwestern University was talking about how a research grant we awarded to support research into Alzheimer's and music has gone on to use that pilot data, I think, for NIH funding. So we want to see more of that. So keep it up. And I will promise you I'll get on with the presentation, but just two more quick notes. I think Joy, when we heard you, Joy, where are you? We heard your work. I think at least and I think Wen, and I'm guessing Emmeline, we could breathe a little bit more easier knowing that Sound Health Network legacy and the Alliance work is continuing, because that's so important, that translational work. And my last note is simply that those of you who want to know about arts education work, because I'm going to be talking about arts and health briefly, we do support something called the Arts Education Partnership. We do that with the U.S. Department of Education. It's a coalition of arts education service organizations, including in music. And I think they need to be brought in and involved, and I'll try to help to do that too. So briefly, just some of our priority areas. So, well, first, in our strategic plan this year, it came out early this year, many of you know that the National Endowment for the Arts, our goal and our mission is really to purvey the arts and make sure as many people throughout the country have an opportunity to engage with the arts as possible. But we made it very explicit in this plan that it's also to promote the benefits of the arts to everyone. And so we do that primarily through supporting arts and health programs, as it turns out. And we also do that through research. So that's part of our kind of MO for why we do what we do. These are some of the priority areas, and it's not meant to be exclusive, but these are the key things that our leadership right now is big on in terms of supporting the arts and health. And I have to say, Marianne Carter, our chair, we were lucky to work with under the first Trump administration as well, has been extremely supportive of arts and health and of research. And some key populations or conditions we're interested in is how the arts and health relate to military personnel, veterans and their families. Some of you know the NEA supports with Departments of Defense and Veterans Affairs, a program called Creative Forces, which embeds creative arts therapists into clinical care settings in military treatment facilities and VA hospitals. We're also studying that and conducting research and evaluation. Pediatric cancer care and other childhood diseases is another one. We're going to be next February, having a big convening to look into research into that, particularly creative arts therapies, working with a large children's hospital. Opioid use prevention, treatment, and recovery. We actually released a report 5 years ago, and we're in the process of updating it with new data. And we are actually supporting one of the music and health research networks focused on, it's audio and analgesia, so pain management. So those are some of the things coming down the pipeline. Disaster relief and emergency response, how the arts can help with that. Care of older adults experiencing cognitive degenerative declines. I would also add social emotional withdrawal that goes with that, and learners with intellectual disabilities or autism on the autism spectrum. Sorry, that's reversed. So our two major funding programs are research grants in the arts, which support individual studies that investigate the value or impact of the arts. And as it happens, we are not only supporting grants supporting music or the arts and health, we're actually looking into the arts in a variety of other dimensions. Community planning, civic engagement, education are some of the big ones, cognition, learning, the economy. But we do have a large proportion of our grants in arts and health, and these are all require a one-to-one match, but those can be in-kind matches as well. So 20,000 to 100,000 for those awards. And then the NEA research labs are meant to be multi-year projects that often go beyond just one study and then also have maybe other deliverables along the way. And so for that, we're awarding we raised the amount from 100,000 up to 300,000 now being awarded. So those are two awards that we have. And again, I see this as part of the pipeline. They also are, they come out at the beginning of every year is when our guidelines come out. So we are a once a year kind of program. And I'm just going to spend the remaining time very briefly kind of dancing over, skating over some findings. And it's going to be very superficial the way I'm delivering it, but I want you to be aware of some of what we've been doing. Because, in the past, I used to show a big list. Renee or others have been seeing me talk before. I've shown people we've been funding, but now I figured we've been funding for some of them for quite a while. So you might want to know what they've been doing. So one of them is the University of Colorado at Denver, which looks at programs to improve arts programming to reduce burnout and psychological distress among healthcare workers, particularly among medical trainees. And they found that over a 12-week creative arts program that various forms of arts interventions versus controls reduced anxiety, depression, and emotional exhaustion, and improved turnover, intentionally reduced it among healthcare professionals. And this is something they also did in non-patient facing healthcare workers. And they've done various other things that have come out of it. They had a big exhibit at the Association of American Medical Colleges showing their work. They did an online lecture series. And this work is really important, especially during COVID, we discovered how important this was. And it ultimately improves care delivery. Another one is at the Icahn School of Medicine at Mount Sinai. This is done, I should have mentioned the other one is Mark Moss, working with a bunch of creative arts organizations in Colorado. This one is Dr. Joanne Lowy, who working with Carnegie Hall, a Wild Music Institute, 3rd Street Music School. And I don't kid you, John Baptiste is actually a partner, which is pretty cool, musician. So the research focus there, she's working on various populations, looking at the social emotional benefits to treat people with depression in various conditions that begat depression, if you will. And some key findings. So far, they've done one randomized waitlist control study. It's a relatively new lab, but they've already found significant decreases in depression and increased resilience compared to the control group. And they actually have created some really good tools for researchers, a tour of the room, music psychotherapy assessment protocol. They've done a series of well-being music concerts with Carnegie Hall, and they've developed a social music as prescription tool, which actually John Baptiste was active in. University of Florida, they've been in the news a lot with their research findings. Most recently, they had a study dealing with, you may know Daisy Fancourt. She's over at University College London. She's a partner. And they did some work around showing how arts engagement presumably can slow down the clock, if you will, in aging, looking at epigenetic markers. And they've done a lot of different studies. They do largely secondary data analyses, looking at large-scale longitudinal studies, particularly in the UK and the US. They've also produced a bunch of other materials, such as a guide to social prescribing and other tools like that. And finally, and that was Jill Sankey, the PI. Vanderbilt, we of course heard from Miriam, so I won't go over this too much, but these are some of the great accomplishments Miriam has done. She's already spoken about it, but we're very proud of her work and having supported her for many years. I actually said finally, sorry, this is the last one. Drexel University, they have the Arts and Chronic Stress Lab. This is probably one of our longest running labs where they've been working, originally Yoka Brat was on the team. Now it's Girija Kamal and working with Tracy's Kids in New York and a couple of hospitals looking at, particularly again, I mentioned pediatric cancer care and how the arts, open studio art therapy is related to positive affect, self-efficacy, and creative agency for kids in these really stressful conditions. And they've also produced a conceptual framework for research in this area. So we are hoping to influence metadata and research tools just as we influence actual findings. So happy to talk about any of this or anything else. Oh, wanted to welcome on board 2 new research labs we just announced. One is Children's Hospital Medical Center of Akron, where it's Nicole Robinson, our first lab dealing with narrative medicine for children, families, and health professionals. And a great program here by Emory University, Madeline Hackney, who's looking at tango dance for Parkinson's disease patients. And she's looking also at other neurodegenerative disorders and how this program can improve mood, cognition and gait and other kinds of outcomes. So very proud of this work. I would like to say we seem to have recovered a little bit from last year. We're very active now, and I think my presence here hopefully attests to our willingness and interest in continually engaging with you all. So thank you so much.
All right, thank you so much. If I can have our panelists join me down here at the seats. We have some microphones as well.
Yeah, I have a panelist.
I'll take this one. Okay, so naturally we'll have way more to discuss than the time we have. So please, if we don't get to all of your questions, save them and we'll continue the conversation for sure. I'll just start it off and then maybe we'll bounce around a little bit. But there's throughout the entire day today, especially in several of your commentary, there's been kind of themes of change, some continued uncertainty. This is definitely a pivotal moment in our as researchers and as funders and such. And so I wonder, looking forward, looking back, what do you think right now makes this time such an important time to be doing research in this area in music or the arts and health? That makes right now unique.
Just the moment you said that, I realized that one thing that I think we all recognize, we're in a climate now when behavioral health is a little bit more elevated, I think, for example, in government funding and interest in lifestyle improvements and also non-pharmacological dependence. So I think those are some things, dynamics that may strengthen our ability to do this work rather than deplete from it, despite all the other maybe you're alluding to other turbulence, but that's something which we're kind of clinging on to as a real motive to continue this work in a very visible way.
Thank you.
Yeah, I wanted to echo what Sunil just said. That is absolutely true that the non-pharmacological lifestyle type of interventions are really on the rise. It's definitely getting a lot of attention within the NIH, and certainly NCCH, the type of intervention we're supporting are have a lot of gain a lot of attention internally for sure. So I wanted to point out, and I share with some of you sort of offline a little bit, but I think it's safe to say that the recently currently NIH is developing its new strategic plan, and actually one of the topics that was discussed was asked at the webinar, the public webinar, to get public input during this process is about music and health intervention research, and I was actually quite involved in helping to provide answers to the leadership at NIH. So I think that's I think that really bodes well in some ways, that I think this is the type of intervention that NIH leadership is still very interested in supporting. And on the other, and also we are there is definitely part of the NIH is going to more investigator-initiated research. You will probably see fewer specialized funding opportunities. It will be more what we call the pair announcement that will be utilized for people to submit applications. If you have great ideas, I would say just submit them. I mean, there's a bit of cap, like 6 application per year per PI. But that's just to trying to level the playing field a bit more. And certainly there's a strong emphasis on gold standard science. So rigor and reproducibility is very high, a priority within the NIH. And also our NIH director, as also supported by many institute directors, are implementing the unified funding strategies. If people haven't read about that, and I think that's a really great area for you to pay attention to, just so that your area of research as you prepare for your application are fully aligned with the priorities that are described in those unified funding strategies and the NIH priority topic areas. They're very big topic areas categorically. I think probably everybody can agree those are important directions. So it's just a matter of provide the right framing as you present your proposal and applications.
And to conclude, why now? I mean, we've heard it in the stories that have been presented, and I know in the next panel, we're going to hear more of those stories. And I think the public instinctively understands the importance of music, but the public also wants to understand why. You know, in the public health field, you know, communicating with the public, you're supposed to explain what you know, explain what you don't know, and then explain how you're going to find out what you don't know. And so much of the work we heard today is we're on that pathway of figuring these things out. So how do we make it consumable to a public that wants science to show the work? So, but there is real clamor for it.
Absolutely. I love that final point there. Actually, I was going to ask, well, 1,000 more questions, but given our time, I actually want to open it up to the audience if they have any questions to start with, and if not, I can always ask some more.
I can project, but thank you. Really great talks, and I'm going to unfortunately ask something that's maybe a little off topic, but yeah, here we go. So you're all funding really amazing research, and I appreciate what you're doing, and I always think about what's next, right? So you have all this great corpus of research, and we say we believe in this, that, and the next intervention or this program. How do you get reimbursement from, say, government agencies, insurance companies, and things of that nature? Are there things that your entities can do to interact so to bridge the gap between these interventions and actually getting them reimbursed so that they're actually being implemented by music therapists and teachers and such?
Yeah, that's a different agency within the Department of Human Health Services. That topic, that would what we call the Center for Medicare and Medicaid Services and CMS. I know they have, from what I know, they have funding. They have funding opportunity on the street right now too. It's like a whole person health elevate, and that's really very much in line with the kind of research you're pursuing. And I think they are really trying to get the evidence so that they can make decisions about insurance coverage. That's my understanding. So I am not affiliated with them at all, and I'm probably speaking out of my bounds already. But that's what I read on the news, and so I think there's probably a bigger coordination that beyond just NIH. At the department level, but yeah, so it takes a little time.
Well, to that point though, community science, we're all trying to work together, you know, and be open science, we can replicate. So does there need to be more integration within the government so that these independent agencies are providing insurance coverage based on the research that they want to see? So if there was more crosstalk between these agencies, then
there are. I'm pretty sure there are, and I probably should be more active on that part myself too. Yeah, but I think it's ongoing. I think it's developing, and I know I've heard some of you already learn about that Whole Person Health Elevate program, and I would encourage, if you work anything related to it, I definitely strongly encourage you to pursue those funding opportunities.
So the moment I heard about Elevate, before it was on the street, I called the program officer, told them about what we do, shared this information, and learned that it's an extremely rigorous, of course, selection criteria. And I nevertheless emailed to people out in the field about that opportunity. But I do think you're right, like there needs to be, and as one is saying, there needs to be some community, some better integration. I do think one challenge is, I think we don't want to be too reductionist, but I think we have to choose an indication or choose a very like razor edge therapeutic program or approach to really drill down into and try to obtain, if you want to, reimbursement for that. Because I think the way these coverage decisions are made, the way reimbursement decisions are made, it's often for a very specific program or intervention, not for generically, and I know you're not saying this, for music therapy at large or something. It has to be for a very specific use. And I think that takes some consensus building in the field and some coming together with, we want to all rally around a particular use case. And so I still think it comes back to some of the other things you talked about definitions and that.
Okay, we have time for maybe one more question. I see somebody all the way in the back.
Hi, I'm a neurologist who's a Parkinson's specialist at UCLA. I work at the VA as well. I'm not a researcher, but I'm taking care of patients all the time, and they're very interested in a lot of these approaches. The issue that I have in some ways with being so reductionistic and so mechanistically driven with research and funding is that as somebody who's really cheerleaded lifestyle approaches, I have a background in integrative medicine. I, think that music hits when we put those sort of circles up. And I've worked at the VA, so I know Dr. Langevin and her, all these bubbles and like, where does this fit? I mean, I think that music is so cross-cutting. Some of the stuff that was talked about is like, does the social aspect then confound the part of this brain part and that brain part? But like, the truth is that it hits so many things. You have sometimes spirituality, sometimes social connection, sometimes movement, sometimes breath work. There's so many things that music really does, right? And to then say, we're just going to take this little part and study it in this one disease and then have this indication with this specific music intervention, it's quite painful, honestly, for those of us that are in the real world trying to help your average veteran who used to be a jazz musician who is losing, parts of his cognition to really live better, with what we have today with the evidence. So I really urge you, and we're finally honestly at a place with Parkinson's, at least I'm heading a wellness task force, right? This is a bit long. At the Movement Disorder Study, it's an international society where we're coming up with lifestyle choices that Parkinson's patients can do for themselves to live better every day, even in places where we don't have even basic medicines to give. Like, so sub-Saharan Africa, we can't give levodopa, which is like the cheapest medicine. So how can we think about, sleep, diet, exercise can all impact each other, like social connection impacts all of the above. So many of these lifestyle choices actually can, sort of amplify each other. And I think it is very hard to just be very reductionistic, and it becomes sort of painful actually to see just this study on this little piece. So.
Yeah, maybe. Maybe I can help to address you are absolutely right. I think I hope I wasn't trying to show a reductionist approach in my talk. And I think what I was trying to say is exactly what you're trying to express, is that we are moving towards a more holistic, integrative way of looking at a whole person, not just one part, not just one molecule, not just one event. It's sort of how the whole person reacts integratively. Now, absolutely, that's very unconventional, right? For those of us who are trained more classically, we are really trying, we're literally at this very special time trying to figure out methodologically how we can do that rigorously. And I think that's a challenge for the whole community, whole biomedical research community to figure it out. I think we have the framework, we have the vision. We are trying to encourage the whole community to work together to develop this new way of research, what we call the whole person health research.
Could I just, actually, Kevin, you said that it was very important to, that you think most people know the benefits in a way. And I feel we in research sometimes overlook that. Maybe I'm not to overstate how much people associate music with positive outcomes, but if the public themselves are clamoring for this in a way that's much more integrative, I think hopefully funding and policy aligns with those needs rather than it being dictated by a reductionist view.
Well, and people fill in the blanks with their worst fears. Even if something works, you'd like to understand why it works. It's certainly if you're going to rely on it for your well-being.
For resource allocation. Sure. Yeah.
Absolutely. Thank you so much to our panelists. That is our time, but please continue the conversation beyond this panel. We're going to move on to our next session.
Sorry about that. That'd be great. Thank you.
No, I'm just benefiting from.
Yeah, so, yeah, I mean, I'm
We are coming to our final panel.
No, I'm actually fine.
And today we've heard this recurring themes throughout the day that one of the gaps in our field is really translation, and how these discoveries, wonderful findings we all heard today, can translate into meaningful action in communities, in educational settings, and healthcare settings, and really in real world. Our final panel addresses these challenges exactly. Scientific findings can only influence society when they're effectively communicated, interpreted, and meaningfully shared with public. So I'm delighted to turn the stage to Renée Fleming to moderate and chair this panel. My understanding is that each of our speakers are going to first introduce themselves and their organization, and then Renée will kindly moderate the next discussion.
Hello, welcome. How are you? My name is Tushar Swain. I am Director of Public Policy at, oh, that is a big picture. I'm Director of Public Policy at Americans for the Arts. We are an advocacy, research, and convening organization located in Washington, D.C. I'd like to say we got our chops advocating for National Endowment for the Arts funding, particularly in the 90s during the culture wars, but we have certainly expanded our portfolio to include all of the cultural agencies, tax issues, nonprofit finance issues, arts education. And just delighted to be here today and to talk to you all for a little bit. Thanks for having me.
Okay, good afternoon. So Dr. Habibi got in touch with me last week and said, I'd like you to come to California to sum up the policy and political environment for the arts and healthcare in like 2 minutes or less. So I think that's why I'm like almost last here. But no, really, it's an honor to be here. And my name is Andrew McPherson, and I'm a founding principal and managing partner at Healthsperian. We're a Washington, D.C. based health policy, data analytics, and government affairs consulting firm. I was invited, I think, today because I'm also the founder of the Foundation for Social Connection Action Network. We've heard social connection be talked about quite a bit this afternoon, actually, and so I'm thrilled to follow up on some of that. Before I sit down and before we turn to my friend and colleague, Kaylee, so I live in Washington, D.C. I've lived on Capitol Hill for like 25 years or so. As I'm listening to this conversation today, we're spending $1 billion a year, maybe or so, on everything we're talking about in this room. We spent $5.6 trillion on healthcare last year in this country, 20% of GDP. So as we have our discussion together this afternoon, I really want to frame up what was talked about in the last panel, which is how can we combine the resources of our healthcare, insurance, and public health infrastructure in this country with art, the creative arts, and music therapy. Now, we heard from our friends on the panel before that there's some extraordinary research happening, and thank you, all of you, for your work and leadership on that. We got a long way to go, though. And I would argue that we have sort of a built-in public health infrastructure already in this country. That is community-based live events, music, choir, art therapy. We need to be building on the resources of the public health infrastructure in order to fund the type of work that you all have proved can change lives and improve outcomes. So I'm kind of the lowly lobbyist today. Unfortunately, there's like 535 people in Washington, 435 members of the House, 100 members of the Senate that are going to be really very much the decision makers on whether that gets done or not, but I have some ideas for how to do it. So thanks so much for having me.
These are really huge photos. I'm Kaylee Toll. I'd like to start off by breaking the ice a little bit. No, my name is not cut off. My maiden name is Tolman. My married name is Toll. And yes, I did just happen to meet and marry someone with the last name Toll. This is my lifelong sentence, but it's worth it. So I'm a philanthropist. It's not what I planned. I went to USC. I studied international relations, and I went after my dream job in government, and I worked in the national security space for a little over a decade. I left that work several years ago to build and run our family office. We focus on many different things in our philanthropy and our political advocacy, our investments, but the unifying feature has to do with human potential. Where is it being thwarted? Where can it be uplifted? And so we have a really all over the place kind of portfolio. And in fact, came to music and arts and education by way of workforce, which is why I am extremely confident that there are many other philanthropists like me that we can bring into the fold if we get the storytelling right, if we translate the research into language that feels accessible and inclusive, if we use trusted messengers. So those are some of the things that I care a lot about in philanthropy, is trying to better organize this space and have more of a coalition approach so that we can streamline our resources and use our time and expertise wisely. There is not one person in this room who is not busting their butt for their work, but we can do a much better job if we align, if we coordinate, and if we collaborate. I'll just briefly mention a couple years ago, I founded an organization with John Ondrasik of Five for Fighting. I don't know if anyone knows that band, called Let Music Fill My World. We are on a mission to ensure that every student in America has access to and the ability to participate in music education in school. Every year, we fully fund a music educator at a school where there isn't one for multiple years. And then we work with that school and district to ensure that there's sustainable funding down the line. I've really enjoyed that work, and I felt like in some ways it was a drop in the bucket. You see the incredible impact in these schools and these communities, but then what? How does that fit into the bigger picture? And how are we actually solving the problem? Which is what led to setting up the Music Impact Coalition earlier this year. So I imagine we'll talk a little bit more about that, Renee. But the last thing I'll just mention is, when I think about philanthropy, I think that there are few philanthropists that want to fund art that is good, and there are many more that want to fund art that does good. And like we heard earlier, I want to be a part of helping to translate where and how music and art does good. Thank you.
Thank you. So what a fantastic day. Oh, fascinating. Every single presentation was so amazing. And so I want to start with you, Kaylee, because of what you just talked about. We definitely have to somehow figure out how we get this message out. And, you know, we're kind of the advocacy panel right here. And after a long day of hearing about amazing work, and I know from my own career, I was the worst person. You know, I didn't even really have a website. I just wasn't looking at that. I was looking at what I had to do day to day. And I think that's probably true for most of us. But I'd love from your talk about this coalition that you're talking about, because I think that's so important to take local, and this to some degree, that's what the NEA has always done, is to take local fantastic organizations and lift them.
Well, I think you're right. Sometimes the best advocates for music and arts are not arts advocates themselves. And I think we have to, as much as possible, be a little less precious about the way that we message and storytell, and think about who we're not reaching and why, and challenge ourselves to find those trusted messengers. Maybe it's military leaders, maybe it's CEOs, scientists, who are the other people that can share why music and arts education have made such a vital impact to that person's ability to thrive. So with the Music Impact Coalition, this is a group of national organizations. There's over 20 of us now, and we are aligned on the mission to ensure that we coordinate across research, philanthropy, advocacy, storytelling. And as you said, we operate really with a national and local model. It's not like national down, local up. It's just kind of all over the place, building the plane as we fly it, because time is of the essence. And there are a lot of things that we know about what's going well on the ground. There's also a lot of really clear gaps and opportunities. So, for example, we're launching this fall in North Carolina. We've partnered with the state, with the North Carolina Arts Council, Arts North Carolina, Department of Public Instruction. Collaboratively, we've selected 8 districts, one representing each unique geographic region in North Carolina. We've also taken into account other factors like demographics, the size of the districts. All of those districts now are ongoing MEDS, which you all may be familiar with through Mr. Holland's Opus, essentially a very comprehensive district level analysis. And once we have those results, we will create a strategic granting plan. And that will include local investment and then national, where we can supplement. But this is all about sustainability. So our family has put in $2 million to get this off the ground. And what's really exciting is there are a lot of other funders that are in the wings saying, when we get those results back, we are most interested in instruments or equipment. We are most interested in teacher development, because there are more funders like our family who didn't start out with music and arts as a core investment priority, but came to it because there's so much potential. And if you really care about systemic change and you're willing to experiment and think a little out of the box, then this is the moment. I think we have a very unique moment that I hope we'll talk a little more about later.
Well, and I love that you're bringing small organizations together and providing funding for them, but also kind of helping them understand how to message what they're doing. Tushar, I'm going to skip you for a second, Andrew. Tushar, what is the actual funding situation in terms of nationwide right now?
So
10 times today. So
sure. No, so I think we all know about the Doge cuts that occurred last year. Lots of people that I've talked to today were adversely affected by those grants cuts. There were also just a huge amount of staff cuts, which also is affecting the disbursement of those funds. So after USAID and the Department of Education, which I would argue is a cultural agency. There's a lot of arts education programming there. But after those two, then it was our cultural agencies, staff-wise, that were hit the hardest, if you include the National Endowment for the Arts, the National Endowment for the Humanities, and Institute of Museum and Library Services. And so issuing those grants has been a little bit difficult. The good news is because of the work of arts advocates across the country, we were able to maintain level funding for those agencies this year. Just a testament to the work that those advocates do, as well as the work that you all do, because they take that work, they take it to their member of Congress as an example of why the arts are important. And I'm not just saying this because Sunil is looking right at me, but but the leadership of the NEA, it truly has been a master class in terms of how to navigate these Doge cuts. And we had Chair Miriam Carter at our AFTACON conference last year talking about the importance of social prescribing and something that she thinks is something that is potentially that we could have in common in terms of both sides of the aisle.
Talk about social prescribing for a minute. Is it growing as a movement? Will we see more of it?
Yeah, I mean, there are, it's certainly growing at the state level. I think that, certainly, so Medicaid has their section 1115 waivers. There are I think maybe you would maybe know more than me, Andrew, but I think maybe 5 states that are at least doing, maybe not being called social prescribing, but focusing on things like social determinants of health. And so I think
Massachusetts, Rhode Island, is Ohio in now, or what are the states?
I think Ohio is in, North Carolina, California.
Great.
So, yeah.
Okay. Fantastic. Well, I would love to see more of that, absolutely. But I would also really love to see some of our military budget go back to the NEA. That would be great. And the NIH. I mean, I just think the work that you did, that incredible Heal Thrive, that conference just blew my mind to see what was happening on the local level around the country a couple of years ago. So Andrew, tell me how you became interested in this and became passionate about your organization you founded, about loneliness and isolation.
Yeah, thank you so much. I'm passionate about anything that will change people's lives, and I built a career around that. Healthsperian runs now 15 national not-for-profit organizations we make $0 on that are just issues that we're passionate about. I started and founded the Foundation for Social Connection Action Network in 2018. We were not talking about isolation then. We were not talking about loneliness. This is before the pandemic. Why did I start it then? Because I have the unique sort of pleasure, honor, if you will, to be sitting at a perch where if you start to see the academic community developing research, in this case, decades of research around social isolation, loneliness, and social connection. And then you start to see markets moving. So major health plans piloting, venture money moving in. That means there's something happening out there, and Congress was paying zero attention to this issue. Nobody could define what social isolation and loneliness were in Washington, or that social connection was meaningful. So we got 10 organizations together, Renee, in 2018 around a table. We've got 70 national organizations involved now. Mental behavioral health, consumer, patient advocate, health plan, tech innovator, you name it, they're involved. Why is that important? It's important because the best way to get anything done in Washington is to, it sounds cheesy, but it's true, to work together. Multi-stakeholder coalitions. This is a great room. Incredible, obviously, incredible amount of research going on here, and powerful group here, and USC is doing extraordinary work that Washington's paying attention to. However, we need to bring in other voices. We need to bring in patients. We need to bring in consumers. We need to bring in conservative voices. We need to bring in liberal voices, and that's what we've done. So we've got 150 policy recommendations on our website. This is a really complex issue to social isolation, loneliness. Half of Americans are socially isolated and or lonely. Why does that matter? Who cares? It's not in the DSM with the American Psychiatric Association. It matters because if you're lonely or isolated, you're 29% more likely to die. If you're lonely or isolated, you're much more likely to have dementia, Alzheimer's, heart disease, diabetes, the list goes on. This is a serious, serious problem, Renee. And when you start to peel the onion back on this one, you realize what we're really talking about here is not just a health issue or a mental health issue. We're talking about a societal issue. And I would argue that music and the creative arts plays not just like some ancillary role, I think it plays like a central role to bringing people together in communities across the nation to have a creative experience together. And that's what Kaylee is doing as well with her coalition. So that's what we're up to in Washington. And by the way, we're making progress. We've got 12 pieces of legislation introduced now, almost all of them bipartisan. Next week, I'm going to be hosting Dr. Oz. Who's heard of Dr. Oz? Okay. Talking about CMS, right? What's he talking about? He's talking about the work that CMS is doing on loneliness that we advocated for. The Elevate model was just mentioned. Social connection is called out in the model. It's not a ton of money, but it's a step in the right direction. There's other ways that you're going to get funded as well through Medicare Advantage supplemental benefits. We talked about Medicaid briefly, and I can go on and on. So again, we got to bring health, Renee, together with the creative arts. And I think we're actually on a path to doing so.
Well, I've been trying to do this locally in my own way. As I perform around the country, I invite healthcare to the performing arts venue and we share information like we did today. And so many relationships have been formed because we're all service providers for those communities. So it really works. But I think we need to get you on board with helping this whole coalition, don't you think? I mean, this is so important to have things happen in Washington. I got to go with the Grammys on the Hill and tour around, and it just shocked me how few people there are in power. There are a lot of millions of interns running around, but it can be done. So smart. Okay, we're going to take your questions now. Well, I have 3 pages of questions here, but I know we only have 10 more minutes. So go
Renee,
ahead.
can I say one quick thing though?
Of course.
This is just based on Andrew, what you shared. I think that the future is about integration, and we've heard so much about coordination and collaboration, but I think the idea of integration and making things accessible, whether that's the research or the storytelling, is so crucial. And I would argue that we could all challenge ourselves to think about if the way that we're discussing some of these topics, whether that's our organizations alone or the actual language that we're using, is actually achieving the end goals that we hope for. And I mean, even something like, people talk so much about how music and arts are very valuable to building soft skills. I hate the term soft skills. And by the way, I'm not the only one, because now we don't call them soft skills. We call them durable skills or 21st century skills. But what does all that gobbledygook even mean, right? Soft skills sounds kind of weak. Durable skills, you're just kind of like, well, what exactly does that mean? 21st century skills, so it's kind of highfalutin, right? We have to just speak plainly. And the same is true for policymakers, right? They have so many, all of us live in DC. They have so many things on their plate. And even to the best of their abilities, I think we have to make it easier for there to be an entry point for policymakers to do not just the right thing, but the smart thing. And we have to ensure that they understand why it's the smart thing.
Well, the thing is the word. What is the thing? But when I loved your list up there about whole medicine, and it was beautiful. And of course, you had sleep and nutrition and all the things we know about. But really, creative health needs to be part of that. It needs to be on that list.
Can I jump in too? Sorry. Here's the word. Follow the funding. The money is in healthcare in Washington. That's where the money is. Medicare and Medicaid, baby. 140 million people, all right? That's where the money is. And so when I'm sitting here and seeing these incredible presentations and listening to what the NEA is up to and NIH, the fact that we are funding that at the level we're funding is insane. We should be expanding that funding to show in the context of Medicare and Medicaid how those programs can achieve value. And what is value? It's a cost-quality equation. We're going to constrain healthcare growth in Medicare and Medicaid by doing more social prescribed, doing more art therapy, doing more music therapy. That is a really would be a really good way to use our time as a community, is to not be looking for more money. Bits and pieces. $200 million for the end is we call it budget dust in Washington. It's nothing. There's trillions of dollars in Medicare and Medicaid, and you should all be accessing it from my perspective.
Wow. Okay. We're going to talk to you. We're going to have meetings. You're going to be thronged at the end of this.
Thank you all for being here and for sharing your perspective. I think I can talk on behalf of maybe researchers. We are trained to speak very carefully. The number of times I have crossed this caused that from a student's paper and substituted with it is correlated with. Storytelling is not our forte. We are not trained as part of our academic career to learn how to make stories, and just being very careful about what is the relationship between two things that we see. And I see that there is that gap there because it's still, in order to flourish within an academic community, to be able to publish in a scientific journal, we have to follow that same language and same storytelling. That doesn't seem to always apply when we speak with policymakers or people who can move the needle forward. Do you see kind of a way to bridge these two worlds?
I'm happy to start. At Americans for the Arts, we actually have a motto: never a story without data and never a data without a story, right? And so what you all do in terms of providing fantastic research that really provides credibility to whatever that arts policy is very important, no matter how you're saying it. The anecdotal story is equally important, right? Because it does two things. It certainly inspires you because it is coming from the heart, but it also does have the effect on whoever that policymaker is that you're meeting with. And more often than not, I will see them be thinking and even, relate to me what their arts story is. So you definitely need both.
We also have to get the information that you provide to the creative arts therapists. We need to get licensure for the creative arts therapists across the country in every state. We don't have that. And then and if they can earn a living, then we can sort of lobby for them to be really embedded in society. But they are a huge benefit to healthcare. And the few major hospital systems that have brought it in-house have benefited tremendously. I'm thinking of Houston, I'm thinking of Nashville, Cleveland. It works. Right now, it's not expensive at all. So, but you're right. How do we bring these threads together?
The other thing I would add is I think, we should be considering cross-sector opportunities to make some of the research more relevant. A week or two ago, Tushar, when we met in DC, you shared with me the McKinsey report that recently came out. I don't know if anyone's seen this. On one hand, I'm like, well, why would you? Because it's not specific to music and arts. But on the other hand, I'm like, this is exactly the kind of thing we should be talking about, because what the study does is it says that McKinsey and peers are seeing growth in client-facing roles, in roles that are judgment-oriented, that require more customer service and adaptability, interpersonal skills, and that in their interview processes, they are instead prioritizing curiosity, ability to navigate ambiguous situations, and communication skills, adaptability. We know that these are all the skills that people obtain, develop, strengthen through participation in music and the arts. So, and where my mind goes is, this study comes out, or this report comes out, and who's reading that report? The business community, because it impacts the way that they're going to approach their work and their bottom line. Well, I would love for that to be followed with something from the music and arts field that connects those 2 points and makes that feel more relevant in a way that, the CEO of a company may never even consider. But if we can get those kinds of leaders on board cross sectors, just one example with this McKinsey report, I think it'd be hugely important. And I just think we're leaving a lot on the cutting room floor. And that's one case where you show that to me, Tushar, and I was like, this is it. Like, this is a perfect use case of where we could go out of the box.
For one more question. Of course, I can't see. There we go. 2? Okay. Oh, good. 2 questions.
Well, thank you so much to this panel. You've given us a lot of optimism today, which is much needed. And it's like a big shot in the arm for academic researchers in this current climate. The reason I'm saying this is because academic researchers do not know how to do advocacy. We are, like Assal was saying, we're trained to work in laboratories and to be as rigorous as possible and to ask as basic questions as possible. So things like reaching out to your elected representatives or telling people about how to change the agenda of how science, especially as it relates to the arts, is done in this country, is not something we can do. But what we can do, however, is we're all members of scholarly societies. We're all members of societies that eventually talk to things like the National Academies of Science or AAAS or things like that. But what can we do as average scientists to get the 435 people to kind of take our work seriously, because we know that they're not reading our work because we don't write it for them in their defense. But what can we do to make this stuff appear like it's a very serious issue that many people's lives, livelihoods, and society kind of depends on this kind of research? So I feel like we're not doing a great job at this time, but you all can give us some very important advice on how to proceed.
Thank you so much for the question. It's not 435, it's 535. And they all have their own competing priorities. And I'll come back to that in just a minute. Number one, the work you're doing does matter. Very, very much so. When we in Washington are developing a policy to present to the executive branch, my team works very closely with the Secretary's office and CMS on down. We are looking for the best research in the country on a particular issue, and we are citing your research regularly. So that is happening, number one. Number two, the vast majority of lobbyists in DC work at associations. They're not at the big firms working for pharma and oil and big oil and all this. I mean, there's a lot of that too. That's where there's a lot of money that's spent there. The vast majority of us are working for not-for-profit associations representing people like you. And there's armies and armies and armies of them out there. So I do want to give you some hope. How do you get people to pay attention, though? How do you like break through, which I think is kind of really the core of your question? Bend the cost curve in healthcare. It's 20% of GDP. So if you're a member of Congress, doesn't matter if you're Democrat, independent, blue, green, it doesn't matter. You're looking at, holy crap, the Medicare is going insolvent in 2032, according to the Medicare Trustees report by this administration. We got a lot of work to do to bend the cost curve as the baby boomers get older and sicker. All right. So every question in our meetings comes down to, what are you doing to achieve value in the healthcare system? And by value, I mean quality over cost. And one way to do that is to cite the research that you all are doing in the healthcare space.
One other thing that we are pursuing is we're working with NORC at the University of Chicago to carry out some new research. So they'll be using I'm probably going to say all these things wrong, so just bear with me. I know this is your guys' stuff. The AmeriSpeak panel, a nationally representative sample, 1,000 respondents, and we're asking different kinds of questions that I hope will, the results of which may be more usable or relevant to elected officials. For example, trying to back up a claim that I think is true, that music and arts help develop the most essential human capabilities in the AI age. How do we actually show that and prove that? And that could be multiple research studies and different types of approaches. But that's the kind of thing that policymakers will listen to. And I mean, other things that we're asking, for example, if you want to know where people should prioritize workforce funding and economic dollars, we need to give more fuel to that fire so that it's very clear that the skills that young people learn through music and arts education are actually preparing them to thrive in our modern world. And those uniquely human capabilities, I mean, it's not going to be the people that can compete best with machines that will win the future. It will be the people that can best harness and integrate the uniquely human skills into our world. So anyway, I think some of it has to do with like, are there different questions that we can ask and different ways that we can sum up research so that someone like Andrew can pull that out, or someone like me can give a call to the representative and say, have you seen this? Maybe they're not going to read the report, right? But they will be intrigued by something that we can frame in a way that makes more sense to them.
I think we're also at about the place where we need to actually make a case for human skills. It's it's moving very fast.
It's our event next week, which you're all invited to. I'm going to see you there. We're going to have 150 people in the Kennedy caucus room in the Senate with Dr. Oz and Senator Chris Murphy. two people who are just diametrically politically opposed right now. And we are going to announce that our coalition of 70 national organizations is going to arbitrate and be the creative force behind protecting human connection in the context of AI. We're going to develop that regulatory framework, but we need your help to do it.
Brilliant, brilliant. Last question. Sunil, did you have one?
Does anyone else? You go first. You go first. No, you haven't spoken.
Thank you so much. My question is very brief, but it connects to both of these questions. There's a huge incentive to in academia for the individualized nature of doing research. And when I say individualized, that could mean me as an individual or my research team, but it doesn't reward the sort of things that we're talking about on the grand scale when it comes to academia, rewarding through promotions and things like that. That's sort of the elephant in the room as an academic myself that I would love to find a way to get beyond if universities are going to continue to be one of the places where this work continues to happen. We're having two completely different conversations where we're ships passing in the night. Do you have any suggestions for how we can think differently about incentivizing researchers to think cross-disciplinarily? Thank you.
Jason, still here? Is Jason here? Jason King? He's gone. Okay, because we had a conversation.
I'm certainly not in this space. I'm not an expert to speak on it, but I do think that it does go to a conversation that I was having at lunch and just generally we do need to we tend to speak to each other, right? And so whether it be in the arts space, whether it be in the arts health research space, I do think that we don't do a good enough job in terms of that kind of like cross-sector advocacy, that cross-sector talking to each other, right? For example, I'm going to speak next week at the PTA, and that's something I should have done a very long time ago because, they are the parents who are advocating for arts education, whereas I'm the arts guy who, has skin in the game. So just from a general perspective, that's why I think that, the collaboration, for this cause is just incredibly important.
The other thing we're facing now are cuts to federal funding for universities and colleges for any degree that doesn't prove after 4 years that people who graduated can make more money than those who haven't had a college education. And that's going to hit the arts very hard. It takes people time. They're just whole careers that will go away, I think, unless we can do something about that. I think we are out of time, unless Sunil, did you want to just say one thing?
One thing? Okay. Yeah, thank you. Everybody knows I can say more than one thing. No, but I think one group that we kind of have missing, and this is a really great conversation. I know the focus was education, but somebody who can help us design like healthcare cost utilization studies around the arts, and really to get at the cost factor, the opportunity cost stuff. And the thing I was going to ask, the question I was going to ask Andrew, if you have time, is just maybe if you don't have time, we can talk about it afterward. Do you think workplace wellness is an area that you see a lot of interest in this? Like, is that an untapped area for businesses to see this as saving their costs in terms of benefits and so forth?
Yes, but it famously doesn't save money. It just doesn't. And there's a famous example. I was very involved with the Affordable Care Act. And I was very fortunate to be in the center of all that. And there's a very famous testimony done by the CEO of Safeway, who had supposedly the best program in the country to provide incentives for their employees to prevention, chronic care management, lifestyle, the whole thing. And it was a huge donut hole in savings. And so CBO, the Congressional Budget Office, highly unlikely that they're going to score quote unquote savings for that. But that doesn't mean that it's not important. So the answer is yes and no. So I think there's a lot of companies that are doing that. And there's a lot of different flavors of that, of course. And going back to the Elevate model at CMMI, just 10 seconds on this because it's important. The Center for Medicare and Medicaid Innovation is an agency of Medicare and Medicaid that has $10 billion every 10 years to just test models, to test innovative ways of saving money in the Medicare and Medicaid program and improving quality. Elevate, is an acronym, is a long acronym, is one model in CMMI. It focuses on lifestyle. So going back to your points you're making in your remarks, which I thought were right on target, this administration, say what you may about them, this administration is testing really innovative ways, and they're leaning way into prevention, wellness, chronic care management, and some of the more, I'm going to say it, non-traditional ways of providing care and support to people to improve health outcomes.
Well, wonderful. Thank you, everybody. This is fantastic. Thank you, Assal.
I'm just going to thank you, everyone, for being here today. I hope that sparked interest, inspiration. Thank you from the fantastic staff and students of the Brain and Creativity Institute. They put an amazing day together. And safe travels. Come back again next year. Thank you.